हेलो हेलो टेस्टिंग 1 2 3 हेलो चेक।
हाँ हाँ। अच्छा, गेस पूछ रहे क्या?
हेलो हेलो
Good morning, everybody. I request all the participants to settle down. A heartfelt good morning to everyone gathered here and those joining us online. It's a privilege for us to extend a warm welcome to one and all present over here with immense joy. I am Manasa, and this is my co-host Samriddhi. We are very grateful to be able to host you today. On behalf of the whole organizing committee, we take immense pleasure in welcoming you all to the inaugural ceremony of the annual Symposium of PMRF 2024 organized by IIT Indore. Today, we have with us the Honorable Chief Guest, Professor Devangvi Khakar, Director of IIT Indore, Professor Suhas Joshi, NCC Convener, Professor Deepa Venkatesh, and the Institute Nodal Coordinator, Professor Ishwara Prasad Kurimile. We request the dignitaries to occupy the stage. We will commence the event with the ceremonial lighting of the lamp. This auspicious ritual symbolizes enlightenment, knowledge, and wisdom. I now request all the dignitaries to proceed with this ceremony.
Thank you. Following this traditional ceremony, I invite Professor Deepa Venkatesh to deliver the welcome address and to introduce you to the PMRF scheme, its goals, and its status. Over to you, ma'am.
Good morning. My name is Deepa Venkatesh. I work in the Electrical Engineering Department of IIT Madras. I'm the team lead for the National Coordinating Center for the PMRF. It's a great pleasure to be here. Thank you for the organizers to invite us here. And have a pleasant responsibility of introducing PMRF to this crowd. But of course, all of you are very familiar with PMRF. You're all PMRF fellows. Just to make sure that we are all in the same page about the program and where we are and where we are heading, I'll take this opportunity. This was initiated, the program was initiated in 2018. Professor Desai, who's here, was probably the first national convener for PMRF. And after that, we moved on with IIT Delhi as the convener. And in 2022, IIT Madras became the National Coordinating Institute. The idea was to initiate a program at the research level for improving the quality of research in higher educational institutes. The key differentiator for this PMRF fellowship is, in addition it to being a rigorous selection process, there is a periodic review, a yearly review for all scholars, and the fellowships get decided based on the review. There is a research grant of 2 lakhs per year in addition to the fellowship, and if you compare the, volume of fellowship money that is being paid in terms of dollars. If you do a direct dollar conversion, it looks smaller. So here you have several fellowships lined up. But in terms of, purchase power parity, PMRF is one of the most, highest paid fellowship across the world, right? What is expected out of a PMRF fellow? In general, carrying out high quality research in the topics of national importance, publish in high impact journals, conferences, engage in translational research, depending on which area of research they are in. A very important responsibility of a PMRF fellow is also to impart technical knowledge, to promote research, interact with students outside their own institutes, at least for an hour per week, to promote the culture of STEM in general and research in particular. This is in addition to the teaching assistantship in the respective granting institutes. So to give you how we organized ourselves, so of course this is funded by the Ministry of Education. There's a national coordinating committee of comprising 8 directors, which is also probably rotating every 2 years. The current committee constitution is what is shown here. We as internal operations committee report to the NCC. So there is an internal committee which includes several deans and the team lead. There are 38 granting institutes today, and each granting institute gets represented by an institute PMRF coordinator. There are, we organize our research for convenience to 10 broad areas. So the 10 nodal institutes from among the granting institutes are chosen by rotation again once in 2 years. The job is to, responsibility is to review the applications and also the progress in each broad area. And they get represented by nodal coordinators and subject coordinators, because the broad areas are really broad as the name indicates. So for each sub area, there are subject coordinators, which also have subject panels and several reviewers. The last review, we had close to about 2,000 reviewers talking to the scholars in our whole review process. As I said, the way forward was set, the goals or the bar was set initially by IIT Hyderabad and then IIT Delhi. We are following the path. The National Coordination Committee meets 4 times a year, and we report for all the academic financial matters to the committee. The convener is our director, Professor Kamakoti, and Professor Banerjee from IIT Delhi, Professor Murthy from Hyderabad, Professor Rangarajan from IIC Bangalore, Professor Gaur from IIT Jammu, Professor Uma Maheshwar Rao from NIT Rourkela, Professor Gauri Shankar from IISER Mohali, and Professor Yogesh Singh from University of Delhi are the members of the committee who give us directions on how to take this forward, course corrections if necessary, approvals, operational issues, give us guidance on how to make the program more impactful. The granting institutes are 38, as I said earlier. In addition to IISc and all the IITs, 23 IITs, we have the 5 IISERs and institutes which come under the NIRF rank 25. which includes NIT Trichy, BHU, Jamia Millia, JNU, University of Delhi, University of Hyderabad, and Aligarh Muslim University. Between them, the numbers indicated in bracket are actually the number of fellows who were given fellowships in these institutes. 10 nodal coordinators without whom the program cannot go ahead. For this year, last year, we had a change in the nodal coordinators. And I take this opportunity to thank all these nodal coordinators who have put in, or you are continually putting tremendous effort to maintain the quality of this program. In terms of selections, we have made 3,688 selections over several cycles. So you see most of the selections have happened since almost May 2020, when we had some change in the way we started operating PMRF, of which 64% is male students, women students, and 36% women. We had two modes of entry, direct and lateral entry. Lateral entry is for scholars who are already in the system, who come up with a very solid research proposal after spending time in the institute, versus direct entry, who are fresh PhD scholars. Currently, we have close to 3,000 active fellows. There are 85 of them who have submitted their thesis. 448 would be submitting very soon because their fellowship has ended, but the last final stages of thesis preparation. There are, in 2023, we identified out of all that 20 exemplary performance students. Probably this number is not right. It is 1 and 2, comment 1 and 2, of which maybe about 500 of them would have been about comment 1, which is recommended with commendation students. We have to move 64 of them to the institute fellowship, and we had to relieve 36 of them even before the fellowship got ended because of the non-compliance to the expectations of PMRF. In terms of distribution, this is a heat map. Interestingly, 22% of the fellows come from West Bengal, and the rest is all distributed in the country. This is a distribution in terms of different disciplines. Civil, electrical are the bigger, and chemistry are the bigger, broad areas. In terms of impact, I know impact in research is really not quantifiable. It is more of intangible outputs that will come in, but we are keeping stock of these numbers. Overall, the number of publications obviously has increased because the number of fellows have increased. In terms of journals, conferences, I must say that the research grant helps our scholars to travel without the restrictions of the institute finances. So the number of conference publications are way higher than the non-PMRF fellows. There are 404 patents that are registered or granted. A big impact our scholars are making in terms of teaching assistantship. So these are showing hours in the granting institute and hours outside the institute. Scholars are putting in a lot of effort in promoting research. And this is one of the intangible outputs that PMRFs have contributed. We have all the funds that get dispersed through the PFMS portal now. So everything is, even all our metadata is available in portal. If you go into pmrf.in, all these details are updated live in terms of impact. All the operations are through a central portal right now. And this is supported by a team. 2 of them are here. And that concludes my talk on about PMRF. Now, I would like to also add a point here that we have exhausted all the fellowships that were allocated by the ministry. In fact, 3,000 were allocated. We have managed to fit in about 3,700 in the same budget. The next phase for PMRF we have applied to. There was a committee, which is a 15-member committee formed to look at the impact of the current PMRF or the way it is operating and have suggested some changes. So we have proposed a revised guidelines to the ministry. We hope, we are very positive that that will get approved, and we are waiting for the approval. Thank you.
Thank you, ma'am, for the brief. I would now like to invite Professor Suhas S. Joshi to address the audience and introduce our distinguished chief guest, Professor Devang Khakar. Over to you, sir.
Good morning to all the PMRF fellows, and welcome to the institute. I'm sure our team at IIT Indore has lined up almost like who's who in the fields as speakers and as mentors to you. I'm sure you will participate and take advantage of their presence. One such eminent person is Professor Kakkar, who has kindly agreed to be the chief guest of the program. Thank you, sir. We have been trying to bring him to the institute for last 2 years, but now this time we succeeded. Professor Deepa and Professor Ishwar, who is at the grassroots level coordinating everything. We also have Professor UB Desai, former director of IIT Hyderabad here, and Professor Muralidhar from IIT Kanpur. He is also there. Thank you for coming. There are other eminent guests who will come and will deliver their talks. At IIT Indore, we are sitting into this particular building, which is one of the best buildings, awarded rank 3 in the country among the buildings built by CPWD, government buildings. We all know that we all have perception that the government's agencies do not work, but then this is one of the best things the government agencies have done for us, that they have created a building which is kind of award-winning kind. At IIT Indore, we have several programs, BTech, MTech, MS, research, PhD programs are there. The ones which are written in red are the ones which we have started last year, rather 2023 academic year. Besides the regular programs, we have started maths and computing, chemical engineering, engineering physics, and space science and engineering, 4 BTech programs at one go, and 6 MTech programs like applied optics and laser technology, computer science and engineering, structural engineering, water and climate sustainability, biomedical and defense engineering. So about 10 programs we started in one single academic year. We also have something called a MS and data science and management jointly with Indian Institute of Management. It's an online program of 2 years, and it draws fairly good amount of professionals starting from 2 years experience to 15 years of experience. We have another unique program which is called as Executive MTech program in hybrid vehicle technology, which is especially coined for or designed for Volvo Eicher in the vicinity. This is the biggest company, Volvo Eicher. We have more than 2,800 students. We have total faculty strength of about 225, including those who have been given offer letters recently. And we are ranked 14th in the NIRF ranking and 454 in the QS ranking. This is one important initiative of the institute, which we call it as Maker Space, where curiosity connects creativity. And that is where you can see this is the course which is introduced for first-year engineering students. And all of them are actually designing some kind of a device which is mechanical, electrical, 3D printed, machined, formed. All processes, manufacturing processes are there, laser processes are there, 3D printing is there, everything is there, but they actually make a product rather than learning the tricks of the trade. And this year the concept was line followers. So they make a device which follows a line, and then it can have multiple applications. So you can see that this particular table, these are the group projects of, there are so many applications they have evolved for line following. And the students are very novice to programming, electronics and oscilloscopes and soldering and welding, everything. But they learn in one semester all these things and actually make the device. The first thing they do is the stitching their apron. They also know how to use the stitching machine and actually stitch their own apron. Each student has to do, the first assignment is that. So it's like self-doing and do it yourself kind of program. Just coming to one small thing, but the important one is these days we find it very difficult to retain the students and their attention in the classes, in the academics. We also find difficulty in getting retaining and motivating the PhD students also to do a good work. So that's also there. But since you people are now graduating and going to become an academician, some of you are going to go to industries. This is very important that now you have to look from the other perspective, that you are finishing, but now what is there in store for you? That how do you enhance the learning experience of the students? The students find that many times that the classrooms are boring and things, they don't want to learn certain things, and we want to put those things into their mind, and that's how there is a competition. They reject and we try to force it, and that's where enhancing the learning experience of the students is very important. And from that perspective, National Education Policy 2020, which has been implemented in the country, provides a lot of framework in developing many such avenues or creating such avenues where the students can pursue their own interest, their direction. They can choose their direction and they can go in that particular direction. So we have made some attempt at IIT Indore for enhancing the students' learning experience. I thought you guys are prospective teachers and industrialists, so I would talk to you for a few minutes about this. So this is the journey of first, second, third, and fourth year of the students. And we have added several new avenues to the students right in the first year itself. So as I mentioned, the makerspace is one part which is actually grabbed and which is taken by the students. Earlier from the workshop, the students never used to come, but the workshop people, they are telling me that the students are not going out of the makerspace these years. They come there day and night. There is no time. They work in the night also to complete their project. So the situation has actually changed. We also do what is called as a Genesis program. We derive a lot of inspiration from IIT Kanpur. Because my son is in IIT Kanpur, so we actually got to know a lot of things from there. So this Genesis program is a 6-day ice-breaking program, which consists of a large number of activities. The students are not going to study anything. Morning 6 o'clock to night 6 o'clock, 8 o'clock, they are busy in activities for 6 days. Sports, culture, yoga, team building bridges. We have given this time a task of building the wooden planks and the ropes and a bridge over some 15 meters. They have to make a bridge with the bamboos and all that. And so a kind of a team exercise for some 100 students can come together and do it for a half a day. Forest walk is also another important exercise in this. So a lot of exercises. This year, actually, we have 3 military schools near IIT Indore. And one of the schools actually took all our 500 students into their campus. And they gave one-day training, including a firing. Some of the students got an opportunity to do a firing also during their program. So it's a, bringing them out of their mold and, ice-breaking session we do. We have electives right in the first semester. All the courses are not compulsory. We have made small courses of thermodynamics, we have made small courses of applied mechanics, and several such small courses, and they can choose those small courses instead of, making everything compulsory right in the first and second semester. Second year, we have some another aspect which is called as the societal aspect. All of us have to pay back to the society. Each one of us has earned our degrees through the taxes and the things paid by the citizens. So we have to give back something. So we have started a rural immersion program, design thinking for rural technology. And again, from second year, third semester, fourth semester, they have many electives. That is what we have started. So we have revised our curriculum that in the second and third semester, I told our professors that they should have the most attractive electives in the second and third semester. That is why their interest in the core areas will remain, or interest will actually grow. And that's how the internships also are there. Those are actually given credit. Third year, again, in the makerspace, they do a capstone project. They try to solve an industry problem. Then we have a course on foundation of entrepreneurship. Again, the electives and entrepreneurship internships are there. In the final year, we are again having a big project, final year BTech project, field trials. The project can be, because of the earlier experiences, the final year BTech project can be far better. We expect that the students will actually develop a prototype and it can actually have a field trials, and it is ready for taking it out of the institute. We are also thinking of a course on systems engineering, where the integration, everything comes together, and then you think of the wholeness rather than a part of the system. In NEP, we have a concept of academic bank of credit. So it is like this, that if you take up the courses which are co-curricular, not exactly matching to your curriculum, say for example, internships, immersion programs, design thinking, foundation for entrepreneurship. If you take those courses, you can deposit those credits into the credit bank. And by the time you graduate, you can exchange those credits with any of those institute or departmental electives. So we have started a concept of, it is there in the NEP 2020. That concept we have adopted, and from this 2023 batch, this concept of academic credit bank has been established. So just in a brief, I thought I will give you some glimpses of various initiatives which we have taken. Nevertheless, I welcome you again to the institute. We have a beautiful campus. You can roam around in the mornings and evenings, but wherever there is written that forest area, do not cross, please do not go on that side. We have some wild boars, wild animals also in the forest area, but they don't harm anybody. So far, nothing has happened. But still, I think don't go into those directions. You can roam around into the other areas. So thank you and welcome again to the institute. Thank you.
I request Professor Joshi to please introduce our distinguished chief guest and welcome him formally.
As I said, it is my pleasure and privilege to welcome Professor Khakkar. He was the director of IIT Bombay for more than 2 terms, more than 10 years. And I had a privilege to work with him for a long time, initially as head of the department, but later as Dean of Alumni and Corporate Relations. And it was a great learning experience for me in many ways. Professor Khakkar is elected fellow of 3 major science academies of the country: Indian Academy of Sciences, Indian National Science Academy, and National Academy of Sciences, as well as he is the fellow of Indian National Academy of Engineering. He is also bestowed with prestigious prize of Shanti Swarup Bhatnagar, Prize in 1997. He has also received Best Teacher Award in the IIT Bombay, which is also considered to be very difficult to get in the institute. Professor Khakkar works on the research in the domain of polymerization of rod-like molecules, and his work is reported to have assisted in wide understanding of the discipline of polymerization. He has been instrumental in taking up many initiatives at IIT Bombay, one of which I was associated was the Development and Relations Foundation for engaging the alumni across the world. IIT Bombay had 70,000, 65,000 to 70,000 alumni. And how do you engage them professionally? So this foundation has actually started by Professor Khakkar, and it was a very difficult task. There was a lot of resistance to pay very high salaries to the professionals than the salaries of the professors, and sometimes many of them were actually drawing the salaries higher than the director's salary also. So putting up such institution of professionals into an academic institution is a very big task in our country, and that he has started. You will not believe today this foundation is able to get over 200 crores per year as the alumni donations for the institute. So when I was there, we started with a very modest thing, was 18 crore, 33 crore, 50, 100. We crossed 100. And now, after 2 years, I hear that they have crossed 200 per year. And a recent donation by one of the alumnus, Nandan Nilekani, of 350 crores for the institute is actually the groundwork which was laid by Professor Khakkar in the institute. So that was one of the major initiatives. Of course, he was again instrumental in IIT Bombay Monash Academy, which is a major academy where more than 200 PhD students work jointly with Monash, University of Monash. And that is where such a large number of PhD students joined together is rare. I mean, there is no other such kind of a collaboration anywhere where two institutes have come together and they have such a large scale collaborations. Well, there are many things I keep telling my faculty members what initiatives he has taken, and they are all aware of. But I think he's a person of a very grand vision and a wisdom. So we are all the beneficiaries of that. I request Professor Khakkar to enlighten our PMRF fellows. Thank you.
So, thank you, Professor Joshi, for overly kind introduction. And now that you've given such an introduction, I'll have to actually say something to match that. First of all, I want to thank the organizers, Professor Joshi, Professor Ishwar, for inviting me. And it's really a pleasure to be here. One is wonderful to be on the IIT Indore campus. I've been here once before, and that was in 2009 when the foundation stone of this institute was laid. At that time, I was the sort of in-charge director of this institute because IIT Bombay helped to set up this institute. But now when I come and I see this, wonderful campus and this beautiful auditorium and all the facilities that have been built up, it's really a great pleasure. And of course, it's wonderful to come and have a chance to speak to all of you who are the best PhD students of our country. And so hopefully I'll be able to say something that will be of interest to you. And happy to see Professor U.B. Desai, a colleague from IIT Bombay, and then of course went on to do great things at IIT Hyderabad. Professor Murlidhar, formerly a colleague at IIT Kanpur because I started my career there. Professor Deepa, colleagues from IIT Indore. I got a chance to meet many of you yesterday, and I hope to see some more today, later. And of course, colleagues from other IITs and PMRF. So very warm welcome to all of you here. So I was given this topic, which is what entails cutting edge research. And I think all of you know that. I mean, I don't have to say, because all of you have been already doing it and you have been selected. So I thought that, I will sort of say things that are adjacent to this basic enterprise of doing research. And this is the outline of my talk. And, one of the important things about research is creativity. And so I'll say in the beginning a little bit about these different fields of activity, art, science, technology, and design, and, how they approach their work. And then I'll spend some time, just highlighting some of my impressions on how research gets translated into technology and business, giving some examples. After I've finished my administrative duties, I've gone back to the department, and for the last 5 years, I've been, back doing what professors do, teach and research. And, I've developed some ideas about what we should be focusing on. And so I'll say a little bit about that. And then finally, I'll just give a couple of slides on what I think is really good, what is important for good research, and then conclusions. So, scientific research is generation of new knowledge. It's always in some sort of framework. So, and then, of course, there's this huge body of knowledge. So you have to be aware of that. So, you're doing something new. And an example of this could be synthesizing and characterizing some new material. Also, there's this big effort of developing models, theories to quantitatively describe observed behavior. And there are many examples of these kinds of theories. And then, of course, applying this new knowledge to address the needs of society. So it could be products like the invention of the transistor or airplane. It could be processes like the great Haber-Bosch process for ammonia manufacture. And it also could be policies. And, in today's context, policies related to the environment are becoming extremely important. One which was signed by all the nations long back was the Kyoto Protocol. Some of you may know about this. So this was essentially an agreement between countries to limit the use of fluorocarbons so that we can protect the ozone layer, which is needed because it cuts out the ultraviolet radiation into the atmosphere. So that was a very successful protocol. And now, we've been having these meetings to limit greenhouse gas emissions. COP28 was the last one in Abu Dhabi. And really the goal is to eliminate the use of fossil fuels. And all of these types of policies are informed by science and research. So really, since the one word that I've made bold is new. So you have to come up with something new. And so that is a creative process. And it really helps if we understand, different fields, we can get ideas from those fields and what are the different approaches. So let me just say a little bit about that. So, if you look at a comparison between creativity in art and science, so art, if the key word for art is create, and the key word for science is discover. Science is essentially governed by the scientific method, where you do either some experiments or whatever and test out a theory. If it gets validated, well and good. If it doesn't, then the theory is discarded. But in art, there is no method as such. And art is defined by the community of artists. They will decide this is art. In science, we build on existing knowledge. And, you can see this graph where there's slow progression as the knowledge builds up. And then suddenly there's some new discovery and there's a jump. And so this is kind of, linear progress that happens. Whereas in art, it's completely different, where, there's one movement of art that starts and then a brand new movement starts, which is quite different from what there is earlier. And so there, in art, you have sort of, rather than building on, you have breaking with what is the tradition. So you always want to do something quite different. Similarly, if you look at what is engineering and technology, the key word here would be invent. And the basic idea is to design and build complex systems, products. And it is a combination of science, but there's some art involved, and I'll try and explain that. And of course, economics. And typically, these kinds of, or this field is characterized by this kind of invention obsolescence cycle, that, some new product comes up, it's quickly adopted, reaches saturation, and then when something new comes to replace it, that product is eliminated and something entirely new comes. And, if you look at music systems, we started with phonogram, record player, cassette player, Walkman. I mean, this is for people of my age. Many of these things you may not have heard of. CD, then there was iPod, and now everyone listens to music on their phones. So, and each stage now, it's really hard to find a record player, which was a very common thing in people's homes at one time. And finally, design, where you have a combination of function and form. So there's engineering and technology behind the product, which helps it work. But at the same time, there is some kind of art aesthetics to make that product appealing. And so design we can think of as a combination of art and technology, and it applies to processes, products, policies, whatever. And finally, there is innovation, where, you through an invention, you come out with some new product or process. Usually it is to meet a customer need or to create a customer need. That, sometimes we didn't even know that we needed a mobile phone. So when the mobile phones first came, I told my wife that I'll never use, why do I need to carry a phone around with me? And, now I've got one in my pocket. So obviously they managed to create a need for that. And this is also characterized by continuous improvement. And I'll give examples of this. But technology is an enabler, because you might just use many different technologies to achieve that. But behind it all, there is some kind of economic calculus that, it should make a profit. And then finally, there's this idea of science and art. Professor S. Chandrasekhar was a Nobel laureate in physics. And he wrote this book called Truth and Beauty, Aesthetics and Motivations in Science. And which the basic point is a scientific theory, a good scientific theory also is beautiful. And I put beautiful in inverted commas. In the sense that, of course, you look at a theory, there's nothing really that beautiful about it. It's just a bunch of equations or something like this, which, to a person who's uninitiated, it's just there's nothing, no beauty in that. But a good scientist is able to look at a theory and able to recognize good science within it. And as a result, it appears beautiful to them. So in this sense, you can say that there's a combination of science and art. Then you can think of technology and art. And here is a photograph of a chemical plant, which has, lots of components. And, to make such a plant, you have to do many things. And usually at the core of this chemical plant, there is a high technology component, usually protected by patents and other IP. But, to make such a plant, which is so complex, there is so many design choices that the good designers, they have a feel for what is a good choice. And so though there is technology, but there's also some art involved in actually coming up with a design like this. Similarly, you can look at, these kinds of designs which have a lot of technology, whether it's an aeroplane or one of these chips. But again, there are a huge number of design choices. And so you actually have good designers who can actually figure out what kind of choices would be most appropriate. So in that sense, here you have a combination of technology and art. And then there are some things which have technology, but then the art component becomes quite important. And here I'm just showing two very popular phones. At one time, BlackBerry was one of the most popular smartphones, or the only popular smartphone, you can say. And then, you had the first iPhone, which came out. There is a lot of technology in both of them that, there was this touch screen and lots of very nice software and user interface and so forth. But there's a high art component, which makes this type of device so appealing. So, you can have all this combined. And a lot of these ideas that I'm talking about, they are in a nice book that has come out called Augmented Thinking for a Complex World, The Nexus, the New Convergence of Art, Technology, and Science. I've kind of cut the thing a little bit. It's by Julio Otino and Bruce Mao. Otino is a chemical engineer. Also, he was my PhD guide. And Bruce Mao is a very famous designer. And, one of the things that they say is, how can we identify ways for finding and implementing creative solutions? And one of the things they sort of recommend is that we should augment our thinking spaces. Then we can expand our potential. So if you think like an artist, it's very different from thinking like, let's say, somebody who's doing technology or science. Okay. So that was the first part of it, where I just wanted to expose you that, we are all, I think most of you are in science and technology, but there are other fields also of endeavor, and they work in a very different way. Now, let me just say a little bit about technology and commercialization, because one of the big thrusts today is to try and see that how this research that we are doing in academia and also in research labs, how can it actually translate into something useful? And so what are some of the paths that we can take? So here again, I'll come back to this type of smartphone design and to say that, okay, you can have good technology, but it's not necessary that you will succeed in the market. So, between Nokia and BlackBerry in 2007, they had more than 90% of the this mobile phones market. And then Apple came out with its iPhone. But, when it first came out, though it made a big splash, the sales were not so good. But it was only after the App Store, where they were selling all these software which could customize your usability of the phone. Once that was established in July, that the sales skyrocketed. And today there are more than 1.8 million apps in there, and huge amounts are being made by those who sell apps on that store. So the point here is that though there's a great product, until this service of apps came, this product didn't really take off. And so this is one of the things that whoever is in charge of trying to develop products, you have to have your be very aware of what customers may want to be able to make a success of what you're trying to do. The other example I'd like to give is of Raman scanners. So Professor C.V. Raman discovered the scattering of light by molecules and got the Nobel Prize in 1938. But really, based on that principle, Raman scanners started coming only in the last 2 decades. And now, you can get, even handheld Raman scanners to see what is the chemical composition of materials, or, you want to do analysis, then you can get these kind of huge lab things. So the basic point is that the path from science to technology can be quite long. And, many other things have to be developed before that scientific idea becomes into a product. Another project which was, it was just thought of as a science project. And this was this Human Genome Project. I don't know if any of you have heard of this, but between 1987 and 1990, an international project was initiated from the US at the cost of about 3 billion. And there were participants from countries around the world. And the idea was just complete mapping of the human DNA, which had never been done. And at that stage, it was considered an impossible project, that it just couldn't be done because, the human genome is so huge. But as a result of a large number of innovations, the project actually got completed well before time. And though it was a pure science project, there was no expectation that something will come out of it. There were a huge number of spin-off benefits. The technology for sequencing has been continuously improving, and it's following, Moore's law, which is saying what is the increase of the speed of computers. This cost is going down just like this. And then it has given the possibility of things like personalized medicine, discovery of drugs based on, the genes, disease identification. People are looking actually at evolution and migration of humans, that they actually do DNA testing of huge populations around the world. And then they say, okay, this group came in here and so forth. So, for example, there's been large scale mapping of the Indian population. And so we know what the origins of people are. And in fact, what is now well established is that we all came from Africa long back, but we are all from there. And then many new techniques came up. So the basic point I'm trying to make here is often the connection between science and technology is unknown when this project starts, but then, the opportunities just blow up. But then there can be different kinds of sort of technology development, you can say. And an example of that is this evolution of the automobile industry in Japan. After the Second World War, the Japanese market had only copies of US cars, and nobody thought very highly of them. But between 60s and 80s, there were a huge number of process innovations, and things like lean manufacturing, and just the kind of processes that they put up in for manufacturing. They developed a huge reputation for quality and reliability, and slowly the export started. And then by 80s and 2000s, there was a lot of product innovation. For example, Toyota came up with the electric hybrid vehicle, which has which gained a really huge mass market. And then, of course, then they went into very most expensive cars. And today they are in a dominant position. So here the story is that, technology is known broadly. Everyone was making cars, but it's through small innovations, continuous improvements, building quality that you can actually gain a lot of success. Then let me just say a little bit about technologies that are related to one of the big problems of today, which is climate mitigation, which is today's urgent need. Now, two of the technologies that are related to, which I'll just speak very briefly about, that we want to reduce fossil fuel. So in electricity generation, we can reduce fossil fuels by using solar photovoltaics. Now, those are being now widely used. Now, this was discovered in 1887 by Hertz, and then theoretically explained in 2005, and people have been building photovoltaic cells since then. And then if you want to reduce fossil fuel use in mobility, one of the technologies that's proposed is to use electric vehicles using lithium-ion batteries. Lithium-ion batteries were first demonstrated in 1974 by Whittingham. The modern variant was produced by Goodenough in 1980, and the commercial battery was made by Yoshino in 1987. And these three people got the Nobel Prize for Chemistry in 2019. So now the question is that, the discoveries were made long back, but how has this thing evolved? And so let me just show you this graph. So obviously you can't read anything on this, but this is a graph that is produced by the National Renewable Energy Laboratory in the US. And they have tried to put down, the solar photovoltaic cell efficiencies as a function of time. And this graph starts in 1975 and it goes on till about 2023 or something like that. And, each of these colors is some different technology. And the basic point is that, if you look at the lowermost point, the green line, green open dots, the efficiency in 1975 for that one is something like 2%. And in that time, this purple line, which is some product from the IBM Watson Research Lab, that was around 20%. But if you look today, the maximum that we are getting is about 48%. That is huge. That means half of the, energy of the sunlight falling on the cell is converted to electricity. And so the reason I wanted to show this is that, you can see all these little bumps going up in each case. So each time there's a new development, the efficiency gets pushed up by a little bit. And, you can see how, because of this pressure of having, more and more efficient cells, there's been a continuous series of innovations which has pushed up the efficiency of the photovoltaic cell. And as a consequence of that, not only has the efficiency gone up, but manufacturing processes have also improved tremendously. And so in 1975, the cost of a solar PV panel was more than $100 per watt. And today, the blue lines show this. It's coming to about $1 a watt or less. So more than 100-fold it has come down. So this is how these technologies evolve. And once the cost comes down, then, you can see the way that, the capacity is increased. And, from almost zero in 2005, we are at something like 800 gigawatts. But it's still only 3.1% of the global energy generation. And so there's a long way to go. Let me talk a little bit about another technology that I mentioned, which is lithium-ion battery. Now, one of the important parameters for these batteries is the energy density. That is how much energy can you pack into a certain volume. And so this is watt hours per liter. And in 2008, it was 55. And 2020, it has gone up to 450. So through innovation, through scientific research, you can make a huge difference, a 9-fold increase. Again, there's a long way to go because what they're trying to replace is gasoline, which has a very high energy density of 9,700 watt hours per liter. But even this improvement has made a big difference, and the costs have also fallen. It says lithium-ion battery costs have fallen by 98% in 3 decades. And then the number of electric vehicles have gone up in this way. And there are now more than 10 million vehicles in the global stock, but still it is small. It's only 1% of the global stock. And in India, of course, we don't see that many electric cars, but there's been a tremendous increase in the number of two-wheelers on, and there's, this article says that in 2022, the sales increased by 132%. So, this is the kind of, so basically by showing those two examples, I wanted to just explain that, research makes a difference. When you do your research, you can translate it into some innovation, and it really makes a difference in the usage of the technologies that you're looking at. Now, you're all doing PhDs. I mean, not the ones in the front rows, but all of the people in the back are doing PhDs. I also did PhD at some time. So, when I thought I'll share some of my experience. When I was doing my PhD, I was working on a certain problem on fluid mixing. And at that time, there was a huge, excitement because this idea had come about that some types of differential equations had chaotic solutions. And in fact, there's a scientist called Lorenz, who in those days, computers were very difficult. He was a climate scientist, and he had built a very simple model for the climate. And it was giving, essentially it was a nice equation, but the output was completely random or chaotic. So, we were all very excited, and we wanted to see, can it apply to mixing? Because I was looking at fluid mixing in those days, mixing of very viscous liquids, like let's say polymers or something like this. And so then we started looking at the mathematics of it, and my guide and we started reading about the mathematics of these kinds of chaotic systems. And I don't want to say anything more than saying that if you want to understand fluid mixing, you have to figure out how fluid particles move around in your system, and they are essentially governed by some differential equations. And it turns out that if you have a flow which is two-dimensional and steady, then you can never get very good mixing. However, if you have time periodic flows or three-dimensional flows, then you can actually get chaotic motion. And so one of the systems that I divide, so before I go to that, here, I mean, those of you who want to try out something like this, you can look at the simplest example of this type of chaotic system. It's called a logistic map. And so it says that if you give me any position X, then I'll tell you what that position will be at the next iteration. So if I start with X0 equal to 0.5, I can plug it into the equation, and A is some constant. And so if I plug it in there, if I put in X0, I'll get X1. And then if I plug in X1, I'll get X2 and so forth. So in this way, I can, even just I did these calculations using an Excel sheet. It turns out this very simple equation gives quite interesting behavior. So if I take the parameter A to be 1.2, then it starts at 0.5 and then it just kind of goes to a constant value. If I put A equal to 3, then it starts oscillating, but then eventually it goes to some steady oscillations with a fixed amplitude. But if I go to a value of 3.99, then the output from this function is just random. So this is what is chaos. And you can try this out and play around. It's very interesting. But so I wanted to see, can this type of thing be applied to fluids? So one of the things that I devised was this kind of mixer. So there are two plates in a pipe and the pipe is rotating. So, the flow goes around in each half, like I've shown here. And in the next half, you just rotate it by 90 degrees and it again goes around. And then if you follow a fluid element as it's going through many of these, like a large number of these elements are added on, then, you get this kind of behavior, which is shown on the left, that the fluid particle just takes very complicated paths. And in some places, the motion is chaotic, where, you can see all the points are all random. And in some parts, it's very regular. And so if you then imagine that, okay, I'm looking at only a cross section. So what does it look in 3D? Then you see this picture there, that, you have these tubes, which are sort of regular motion where there is no mixing. And then there is the other part where it's chaotic and it's well mixed. And a later student came and did some experiments. And this is like two views of the same thing. And, you can see those black lines. Those are the plates. You can see the edge of the plates. And you inject one orange line and one yellow line. Now the orange line is in the chaotic region. So you can see the line is completely mixed up. But the yellow line just goes out as it is. So, this is some idea that, okay, you can generate chaos in systems, you can mix. And now you go and look and do a patent search, and there are many new kinds of mixers being essentially devised using this concept. So this is again something that came from mathematics. We did some engineering kind of thing, and then now it's being implemented in a wide scale. Okay, so the last thing I want to talk about, commercialization. I told you about things like evolution and all, but how can you, now that you have got this idea, you have something that works, how can you actually get it out into the market? Well, one way that you can do is to actually license your technology to an industry. But over the years, what I've found, it's extremely difficult to do this. Because unless the company is working in exactly the same area, they're not able to absorb what you have developed. But a very nice way that has proved to be quite successful, not just in India, but all over the world, is through this idea of startups. So startups are a great vehicle for technology transfer. So some technology is developed in a research lab, in an educational institution. It can go into a startup and get commercialized. And I want to give you examples of 4 companies that came out of IIT Bombay. I got to know them well because they're all, I was sort of, part of the incubator at IIT Bombay. So the first 2, IdeaForge and Atomberg, IdeaForge, they were undergraduates. They started making a handheld mobile charger, so you say, oh, sometimes the power goes and you want to charge your phone. So can you just have something that you can operate with your hand? But that had no real market. And then they pivoted to drones. So now today, IdeaForge is one of the strong drone companies in India. And when I look at that, it was a very strong technical team. They say that they can make anything. And, they're very strong in fabrication, design, and so forth. And they were, as a result, very successful. The second company that I want to tell you about is called Atomberg. They started, again, the electrical engineers, they started making a data acquisition system things that you can connect to your experiment and it'll collect the data and put it on a computer. Did not succeed. So then they pivoted to making energy efficient fans. So if you go on Amazon and look for, thank you. And if you look for, Gorilla fans, then you'll see their products. And they were able to succeed. They carved out a niche in a very competitive market. I mean, there are hundreds of fan companies that are better known, but now they're doing extremely well because they made energy efficient fans. And this is again a very strong technical team, electrical, mechanical design, and so forth. So I would say these startups were more based on design, coming up with a nice new product, but there was no really deep technology involved. The other two companies, Sedimac and ImmunoAct, they are based on what is called this deep tech. Sedimac made an engine control system in which there was a faculty lead along with PhD students, and they started this company, which has now become very successful. They're competing with international players, and in fact, I just met the founder a few days back, and he's moving to Portugal because they are going to start selling their product in Europe. So there's some very good technology which they have, which is protected with patents, and they can use that and create a market share. And the other one, very recent, is a company which is doing cancer treatment using your own immune system. So this is a really great product. They take out your white blood cells, they do some genetic engineering to program them to attack the cancer cells. Attack the cancer cells, and so without taking any other drugs, your own immune system essentially takes care of the cancer. It's called CAR T cell technology, and it's being used for leukemia. And here again, the lead in that was a faculty member. It's a research-based product. The clinical trials have already succeeded, and the first patient is already taking this treatment. And so in the clinical trials, they had many successes. So you can imagine that there are these two types of companies, and really for y'all is the second type of company that's important. So all of you who have some very good ideas, you think that they can be commercialized, this is something that you should think of. I mean, for most PhD students think that I'm going to become a professor or I'm going to join a R&D lab. But the third option is to do a startup. And I would encourage you to, at least think about it. So if you look at, from this segment, what I try to convey is that science is often at the core of technology development, but often the linkage is not direct. Advancements in science make the technology more and more viable. And products are not just one technology, they're a combination of many technologies, and design is also very important. Finally, startups are a very good vehicle for technology commercialization. And, you need, the reason I'm saying that you as PhD students should go and start your own company is because it's not that I've done the research, now I hand it over to some commercial enterprise and they can run with it. They can't. Because when they go there and they go talk to their customers, the customers will tell them, we don't want this, we want that. And so unless the original developers of the technology are there and engaged, they cannot make those changes and make the product a success. So that's why right at the end, that technical expertise is essential if you want to do constant innovation. So as I said that, after about a long time sitting in administration, I went back to the department, and then I started, just spending time doing research and teaching. And slowly over time started thinking that, there's some things now when I see all the development of science and technology, that there are some of these things where we have to develop strong expertise. And one is, of course, quantum mechanics, because of so many things that are developing in there. Bioengineering is now becoming extremely important. And, the CAR T cell technology is really an example of bioengineering. Communication is this huge area where, lots of Professor Deepa will probably say more, and Professor Uday Desai, they are the two experts who can probably tell you more about it. But this is a huge, huge opportunity, and the fundamentals of that will make a huge thing. But what I want to tell you a little bit about is computing, because I've got more into this after I went back. There's lots of progress that is possible, and these are now becoming much more accessible, the tools for computing. And the reason is that very powerful computers are available at a low cost. So today, laptops are so powerful, and you can easily purchase time on a cloud to do even large-scale computations at a relatively low cost. But more important than hardware is the open source software that is available for many applications. And significant problems can be solved with resources available today, which were not feasible in the past. So, after I went back, I learned how to use this software, which is called LAMPS, for molecular dynamics. And, I'm using it for looking at problems in particle flow, and I'm looking at some problems in polymer thermodynamics using this type of molecular dynamics package. And it's extremely easy to use. And the second one, which I learned after I went back, was this open form, which is for computational fluid dynamics and also solid mechanics. And again, absolutely available for free. And, I started learning this because I wanted the second year students to learn this. So I was teaching fluid mechanics to second year students, and one of the course projects was using OpenFOAM, and this is an example of the problem that they solved. And literally, it has become so easy now that significant problems can be done very, very quickly. And of course, now I have some research students also working using these kinds of packages. So in this just very brief thing that I wanted to say is that, many of you are doing experiments, but you can collaborate with those doing computations, because with computing, you can get very detailed analysis, and you can get measurements that cannot be done with experiments. So for example, I asked the question, like, supposing I have a molecular chain and I start pulling it, then what will happen to the conformations? Now, that is almost impossible to measure experimentally, but through computations, you can get absolutely detailed. Or I'm looking at, particles flowing. I can say what is the force, velocity, everything on a single particle in there over time, which would be impossible to measure. And then all parameters can be varied. So you can have a density of 1, or you can have a density of 1,000. It's just a matter of typing the number in. And through all this, you can get many new insights which you could not. And of course, there are many startups also now who are using this, and they are providing a service to industry and academia. So this is something that I would recommend, that, if you are not doing it yourself, you can collaborate with somebody, because today, you are getting a very, very detailed view through computing, which is often very difficult to get by experiments. Okay, now I'll finally come to what Professor Ishwar asked me to talk about, which, of course, all of you know what is quality research, so I don't have to say what is quality research. But I just wanted to I have 2 slides on this. So one of the things is that it's really difficult to define what is quality research. I sort of say that, okay, define a smile. Well, I know I can make out when someone is smiling. When I look at the person smiling, I know that he's smiling. But then it's really difficult to put down, you will not capture the essence of just writing down things. So it's really difficult to define, but I wanted to give you some sort of, things to be careful about. And so the first thing here is a law that I came across a few years ago. It's called Goodhart's law. Goodhart is an economist. And what he says is that when a measure becomes a target, it ceases to be a good measure. Okay. So, if you say that, GDP is a target, and then, it no longer will be a good measure of how well you're doing economically. Same way in research, we have so many metrics, number of papers, impact factor of journal, number of citations, H index, and so forth. So, you have to be careful, because you should not let yourself be influenced by these things. Don't try and publish more papers. It doesn't matter. Or try and publish in the highest impact journal. Because again, it really, today publishing in a journal where it's like your work is likely to be read, where there's a community of people. Also, number of citations. I mean, I see many people saying that, okay, you must start writing review papers so that the number of citations increases. So, that for me, the most important thing is the motivation. Why are you doing the research that you're doing? It's not to write papers or to get citations. It's to solve some problem, to get a deeper understanding of some problem. And so what I wanted to say in this slide is basically keep that focus. That focus is really important. That what is the most important thing to keep in mind when you're doing your research is why are you doing it? And really, as a consequence of this Goodhart law, what I can say is good research will result in high metrics. That if you've done excellent work, people are going to cite you, maybe have many papers and so forth. And work will get published in the best of journals. But just because you have high metrics doesn't mean that the research is good. And in fact, the only way that you can see whether research is good or not is through a qualitative analysis of what is going on. That is, you read the paper and try and understand what is the contribution and see how does it fit with the overall broad thing. So this is one thing I wanted to say as far as research is concerned. And then I wanted to just say what are some things you should keep in mind. And I think the most important thing is correctness. The whole research enterprise is built on essentially trust. When you send out a paper for publication, the editor is not going to send somebody to your lab to check that you have done your measurements correctly or that you have, written your equations properly and so forth. They just trust you that you have sent this out, that, what you have done is correct. And so the obligation on your part is to make sure that everything is correct, to constantly check things, to assume, if you're getting some very strange result, always assume that you have made a mistake and then go through and check. Don't assume that, all of physics is wrong and now you're going to come with a new physics. So that correctness part is really important, and that is really the most important thing to work for in research. And then to identify problems in such a way that you'll make a significant contribution. If you ask too difficult a question, you'll not be able to answer it in the time available for your PhD. So then that's a loss. But if you pick too easy a problem, then nobody will care about the answer that you get. So over time, you have to develop this ability to choose a problem that you can solve, and it does address an important problem. So see how you can make a significant contribution to new knowledge, which will have an impact. It's really important that you give full details of everything you have done, because one of the big reasons for success of science is that people go and repeat what you have done and verify that it is correct. So you must give full details, and that is really important for this whole enterprise to succeed. And, instead of going for the highest impact factor journal, try and publish in journals that are appropriate for the work. very often, reviewers will give lots of comments and lots of questions and so forth. So there's always this tendency that saying, okay, forget this, I'm withdrawing here and I'll publish somewhere else. But I feel that addressing those comments and questions in a very detailed and sincere way is important. And in fact, one of my colleagues used to always tell me that the worst kind of review that you can get is, when the reviewer says, oh, this paper is fine, just go ahead and publish it. That I have no comments. So, that is the most useless kind, at least from your point of view, because often the reviewers' comments help you think and strengthen the arguments that you're making in your paper. And then, of course, try and see, what is really going on in your field and see that you can do something more. So that where is the cutting edge? What can you do? And finally, try and see that if you have got some new result, how can it be put into practice? So I would say this would be the sort of mindset which may lead you to do good research. And with that, I'll end my talk. And so these are the sort of conclusions from what I've tried to convey, that modern products and processes are combination of art, science, technology, and design, and you need a lot of creative inputs. And science is at the core of technology, but often this connection is not so direct. Continuous advancements make technology more and more affordable and competitive. I think there are some emerging areas, and it's important that all of you build strengths in those areas. And one of the areas I mentioned was computing, which is becoming very much more accessible using this powerful open source software. And finally, I want each one of you to strive. I want each one of you to strive to do quality impact making research. We are all the best of researchers, PhD researchers. And so what is quality research. And so you just have to put in the hard work to actually achieve that. So thank you. Thank you for your attention. And I wish you have a very nice couple of days here in this symposium.
Thank you so much, sir, for such an informative and motivating talk for all the researchers. I now request Professor Suhashish Joshi to felicitate our honored speaker. Also, as we honor our distinguished guests, I would like to bring to your attention the cultural richness and the exquisite craftsmanship of the Maheshwari silk uttari that is being presented, which hails from the town of Maheshwar in Madhya Pradesh. Thank you, sir. Furthermore, I would request Professor Ishwar, sir, to honor Professor Suhashish Joshi and Professor Deepa Venkatesh. Thank you, sir. So before we proceed, we take a short tea break and I request everyone to please proceed to the common area outside and then proceed to the Maitri Seminar Hall for the rest of the talks by 11:30.
15 minutes. So we have 15 minutes break. Start at probably 11:30. Yes, 11:30. Yeah, like Professor Desai, I think we have a outside tea is being served. We'll meet in the other room, which is called Maitri Hall, just outside the corridors.
Sir, it is not audible. Uh, Hello, sir, it is not audible. Sir, it is not audible now, till now. Hello. Uh, Sir, it is not audible. Hello. 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 Sir, it is not audible. Hello. 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 Hello.
Yeah, anyway, if you can get the presentation. Okay? Can you do Control L and get rid of all this? Fine? I'm on, huh? Okay, so we're back. So these are two famous physicists, I presume many of you know. One is, of course, Feynman. And Feynman lectures at one time were very popular. I believe they are very popular. He got the Nobel Prize. Okay, and Freeman Dyson should have gotten the Nobel Prize, but I guess he didn't have enough godfathers. So one of the famous statements by Feynman, he has lots of them, by the way. It's not, sorry, it's not audible. I think they need to take care of it. Yeah, is it okay now? Are the remote audience able to hear me? You can hear me, but remote, I don't know. Or remote, they can hear. He knows. Okay. So teach your students to doubt. See, this is what academics is required in a sense. To think, to communicate,
Sir,
to
excuse me,
question,
sir, it is not audible.
to make mistakes, to learn from the mistakes, and more importantly, to have fun. The first slide is a sort of a cartoon on the fact that education is no longer fun. It has become a drudgery. And that's the reason students don't come. I think somewhere along the lines, and here I'm not blaming the students, I think it's the people of my profession, the faculty, something has gone wary. I don't have all the answers. I have some thoughts, let's put it that way. But I think we need to bring fun back into learning. And that is true everywhere. You may find with your own, the youngsters that you encounter. The other one I like a lot also, and it relates a little more towards the talk that Professor Day-1 Thakkar gave on research is, dissent is the soul of science, and I would say dissent is the soul of technology, dissent is the soul of education. And I think important. Dissent doesn't mean that you have to rebel. But disagreement is very important. If you don't disagree, nothing new is going to come out. If you simply conform, then what you may do is like what a lot of research that happens in India, like in my area, I say, we have a nice algorithm for face recognition. Since I talked about Digiyatra, maybe the accuracy is 95%. I work very hard and make the accuracy to be 93%. The next guy comes in and works very hard, makes it 97%, things like that. Now there, essentially we have agreed, we are modeling. This is important. I'm not saying it is not important, but if you really want to make something new, something exciting, then you have to accept. And the problem again is not with the students, problem is with the faculty. We don't like dissent nowadays. I can narrate enough stories of IIT Kanpur where I was a student, where in fact, the reason I'm saying it, recently we had a reunion, so a lot of those stories came back and they're a little fresh in my mind, which I'd forgotten. Okay, I won't get into them. Okay, but I think somewhere along the line, even in the IIT system, even in IIC system, I think there is a certain brittleness which has come into the education process. Okay, and I must take this opportunity to compliment my faculty during those days. I mentioned about PRK Ram and many more. I've never seen a bunch of faculty who were so forgiving. I think we got away with everything for which we will be punished today. Oops, how do I change the page? Huh? Click which one? How do I change the page? Okay, clicker is working. So this is the page changer. Oops. This one, huh? Not moving. So what, I just click on this then? Okay, maybe now it will move. Yeah, let me go back. Now this partly kind of relates to the talk and in a sense a bit of a repetition about what Professor Day-1 Thakkar also mentioned in the morning. What is the perceived role of, as I said, perceived role, this is my opinion. You're most welcome to disagree, dissent with me, okay? You don't have to agree to anything that I say out. You can say everything that I'm saying is nonsense, which is perfectly acceptable solution. Okay. Convey knowledge, that's what we all do as teachers. Create and develop ideas. This is the hard part. Create knowledge. Now this I've written it down, but that's the hardest thing to do. And even defining what do you mean by creating knowledge, that itself may take another 1 hour talk. Okay. Inject new thought into society. To me, that is very critical and kind of while teaching, I need to explain that. For example, if I teach a transistor, that's essentially absolutely new thought which came into it. And it was like in the research slide that Professor Day-1 Thakkar had, it's a step change. is one of those inventions which made a huge step change, and we've not had such a major step change since the invention of the transistor. And there are several such step changes across the history of science and technology that one can see, and that we need to bring into the education process. Of course, this is quite altruistic, develop future citizens. These are protocol bullets that I have to put it in, create a better society, learning to learn, etc., etc. This is a report that I read, and I would recommend that many should look at it. New requirements for education, I would say, the World Bank report. And they emphasize a few things that we often talked about, but nice to see it in a World Bank report. This is what is required today. And it's not that we have to be very pedantic in this, but how do we convey this? One is technological know-how. That is easier, and by and large, we do that. Problem solving, that also to some extent we do. Critical thinking. Now, how do we convey critical thinking in our pedagogy, in our education? That is hard. We can all say that, of course, every professor feels that, look, I'm doing critical thinking in my lecture, but you ask the students and they'll have a different opinion. Okay. The other thing is, of course, soft skills. And here there are three things, which is again very important, perseverance, collaboration, and empathy. None of this is kind of, I don't know how to get into it and how to kind of get into the educational mold to create this. Of course, the word empathy became very popular when Satya Nadella took charge of Microsoft. Many of you, almost, I think he's been at the helm for almost a decade or so now. And he wrote his book. Okay, and suddenly I used to meet people who were at Microsoft. He said the word empathy had become very popular. In his book, he repeated that. And those who know about Satya Nadella, he has 2 children, and both of them are physically challenged. And I think that is where the whole concept of perhaps empathy is something that evolved in him and which he brought into practice as a CEO at Microsoft. The other part I'll talk a lot more about is unstructured education. And I'll come to it as I go along. Okay. Now, here are a whole bunch of questions. These evolved. In fact, every time I've given such a lecture multiple times. So whenever I give similar lecture, I keep adding questions. I'm unable to subtract the questions, so because the answers are still not complete. Okay. Do we need and this is no in specific order, literally just as and when the question comes to mind, I keep adding to it. So I have not done any ordering out here in terms of importance, degree, which is first, which is second, nothing. It's just noted it down. Does the curriculum need complete overhaul? I feel it does. And that's what we tried at IIT Hyderabad. I'll talk about it as we go along. What are the right models of learning? Lots of papers have been written on it. I agree partial with some of them, but nobody has a clear answer. Partly because things are evolving too rapidly in current times. When I went to college, it took some time. Something happened. We digested it, we assimilated. It took about a decade before that thought became obsolete. Today, obsolescence is like your cell phone, right? Most of you, I believe, would be buying a new cell phone every 2 years. That's just about the time. I know many who buy a cell phone every year. New models come out, etc. So that's how everything is happening. So I thinking the society is changing. So that's another problem. How can we exploit various things? I think Professor Kakkar talked about the computing models and other things, Chat GPT, Gemini, etc. Unfortunately, India, I just saw some news item today morning. In fact, yesterday I saw it. Now you need some permission from the ministry for new AI models that you're going to use. To what, I've not read the full report, but to what extent, I don't know. So is the traditional university being disrupted? What do we need to do? Way back when I was a youngster, we used to talk about the J. Krishnamurti model of learning for schools. It didn't quite catch on. All of us want to get into IIT, so J. Krishnamurti school will not have students going to IIT. Okay, but then I have many friends whose sons and daughters went to a school which was essentially modeled on teachings of J. Krishnamurti. Okay, then why lack motivation? That again I mentioned about low attendance, uneven student interest, etc. Then how to bridge the gulf between theory and practice? This is a constant debate, and I leave it up to you to figure out. Between breadth and depth, relevance of non-core subject. This is a big question. Earlier when I'll talk a little bit more as I go along, when I went to IIT Kanpur, those is 5-year program, 3 years were common. It didn't matter whether you were electrical, mechanical, chemical, I learned enough in 3 years to be called myself a chemical engineer, a mechanical engineer, a civil engineer. I did experiments and did surveying with theodolites, though I was in electrical engineering. Okay, so I was well versed in operating a theodolite. I'm sure many of you are probably who are not in civil have not even heard the word theodolite. But that's how it was. Now, what do we do today? Do we do the same thing? That was way back in the 70s, right? So how things have changed, you know, what is it? I don't have, again, clear answer, but we need to tackle this. Somewhere there is a problem out here. How the flexible curriculum has to be very flexible. And I think the curriculum nowadays is very rigid. And I'll talk a lot more about it as I go along. How to space the curriculum and how to make curriculum interdisciplinary. You know, NEP talks a lot about it, that it should be, but you know, doing it is a different thing. You know, as they say, the details in the devil is, you know, in the details. You know. Or put it the other way, my friend Kanwal Rekhi, ideas are dime a dozen. This is execution is what matters. You know, success depends on execution. But today, everybody has great ideas. How to increase industry interactions. You know. We were just talking about it. I was talking with Dr. Deepa about it earlier. Then incorporate research in undergraduate program. By and large, research typically is done in master's and PhD. Can we create a program which is research oriented? It has the 3-credit art system, outlived utility. Typically, all courses are 3, occasionally 4, etc. So I'll talk about it as to what we did. Again, I think Professor Devang also brought this into the picture, the design and creativity in engineering. You know, he was more in terms of research, you know, and innovations and inventions that he talked about. But even in engineering education, how do we bring design and creativity into it? I'll talk a little bit about it. How to bring synergy among technological know-how, problem solving, critical thinking, something I mentioned earlier. Are we pumping too much information into our students? Yeah. Again, I'll mention a few words on it. Anyway, the list is ongoing, so work in progress. You know, why so many questions? So I like, again, another quote from Feynman. I would rather have questions that cannot be answered than answers that cannot be questioned. You know, so I think this is a nice quote, and this is something every educator should keep in mind. We need to break the mold. This, I feel, is a basic philosophy which we are not quite adopting. You know, we keep incremental changes. You know, like I've been through like IIT Bombay. You know, every 5-7 years we change the curriculum. But it's like, you know, to say 19-20 ka farak hota. You know, it's like to me it reminded me of the Jaspal Bhatti's joke about music directors in Bollywood. You know, he used to call them as Torji Marodji. You know, and this is what sort of we end up doing. You know, so I think we need really path-breaking changes in it. We may fail. I think we should be prepared to fail. The trouble is, you know, we put a target that yes, it has to be a success. Now, once you say that I have to be successful, then you cannot innovate. You will follow a beaten path. You know, if you're going to innovate, somewhere along the line you're going to fall. You know, like Professor Devang talked about startups. He gave 4 successful startups, but there are so many unsuccessful. For those every 4, there are probably 40 which didn't make it. And we don't talk about it generally. Okay. But yes, that is part of life. So then only you will innovate. Otherwise, you're not going to innovate. So T education, flexibility, I'll talk a lot more, foster disciplinarity, electives, wider choice of electives. Over the years, the electives have come down for some reason. No, this also has to, I remember faculty discussion, the E department, Bombay. No, this has to be taught, that has to be taught, you must teach this. So in the E department at Bombay, we had something called Bhagwat's principle. There was one Professor Bhagwat way back. So big discussion was going on like this, you know, and then Bhagwat stands up, walks up. Before going out, he says, "You guys can teach what you don't know. I will teach what I know." And he walked out. So this is referred to as a Bhagwat principle, you know. So anyhow, E department had a lot of colorful professors. I don't know how colorful they are today. I've been outside the E department for almost more than 15, 17 years. But earlier there were a lot of colorful guys. So Bhagwat is one of them. Then very early exposure to science and technology. I think that is critical. To me, that came again at IIT Bombay. The students would come, okay, and they would sort of say, "Sir, I came to study electronics. 1 year has gone by. Where is electronics?" You know, he says, "I'm good at PCM. I'm learning only PCM." The same thing, fine, more details, more subtleties, etc., etc. Okay. So I think we need to really, I mean, this is a genuine question that they have, and we need to, you know, foster research. I'll talk a little bit about a breaker lab, you know, as I go along. Then I think students should be able to pace their program. You know, we have a very rigid system. In 4 years, you must finish your BTech today. If not, you know, it's like a black mark on your thing. And I think we need to change that. Partly, you know, why is it that everybody has to follow exactly a 4-year program? In fact, there is a lot of pride that in case you do it in less time. You know, I remember when I went to school, it was the people used to have double jump. You know, the guy goes from class 1 to 3, 3 to 5, etc. I think, you know, you're missing out on something. It is not really, education is not about classroom, a lot more than that, and you're missing out on all of that. So I think we should allow people to pace it, and it need not be, I'll give a small story here. So when I was teaching in the US before coming here, there was a student in my, I didn't see him for almost, I think, almost a whole year. Then I asked him, then I saw him again. I thought he was ill, he had some health problems and hospital. He says, no. I said, what were you doing? He says, I was traveling through Central America and South America. He was just backpacking. Like the story you heard about Stephen Jobs coming to India, this kid just went to South America and Central America. Okay. And it was fine. Then he came, finished his degree. He graduated, I think, a year or two later than his batchmates. It didn't bother him at all. So I think that's a good spirit in which the whole system has been set up. Unstructured, I'll talk a little more about it. Excessive information, encourage, of course, creativity, design thinking, etc. A little bit. Breaker lab. See, this is, what happens in India. We have maker labs. Today, all IITs have maker spaces. I think, Professor Joshi talked about it. Okay. I just hope that, I don't know out here, but in most, at least in Hyderabad, I did that, partly learning from Bombay because the funder was the same guy, Hemant Kanakia. So Hemant Kanakia is an IIT Bombay alum. He funded the Maker Lab in IIT Bombay, and then he gave a little bit of money for us to have a Tinkerer's Lab. Now, it is run by students, it's great. The point is, I used to have a short sort of a 3-day workshop with Japanese colleagues, Professor called Hori-san. I think Kishle may remember Hori-san. So he would come, and that's where he mentioned what they do in Japan. And this is Japan, by the way, they have something called a breaker lab. So they would go to Akihabara, which is a place in Tokyo, where you can buy all these gadgets at a low cost, whatever, cameras, cell phones, fridges, washing machine, whatever you want. They will procure all of them, because Japan is a rich country. And they will ask students to rip it apart. That's it. They didn't have to put it back together. They simply had to, each component, they have to specify what was the function of that component. So in India, I think we don't do, and partly that is important for engineering students because unlike US, our students don't have any exposure to working with their hands. If you look at US, every garage, every family's garage is actually a workshop. The cars are parked outside, though we call them as garage. Okay. Even today, it's the same story. There, because of cost structures and other things, people work at home by their hands, fix things on their own, etc. Our students have no such experience today. They don't know what is inside. I remember years ago at IIT Bombay, in my lab, we were throwing away a hard disk. I said, don't throw away. Do you know what's inside the hard disk? Rip it apart. It is not easy to rip apart a hard disk. It is like really solidly welded together all. So if we ripped apart, they could see those magnetic heads on the disk, what is happening, where they are moving. So the idea was that, and this was I was doing with PhD students and master students, but we need this at a lower level. So generally in my talks, I say, in India, we have this kabadi wala, right? Go and get stuff from the kabadi wala. How many of you have ever even taken off a toaster at home? I guarantee, okay, you have done one. One in this whole crowd. And toaster is perhaps the cheapest, most innocuous thing, the simplest piece of gadget you have. Has anybody ever taken off a microwave oven at home after it stopped functioning? None. We are scared to do that. Finally, we'll give it away to some kabadi wala, takes it, he fixes it, or the people who work at your home. I think we need to get this culture of breaking it open and seeing. In Japan, this is actually a course at the University of Tokyo. Hori-san used to conduct that. So I was quite surprised that, and I think that's why I emphasize this. Not that I have been very successful in some of the institutions where I'm involved and I give some, what happened? Some, I have some kind of a say. They have started a bit of it. We are still, they just, this concept itself, how can you have a lab where you walk in and start taking things apart? This is like the movie Three Idiots. Rancho goes around with a screwdriver taking things apart. I mean, it has come because that's how things were. Today, they are not that way. Okay. Collaborative classrooms. We started this, I saw a news item, I've not seen it. IIT Bombay has a collaborative classroom or something. I saw some news. Okay. I'm still on the, thanks to IIT Bombay, I'm still on the mailing list. So I'm somewhat aware of what is happening. So this is a concept we have. This is a design given by Christopher Benninger. We debated a lot with him as to how to take it. The whole idea is the classroom should not be like this, rows and columns. The classroom should be more like, exactly that shows in the picture. So we have about 6 to 8 people sitting in this manner. And what you have to do is at lecture for 10 minutes, 15 minutes, throw some kind of a question. Let them discuss, debate, then pick one thing. And today with wireless technology, the fellow doesn't have to walk over. From there itself, we can have his presentation on the screen. Okay, it's not no rocket science. It's easily available now. Though we don't implement it, you don't have to move around anywhere. Okay, and then say that, oh, this is what we thought of. Okay. And this partly also I saw Hori-san, the way we used to run the workshop. is for 3 days, there'll be 2 Japanese students, 2 students from IIT Hyderabad, they'll be sitting together and some problem will be given. Either they come up with it or we give it, and they'll be working on that particular problem for 2 whole days, like a hackathon, but not a hackathon. With all the stickers, this, that, and finally they make a small presentation as to what is the solution. Like healthcare would be a theme, and within healthcare, then they will think of problems and give out solutions. I think that also we don't do. After Horisan has stopped doing it, IIT Hyderabad also has stopped doing it. Am I right? Okay. Yeah. So when Horisan he used to come like once a year or maybe twice a year and conduct that workshop. And I think Kishle was involved once, if I'm not mistaken. Abhay Sharma was involved in running it. Okay. So I think that is, we need to change the structure of the classroom. This itself, let students talk, murmur. It doesn't matter. It is not such a big thing. Yes, talk does bother. Like in my case, whenever I used to teach, people get very upset if students sleep in the class. So I had a condition: you're most welcome to sleep, just don't snore, because that frequency bothers my ear. So I never bothered. I said, let him sweet dreams, let him sleep. It didn't bother me. See, the point is, why do I believe that I'm so important that they have to listen to everything I say? And I used to tell, if you can manage an A without coming to my lecture, fine with you. In fact, I remember way back when MIT came up with open courseware, the first question I asked my classroom that particular semester, why do you want to come and listen to me when you can get the MIT courseware? Like signal processing, Alan Oppenheim is the guy who wrote the seminal book on digital signal processing. So I used to ask him, he has kept all his lectures in open courseware. This is almost 20 plus years ago, maybe 2004 in that time frame. So I said, why do you want to come? Of course, they still came, not that they didn't come, but it is a mixed bag of things, that today also, why would they want to come to and listen to my lecture when they can listen to it from the expert? And there are enough video lectures, much better than what it was in 2004. So we really seriously need to ask that question, and then we get offended. Oh, they're not coming to my class. You ask why are they not coming? What is the reason? And I think we need to, there is no clear answer. We need to debate on that. Okay. Unstructured learning. This is something, it takes a long time. And I should talk about it in IIT Bombay again, quite some time back. And then I started talking to many IIT alumni. And invariably, they said that at best, 30% of my learning came from the classroom. 70% came from outside the classroom. And in fact, one of my, Shamik Mehta, I don't mind giving recently, he says, what 30%? He says, only 10% came from the classroom, 90% came from outside the classroom. He has gone to US, done quite well. He has donated some money also to IIT Kanpur, not a huge sum, but a reasonable sum. Okay. So all I'm saying is that, we are so obsessed with 30% of the education, we forget that there is 70%. How do we change that? And here I'll give a small anecdote. This is something I was discussing way back with Professor Vasi, Juzer Vasi, my colleague in the E department at IIT Bombay, and we should talk about it, So suddenly, so we used to go after our lectures, have coffee at that coffee shack, the Nescafe coffee shack. And then the conclusion was, suddenly Juzer comes up with this. He said, so you are saying that the hostel should come into the classroom? I said, yes. So this is a tagline, get the hostels into the classroom. Because these kids were very creative in the hostels. You should see in IIT Bombay has something called PAF. And the kind of electronics, and I'm not even talking about the art part of it. The electronics that they use out there to do all kinds of things is just mind-boggling. And I had MTech students, BTech students, PhD, all of them. This is where interdisciplinarity is taking place right there. Okay. So some of you may be familiar with PAF. It's a very unique thing. I have not seen any other IIT have this PAF thing. And they have forget about the show that they put up, but all kinds of gadgets, the things that they do, the back-end work, fireworks, etc., timing it, electronic timers, etc. A lot of it all done by students. And they're so creative out there. They come to the lab, they're half the time sleeping. So what has happened somewhere? So I really like that sort of phrase it came out accidentally from Juzer's mouth. So that bring the hostels into the classroom. And I think that may change things around. Now, how to do it? That's a challenge. So I'm a big believer that we need to bring more unstructuredness into our, partly also if you think about it. So this was not the thinking that I described when I started thinking of unstructured. See, when I used to look at it that how did, for example, I used to teach something called the Kalman filter. Some of you might have heard of something like the Kalman. How did Kalman think of the Kalman filter? It's not that one day he sat and said, okay, today 9 to 11, I'm going to work and I will come up with the Kalman filter. It doesn't work that way, right? It's very unstructured thought. There is that a lot of previous work which was done by Norbert Wiener and others, all that would have come into the picture. Now, it's a very highly unstructured thinking. Finally, when you write a paper, so when Kalman wrote a paper, highly structured. But thinking is all unstructured. So maybe for communication like I'm doing today, there is a structured presentation that I have. But the thinking when I'm about this presentation, my thoughts are all going this way, that way, and then I try to kind of put it. Now I need to also teach that. How do these thoughts, kind of moving back and forth, in and out, how they eventually coalesce and create something interesting. Now, how do we teach that? I think that would be fun to teach if we can manage it. I don't have a clear answer. I have some thoughts, but I don't teach nowadays. Experiential learning, a lot I've talked about it, so I'll skip this particular part. So this is something you must have heard many, many places. This is there in NEP also, they talk about it. Okay. What happened? Did I miss something? No. Yeah. Dynamism and modularity. I think our academics is not that dynamic. The society, as I mentioned, is very dynamic, particularly today. I mean, you see, what ChatGPT did. Within a few months, they had several million subscribers to it. Today, I'm almost certain all of you are using ChatGPT. And in my laptop, there is an icon now on Copilot. So I can put a question in the Copilot. So I don't have to type. I don't have to log into ChatGPT. The Copilot gives everything. And all kinds of interesting things people have started doing with ChatGPT, irrespective of whatever opinion you have. There are lots of anecdotes that I can give. Maybe if you have questions, I'll talk about it. So I think we need to make our curriculum very dynamic. In IIT, actually, you can do that. NIT is also to an extent, ICERs, etc. The reason is we have academic freedom. And I interact a lot with nowadays private universities. And I talk about this as how do we do it? Our hands are tied by whatever, the technical university of the state, like in Hyderabad, it is JNTU. You go to Delhi, it will be TTU. So you're affiliated, TTU say you can't do this, you can't do that. Then you have AICT, then you have UGC, then you have NAC, then you have NBA, then you have NIRF. So sometimes I pity them. I mean, they're simply catering to the needs of these multiple organizations, and they have absolutely no freedom in what they can do. Even if you have a great teacher at a private university, so this again, I give an anecdote. My friend Punacha was my colleague at IIT Bombay. So he says in India, the system is we tie one hand behind the back, then tell the fellow to swim and win medals for us. He says, we can swim perhaps with one hand. That's possible. We can all do that. But you can't win medals with that. But that's our approach. So I think we need to change this whole notion out here. At least IITs have been lucky. There is, in the IIT, as I said, teacher is the king. Once I've been given a course, nobody can kind of, so again, just to be a little more humorous, I'll give a small anecdote from IIT Bombay. There used to be one, I think it was Professor Kamath. It's well known. So he used to be a very tough grader. In his class, I mean, out of class of maybe say 60, easily 30 Fs will be there. Okay. So once the head of the department kind of called him, and said, Professor Kamath, what is this, that? So then Professor Kamath says, okay, just give me 5 minutes. So he went back, he came with the whole stack of notes, books, everything, kept it on his table. He said, you go and teach. And he walked out. And I was good friends with Kamath. So I also once asked him, because somehow he liked me. And Shankar said, oh, he likes you because we can solve all his problems. These problems were really like quizzes. I mean, this is like puzzles, So then I asked, Professor Kamath, why do you do this? He says, I never give Fs. They take Fs, what do I do? So what are you doing? So this is Professor Kamath. Modularity. I think we need to create, see, why should all the course be of the same length, same breadth, everything highly structured? Maybe that was the system in the 70s, system in the 80s. Can we change this around? And by the way, this has been, after I did Fractal, I realized the management education has a lot more modularity in it. Engineering doesn't have any. We are still stuck, the engineering is a little, they move slowly. I'll have a joke on this as I go along. I hope I remember. This is what I wanted, non-linearity design thinking. See, no thinking is linear, but we teach linearity. it's like I used to teach a course on linear systems, and I used to tell them clearly, I'm teaching linear systems because the math is very well defined. I can prove things. I can clearly talk about math. But life is non-linear. There's not a single system in this world which is linear. This is an approximation that we have. And I can teach. I mean, I can write a book on it. I can write papers. Non-linear systems are very difficult. All kinds of different non-linearities. Professor Kakkar talked about this chaotic differential equations. So you have the chaotic behavior out there. Okay, it's a nonlinear differential equation. So nonlinearity is part of life. Everything is nonlinear, but we teach linearity. Why? I think we should make an attempt to teach nonlinearity. We should make an attempt to bring in nonlinearity. I'm not talking about systems. Systems, we do that also. There are courses on systems, on nonlinear systems, after linear systems. But generally to bring in that, look, things are nonlinear in nature. A transistor is not a linear device, but we teach it as a linear device. I mean, there are reasons for it. Okay. But in practice, you have to worry about the non-linearity that exists in a typical transistor. I give that, I'm sure this is true for many, many other disciplines also. And I'm not very, like the Navier-Stokes equation, I had colleagues who used to work on it, very highly non-linear. Okay. So I think, how do we bring that into our picture? Again, a hard problem, not easy to do. But I think we need to attempt. We may fail, it doesn't matter. We need to sort of try that. And I think that may bring fun into the education. That is my belief. Again, you can creative, I think that Professor Kakkar talked about it, so I will not bring it. Mainly bringing that into the education part. In fact, there's a whole section. There was a book on NIT where Dr. Kakodkar, I think, was the chair of that particular committee which had the review of NIT. And he talks about the design spine in that particular, I think it's available on the web. If you search for it, you'll get it. So I would suggest that maybe you should read that particular portion that he has. His idea was that there has to be a design spine. That is, you start with some kind of a design project in the first year and continue with it till you are in the fourth year. So it's more like a spine rather than giving one project, forgetting about it. It's an interesting idea. You might want to take a look at it. Evaluation. This is my favorite topic. We are obsessed with evaluation. Everything is worried about grade, and that in the process, the students are obsessed with it. This is similar to the slide that Professor Kakkar had about that H index. H index, when it came, it was okay. Now it is a measure which everybody has learned to game it. You scratch my back, I scratch my back, and both our H indices will go up. So I'm not belittling anybody. People have done great work. So I have friends who have had very huge H indices. So I'm not belittling. But the point is that people learn to game it. Like I was talking about last night at dinner, how IIT Madras gamed GRE. Okay, that's a different story. So anytime a measure that comes for a first 3, 4, 5 years, that is okay. After that, people figure out how to game it. That's what has happened. Okay. So I think we should give less emphasis for evaluation. Like after retirement, I say openly, before that, I thought people at IIT Bombay may get upset with me, or even when I taught in US. I rarely gave Fs in my course. I think in my whole career, I've been teaching technically from 1977. Okay, I was the evening college teacher while during my PhD at Johns Hopkins University. I've probably given 2 or 3 Fs in that long teaching career. And the reason was that I had enough friends, both at the postgraduate or graduate level in US, also at undergraduate level in Kanpur. They were not good students. They were just scraping through. And they have done very well in life. They have contributed to society just like I have. I mean, I can't claim my contribution is more than their contribution because I had a higher CGPA and they had a lower CGPA. Not at all. Sometimes their contribution is even more than me. People like Anil Agarwal, who started the Center for Science and Environment, because Anil is no more. He's contributed immensely to the environmental thing. Today, it has become a in thing. Everybody talks about it. But he started talking about it, almost some 30 years ago. The center, you should look up the Center for Science and Environment. I think they're doing great work based out of Delhi. Sunita Narayan, and I think Narayan, yeah. Sunita Narayan is the one who's heading it now after Anil passed away. Okay. So I think we need to look at this whole evaluation nonsense and kind of tone it down and not get too obsessed with it. So I think that's one message. We can really discuss a lot more about it if time permits. So these are few innovations that we tried. So this was a broad perspective on what I believe education should. Based on this, luckily for me, I had some very young dynamic faculty members who were willing to experiment and change. Okay. There were 2 of them in particular, Sumona and GVV. I think some of you know him, both electrical engineering. And they really helped me structure the whole fractal thing and all came about by discussing with them. And there I came up, finally I discovered something that the dynamism in a discipline depends on the time constants of the system they work with. So if you look at electrical and computer science, they're very dynamic. Why electrical systems work on nanoseconds now, picoseconds, while computer science works on exaflops, etc. So they'll change very quickly. We're used to things changing too rapidly anyway in any system that we work with. On the other hand, you go to civil, the time constant may be years or months. So I had so much difficulty convincing civil faculty to change it. Mechanical, we have two big stalwarts here, same problem. In fact, I used to get into fight with your good friend. You probably know about it. Your friend might have described the fights. We had one professor who migrated from IIT Kanpur to IIT Hyderabad. Professor Muralidharan knows him very well. I won't give his name here. I think Suhas also knows him. So big fights, so lots of things. To the extent, I was trying to sort of talk about thermodynamics. I think fluid dynamics. Then he said, "What do you know about thermodynamics?" I'm a mechanical engineer. I know. You are an electrical engineer, know nothing. So the good part was dissent was allowed in IIT Hyderabad, that he could stand up and tell me bluntly that way. Okay, and I respected that because yes, he is a brilliant man. He knows fluid dynamics in and out. I don't know. I just know superficially. So let me talk about various. So fractal, I'll talk in more detail. See, we started digital fabrication. I think 3D printing. So what we did was started occurring to me that what is happening, that we are teaching workshop, and I don't know of any electrical engineer or a computer scientist who used a hacksaw after graduating. So I said, why are we insisting that they have to take a pretty piece of metal and cut it and then keep filing until you have that right angle out there? It's a legacy of which has no value today. So finally, here I must thank my mechanical faculty. So I talked to one Surya. He's an IIT Madras BTech, you know him, Karnakaran student from IIT Bombay. So I said, Surya, help me out. He started the conversation. We were going in a car someplace. He was with me. I said, come along, Surya, just like that. And then we started chatting. And I said, Surya, can you help me? Luckily, again, young faculty, this is the advantage. So he said, yes, sir, I'll do it. And then we worked on it. And we convinced the Senate that today in IIT Hyderabad, workshop is done by, I think, mechanical, civil, perhaps chemical. I'm not sure of that. Computer science, electrical, don't do any workshop. And on the other hand, what they do is a course on 3D printing. In the very first semester, students do 3D printing at IIT Hyderabad. And it became a super hit because it was that time very novel. I think we started it in maybe 2012 or 2013 timeframe. Hardly anybody was doing it. It was purely a realm of research, PhD research on 3D printing. Suddenly, these guys are doing an undergraduate first year. They walk into IIT Hyderabad for one of the courses, 3D printing. And it became a super hit with them. In fact, they would call me at the end, sir, we have built all these models. Please come and take a look at it, spend some time with us, etc. I must thank Surya for it. I think he managed the whole thing. He set up the whole lab. He developed the curriculum. He taught also for several years. Now many others are teaching it. AI and humanity. So this we started. I'm not sure if this minor still exists or not, because I said AI is coming in. And as I mentioned about rules, how does AI impact humanity? How does humanity impact? Today, we're all worried about fake news, AI doing this, AI doing that. When this thing, OpenAI came up with Sword. I mean, I got so many social media messages and emails, that look, they showed these beautiful videos which were generated by AI. This is what's going to happen to all the actors and all the people who are doing all this production, Now, so society, so the idea was to look at that aspect. And it was supposed to be common, not for undergraduate. That is, the class will have PhDs, masters, BTechs, everybody put together. It doesn't matter what discipline you are in. We started it. I really don't know what the current situation is. The other one, which I'm quite proud of it, and again links to the last part of the talk that Professor Kakkar gave, is minor in entrepreneurship, to motivate people to become entrepreneurs. And I think it was a big success. So there was one big catch here. So they had to do a minor. I think it was very similar to what IIT Bombay had. I pretty much kind of replicated that system. I think 12 credits is what they had to do to get a minor. The point was each and every module in the minor was not taught by a faculty at IIT Hyderabad. It was taught by someone who had done a startup. Sometimes highly successful, sometimes not so successful. So for example, 2 modules were taught by one former chairman and the other one current chairman, Ajay Chaudhary. He was a co-founder of HCL. Everybody is HCL, right? So he used to teach on introduction to entrepreneurship. And I'll come to that story also in a minute about evaluation. The other one was BVR Mohan Reddy. He started a company called Scient. So he's the founder of Scient. Okay, again, distinguished alumnus of IIT Kanpur. So he used to teach that. Then I had everybody. I had people who were serial entrepreneurs like, Pradeep Mittal. Then I had Satish Andhra, who runs a venture company. Then Hemant Kanakya also came. He taught one course out there. I think he did 1 or 2 years. Then he said, look, I'm very busy. So luckily I had, and then the best part was initially I had to get a group together. Now when Hemant says, no, I can't, I said, okay, Hemant, you find a substitute for me. So Hemant would then find somebody else and that guy would come and teach. So we had, it was going very well. I'm not sure what the current status is, but this was the key component, that teach entrepreneurship by people who have literally burned their fingers, rather than someone who's going to read a textbook and chapter 1, chapter 2, chapter 3. So in this context, I'll come to Ajay Chaudhary. So once I asked Ajay, I gave them full freedom. I said, you come and teach when you want. So many days, not every Monday, Wednesday, Friday kind of a thing. They would come sometimes and do 3-4 hours, then go back. Then after 15 days, they'll come again and do 3-4 hours, etc., and finish the number of hours, 14 hours that were required for a 1-credit course. So then I asked Ajay, became good friends. We started calling each other by first name. I said, how do you evaluate? So he said he gives a final exam. What is this final exam in introduction to entrepreneurship? Watch 2 movies. Rocket Singh, Salesman of the Year. The first movie that Ranbir Kapoor made. And some of you may remember, he's a Sardar in that movie. The second is Jerry Maguire, starring Tom Cruise. 2 popular movies, one from Hollywood, one from Bollywood. And then the question is what? Analyze these 2 movies on the principle of entrepreneurship that I've taught you in the class. That's it. That was this is what I meant. So he brought fun back into the thing, to the extent that students wanted to take him out for dinner after the course was over. It rarely happened. It never happened. Well, a few students took me out in the early part. I was very young, so they liked me. As I get older, they never liked me. So then he asked me, he said, should I accept an invite? Then I said, Ajay, it may be better if you take them out for dinner. Of course, he's very well off. So he took the whole class, and there were some 30 students or 25 students, whole class out for dinner. Okay. He said, forget it, you guys are not taking me out, I'm taking you out. No, there was a nice rapport, to the extent that even some of the students he taught today, and recently it happened, Vishwajit Rathore, he's starting having a startup. So I suggested, he says, yeah, I took his class, so I can talk to Mr. Chaudhary. So he, getting his time is almost impossible for anybody, but because of his connection with IIT Hyderabad, he gave about half an hour to 40 minutes time for a young fellow who wants to have a startup and guided him. Do this, don't do that, etc. Now that is the relationship that you develop when you have people coming from outside, as opposed to faculty members teaching it. Today you ask any entrepreneur in the country, startup fellow, if he can get time of Ajay Chaudhary, he'll be very happy. Okay, it's not so easy to get his time. He's there. He's doing a lot of work on semiconductors and making India into an electronic product nation, etc., etc. Double major. This I think I heard recently. I was there. IIT Kanpur also I think has double major. The only difference is we are saying 4 to 5 years. And this is again like a story, and I'll come to the story later. So the idea was that you can do 2 bits. See, normally in an IIT system, someone gets civil or meta, they're very unhappy. It's like life has come to an end. Okay. So I said, okay, life has not come to an end. You can do a BTech in computer science, and we gave the sequence of credits. And you can take 5 years. There is no need to graduate in 4 years. You take an extra year and do it. About 10 to 15% took up this. Others were simply complaining. They said, I'm getting out as soon. And maybe I'm going to do an MBA anyway. I am Calcutta, whatever. Now there are some 20 IIMs or whatever. So it didn't. So they complain, but when the opportunity is given to them, they don't want to work hard. So some of them took it up. And I think it's a success. I wouldn't say it's a grand success, but it's a good success. And the other thing we started is that I hope it is still active. A student can take a year off without giving any reason. His mother doesn't have to be ill, father doesn't have to be ill, he doesn't have to, she doesn't have to be ill. But the fellow says, I just want 1 year off. Why? I want to go to Kashmir, I want to go to Kerala, whatever it, or I want to go to Sikkim and spend some time, or Dharamshala, etc. That is his choice, her choice, or their choice rather, in today's parlance. Okay, and it has worked. I think some are taking off, but in India we have this black label that if you don't finish in 4 years, it's like a rubber stamp on your head that you are a failure, which I think that value system has to go. Okay. Minors and honors, I tick mark here. I'm not talking about it. This is pretty much what IIT Bombay had done and many other IITs. So we just replicated that whole thing. We started this. This is an interesting thing. I saw Professor Joshi talk about engineering science as one of the kind of bullet or one plot that he had in his slides out there. So we have now a Department of Engineering Science, and here I must say, your colleague did help me a lot in setting this up. So though we have our differences, it's not that way. So this was like saying, kind of taking a bit of IIT Kanpur. For 2 years, a student will do everything. That is, they will study computer science, electronics, electrical, mechanical, civil, chemical, metallurgy, material science. And we developed the whole program for 2 years. And this idea came, that there has to be some breadth in the engineering education, number one. Number two, people were saying that if we in JEE, why are we giving branch in the very first year, as soon as they admit? If we were to allow them to take the branch after 1 year, they will probably take an educated thing and everybody will not flock to computer science. Let's test out, with a real life experiment rather than all kinds of beliefs and opinions. Okay, so this was one other motivation. Just check. So after 2 years, the students could take any branch they wanted, and we said you can go to that branch. Okay, there was no restriction in the first batch. Now, what happens in the first? So this worked very well. Students were very happy. In the first batch, what happens? Out of 20, the early days of IIT Hyderabad, just like Indore, there were 20 batch of 20. 17 of them opted for computer science. So then I had individually must have talked to them for more than 2 hours, kind of sitting in 18 of them only. Just why are you doing this? Life is this. Examples of my students who went to US and became medical doctors, became aerospace engineers, electrical engineers, or no impact. And finally, one guy tells me, and I think that was a very telling thing that the student told me. He says, sir, if I do a BTech in civil engineering, I'll be happy to get a 6 lakh job. But if I do a BTech in computer science, I'm pretty much guaranteed a 15 lakh job. More. 15 lakh will be like the lowest that he's going to get. He says, why should I do then BTech in any other discipline? Okay. Of course, after that, computer science was overwhelmed. Suddenly their class strength, which was 40, went to 60, literally. He said, look, we can't handle this overload, so we put some restrictions. I forget, I think some 30% of the class can take one particular discipline or some such thing is there, but still the sequencing was the same. Computer science, electrical, mechanical, everything else. So this proves that, whether you do it in the first year, second year, third year, the choice is not going to change. It's dictated by something other than the joy of learning that you have out here. Now, the other part that is a lot of interesting things came out of this. So in fact, the dual degree actually came from this rather than IIT Kanpur. So one of the students, he went to mechanical engineering. Then one day he comes and knocks on my door. He says, I want to talk. Okay, sure, sit down. He says, sir, this is what it is, right? I did engineering science, so I did so many credits in mechanical. Now, the degree is to read mechanical engineering, engineering science, BTech, specialization, mechanical engineering. So he said, now I have been to mechanical engineering for 2 years. I have done all these credits. He did extra load. So he says, now if you look at my total number of credits, they are no different than what a mechanical guy would take it, who took mechanical while entering IIT Hyderabad. Why can't I get a degree called mechanical rather than this degree called engineering science, BTech mechanical? I mean, specialization mechanical. 5 minutes, okay, I'll quickly. So I was telling, never give a microphone to an old professor, Yeah. So what I would say is that, so this is where the whole thing started. There are many other such things, many other programs emanated from this program based on the feedback we got from the students. So I'll try to quickly go through it because I think, then we started all course. This became a big success. I'm not sure. So we started all course option, 1 year to work in summers also. At the end of the summer, you get an MTech degree, no project, no thesis, but the number of credits. So we took like the thesis credits were, half of them were course credits in some sense. That's a measure that we took. And we used to charge quite a bit, 10 lakh rupees for all course option. Okay, we had our own exam, no gate requirement, nothing. It was quite a bit of a success and a good source of revenue also. We started online. Now today, everybody is doing it. MTech program in data science. Again, this worked out very well. I think, and it was a flexible program. 4 years, you can do a lot of credits in one particular semester. Suddenly your company wants you to travel, do this, that. You didn't take any credits, but you have 4-year time span to finish your MTech degree. And it worked very well. Okay. Other departments have still not started, but I like what IIT Kanpur is doing. They have executive MTech, which is doing well. There are some 12 such programs or 10 such programs in IIT Kanpur. Then we started BTech in AI. Talked about climate change. We have an MTech program. So we have a department of climate change. They do MTech and PhD. I don't know, maybe BTech may come in, sometime may come in. Collaborative, I talked about it. Okay, fractal. The whole idea of fractal kind of, is that you atomize courses. And I talked about earlier, the length and breadth have to be different. need not be the same thing. Okay, so each course, some courses are 1 credit, some are half credit, some are 1.5 credits, some are 2 credits. So rough calculation, we did a semester's course is approximately 42 contact hours. Okay, now we start dividing it. Okay. So I think 14 contact hours was 1 credit, and 3 credits would be 42. Okay, so we had courses of 7 credits also. Okay, and in this context, I also got our former president, of course, he's no more, Dr. Abdul Kalam, to come and teach a course at IIT Hyderabad. And the fun part of it is I told Professor Kalam that, sir, you also have to give grades, not just teach. He's a very good teacher. And he actually, but he gave only A's and B's. So I'm saying, don't worry about knowing him. Can you expect him to give anything else? So all kind, and this worked actually quite well. So what we did was we started this initially because we didn't have enough faculty. Madras was kind of mentoring us, like Bombay mentored Indore. But I still got faculty from Bangalore, Bombay, some other places who would come and teach fractal. They didn't have time to teach 42 hours, but they would teach 14 hours. So that worked out quite well. Okay. And that became a big success. I think, we have a whole structure. What we added in there are courses on liberal arts, creative art, design, and entrepreneurship. I'll talk a little bit about creative arts as I go along. Okay. So I'll skip this shortage of time. And I'll skip this part also. So let me just give an illustrative, say this is the first year course curriculum, which was there when I was there. And I think things would have changed, obviously. And this is electrical engineering, simply because I'm an electrical engineer. You have independent project, 1 credit. Okay, this is a project where the students decide, and anybody on the campus, any faculty on the campus is a guide. It runs right through the semester. So the arrow that you see, horizontal arrows, it tells you how it runs. So we broke up the whole semester into 6 segments, 7 credits per segment. Let's put it that way, 42 credits for the whole year. Okay, so this runs right through. Digital fabrication also 2 credits runs right through. 1 credit for CAD, another credit for actually doing the 3D fabrication using polymers and building, whatever they wanted to. Okay, calculus 1, calculus 2, etc. Then in the very first year, we added electrical circuits, magnetic circuits. This is for electrical engineers. Digital logic design, again, all 1 credit. Signals and communication. When you come in, you're excited. You have used a cell phone. What does a cell phone work on? Everybody talks about cell phone today, right? So Internet of Things, those days at least were a big thing. This is something we did almost about 10 years ago, more than 10 years ago. Okay, so IoT was just coming in. Everybody was talking about IoT, bioengineering. So we actually taught, today it's become very popular, genetic engineering. In fact, one of the faculty in bioengineering or biotech, I asked him, he said, yes, sir, I teach it. So we started a 1 credit course on genetic engineering. And of course, CRISPR has kind of brought everything into the limelight. Everybody is talking about it today. Liberal art, creative arts. Okay, so creative arts, again, we had 1 credit where the people who taught the course were actual artists who came from outside. So this is a sample list and the teachers who were there. Introduction to theater, M.K. Raina. He came from Delhi. Many might have, anybody who has seen Tare Zameen Pe. Of course, now we'll get Sitare Zameen Pe in some few months from now. So there he is the principal of the school. Okay. Exploring the performance spectrum, Jayachandran, he taught it. He came from Kerala, of course. Introduction to pottery, Jagruti Datta. She came from Baroda. Then understanding cinema, 5 days, Shubhra Gupta. I think, I don't know where the place, Then introduction to Carnatic music, Vasudev. Madhubani painting, Shalini Kumari. I think she came from Patna. Understanding Hyderabad and its heritage. I mean, you're also Indore has so much around you. So that was taught by IT faculty because just going around and etc. Music from the world, Arko Mukherjee. Filmmaking for beginners, Rajiv Ravi, etc. In fact, I had one person who used to teach music, give music to Telugu films. Ramana something, I'm forgetting his last name right now. So he gave a title for his course. I didn't give titles. So there, some students have a title of this title in the transcript, must be with music. So Ramana said, no, this is the title I wanted, fine. So we had people who gave Western classical music. I think now he's an adjunct professor at IIT Hyderabad. Second semester, just to give an idea, again, you go through the whole thing and you can see the structure out here. So in fact, the big argument in the Senate was, oh, we are breaking it up, doing this. How are we going to schedule it? There again, I must thank Surya. And within a week, he came up with the core timetable. Then, of course, we spent time refining it. It's like the last mile problem. We solved that also. But 90% of it was done by Surya to start with saying, hey, this whole thing can be done. Because people are worried. How are we going to schedule the lectures? How are we going to manage the whole thing? And it's been done. Okay. And one can go on, then independent project. The key thing I want to now point out as I go along is as you go along, this is 5th semester, electives start appearing. If you look at this is this is semester 6, third year, second semester, all are electives. There's no requirement at all. So you have baskets, you take whatever you want. There are some independent electives which you can be from any department in the institute. It doesn't have to be from electrical. Again, you look at this one, and all 7 semester, 8 semester, nothing but bunch of electives. Okay, then the other one is for computer science, kind of, I'll skip that particular part and I'll bring my talk to an end. We won't have time for questions and answers. So what is required actually in the challenges, fractal thinking, context switching. Some people were saying students had difficulty suddenly switching context, because they're taking too many modules in a particular semester. So one has to manage that part. Evaluation, I did talk a lot about it. Okay. So, we are in a new age, digital X, CRISPR, climate change. We need to kind of mold our curriculum looking at all these new things that are happening out here. Okay, I won't spend time on all these things. I'll concluding remarks, which is like repeating what I said earlier. So, due to shortage of time, I'm going to skip that particular part. And this is another favorite slide of mine. A truly great library contains something in it to offend everyone. Okay. If nobody gets offended, then you don't have a good library. Thank you very much. I think I did manage it very well. Okay, we have time for questions or none? Okay, we can do that. Whatever you call, you are managing the whole show, so I think it's your call. Thanks. Rohini, my bags are here. I'll sit here. No problem.
Mr. Rohini.
Oh.
Hello.
That takes. Oh, I should give my microphone.
Good afternoon, ma'am.
Good afternoon. Oh, hello, everybody.
Yeah.
Safety guardians.
Can do it later.
I hope you people can hear me.
Yes, I think you don't
Hello?
want to interfere.
Yeah, we are able to see, ma'am.
So I will now share my screen. Shall I? Hello?
Hello, ma'am.
Yeah.
Ma'am, we are able to hear you. Yeah.
Yeah, now I need to share the screen, right?
Okay, moving forward, we have a very interesting talk on doing science in India and as a woman by Professor Rohini Godbole, IIT Bangalore. We'll have her online. So I request Professor Ankit Roy, Department of Physics and Associate Dean of Academic Affairs, to introduce the second invited speaker of the session. Over to you, ma'am.
Thank you. Professor Rohini Godbole. Ma'am, can you hear me?
I can hear you. I hope you
Okay.
people can hear me.
Yes, I can hear.
Okay.
So it is my privilege to introduce Professor Rohini M. Godbole. She is a theoretical particle physicist and also Padma Shri awardee. So let me start with her career. Basically, Professor Rohini M. Godbole holds a bachelor's degree from University of Pune, MSc in Physics from IIT Bombay, PhD from State University New York at Stony Brook in USA, IIT Kanpur, IIT Bombay, IIT Jodhpur, VTU Belgaum, and Shivnadar Institute of Eminence have conferred DSc on her, and 2-century-old universities, the Tilak Maharashtra Vidyapith and SNDT Women's University, have conferred DLET on her. She has been involved in research in theoretical particle physics over the last 4.5 decades and co-authoring about 300 research articles, reports, and books. After spending time at the TIFR and Mumbai University, she has been at the IIC Bangalore for more than 25 years and is currently INSA senior scientist there, with adjunct professorship at IIT Hyderabad, as well as distinguished visiting professorship at Shivnadar Institute of Eminence. She also has been a visiting professor at University of Utrecht and held van der Waals chair at the University of Amsterdam. She has been a visiting scientist at CERN and DESY at various times. She has been functioned in various advisory positions, such as member of the Scientific Advisory Committee to the Cabinet, a member of High Energy Physics Advisory Panel of the United States, She is an elected fellow of all the science academies of India and the World Academy of Science. She has been vice president of NASI and is currently the vice president of IASC. She has been the chief editor of Pramana Journal of Physics and was associated with the journal for more than 2 decades. Professor Rohini M. Godbole has been conferred prestigious Padma Shri Award by Government of India in the field of science and engineering nuclear, as well as Ordre National du Mérite by French government in 2021. She campaigns the cause of equity and inclusion in science and was the chair of the TG9 on the same subject for the Science, Technology, Innovation Policy of India, STIP 2020. She is the founding chair of the Women in Science panel of the Indian Academy of Sciences, has strived for the last 2 decades to increase the participation of women in science and make their path in science less encumbered. Among her lasting contribution is the co-edited book, Lilavati's Daughters, the Women Scientists of India, comprising of autobiographical sketches of Indian women scientists, as well as landmark surveys on the status of women in science. It is interesting that a graduate level textbook on supersymmetry, so co-authored by her and Lilavati's Daughters, have both been widely acclaimed and popular. With this introduction, I will request ma'am to enlighten us with his talk. Thank you, ma'am. You can start.
Thank you very much for this very kind introduction. So first, to begin with, all the dignitaries in the audience, and beginning with Dr. Suhas Joshi, who is the director of IIT Indore, and all the others since I am not able to see who all are in the audience, I don't mention them by name. And most importantly, all my young friends who are the PMRFs and for whom this is the annual symposium. So good afternoon. I think it's afternoon, yes. And I am the only thing that stands between you and a lunch. So I'll try to be brief, but not so brief that I'm not able to convey what I am saying. So now let me try and see if I can share my screen. In the meanwhile, please tell me if you are able to hear me properly, because I'm having some trouble sharing the screen. And I may have to log in and out of WebEx for that. So if I suddenly vanish, then please know that it is my computer that is doing strange things.
Ma'am, can you share, can we share your presentation on your behalf?
Can you do that? That might be easier because I'm not able to share it from here.
Yes, sent it already.
And what I will do is that I will open this presentation on my own screen and I will tell you to go next. I think that might be easier because somehow WebEx is preventing me from sharing my screen.
Yeah.
I tried twice, but it has not
Share
worked.
it. Just Professor Rohini, are you able to see the slides?
One second. I'm opening them also on my own screen. In case I got. Yeah, very good. Yeah. So can you make it? Yeah, this is fine. Good. So thank you. So as I said, this is going to be a talk on sort of, taking a look back at my own life and trying to tell you a little bit about the experiences about doing science in India, and I have put in a bracket as a woman. So let's go to the next slide. Can we, So, okay, this is of course on your symposium. So this is all the best wishes to all of you. Let's go next slide, please. Yeah. So before I sort of say this, before I begin, let me also say this, that my friend here was very kind and gave an introduction, but I thought I will tell you scientifically who am I. So I'm a theoretical particle physicist. Of course, I've been working in India, But the reason I'm stating India separately is that this particular subject is a very global subject in nature of its functioning. And what is particle physics is the subject which deals with the theories of elementary building blocks of nature and how they are put together to form everything. And in particular, my particular aspect of my work is that I work on how to explore these theories about the laws of the fundamental laws of nature, how they can be explored at high energy particle colliders. And one of the name of such collider is popularly known to all of you. That's the Large Hadron Collider at CERN. And this subject is called collider physics. But to repeat, I am not an experimental physicist. I am a theoretical physicist. But it is necessary for me to understand how these mammoth experiments, which require also mammoth and precision engineering, so involves also engineers, involves a whole lot of experimental physicists, and I need to understand some of the details of these machines, of these detectors, and my knowledge of particle physics to be able to make significant contributions to the investigations of these theories at the colliders. And I have been working on it for more than 45 years, first as a PhD student and then as a scientist. Next slide, please. So, as I said in the beginning, I'm going to make a few remarks of my own personal journey in the walk of science, but not so much to tell you about myself. But what I want to do is that I want to tell you a story. And unlike other stories where morals are given at the end of the story, or you are told to find the morals of the stories, I'm going to try and tell you the morals of stories as we go along. So I'm going to use the story as a structure, story of my life as a structure, to tell you and share my thoughts about what does it mean to do science in India, in particular doing theoretical particle physics explorations at the high energy collider experiments, which are actually based somewhere else in the world. To some extent, I also want you to give you a flavor of how today's in the world where science has become global, how does one do science sitting in India? What are the possibilities? What are the hopes? And what are the aspirations that we can have? And on top of it, or at the bottom of it all, underlying integrally, I also want to include my experiences or my thoughts about doing science as a woman. And why am I doing this? I'm doing this because I'm hoping that all of you in the audience here, the guys and the gals, will pursue a path of science / engineering / innovation / industry, whether it is academic or non-academic. It will be a path which will be lit up by your knowledge and experience and excitement about science as well as engineering. And therefore, in today's atmosphere, for all of us, it is also important to have an awareness of the necessity of inclusion in STEM, in general inclusion, in particular gender inclusion. So this particular slide tells you or sort of sets the stage. Why is it that I am telling you my own story? Because it will be indeed every now and then will be papered with the morals of the part of the story up to that point. And I hope that we will have a little bit of a time if there are any questions that you would want to put to me. So the next slide, please. So, before I begin, I want to tell you what have been the aha moments in my life as a scientist. What is it that one looks forward to in a life of science, which most of you are going to be embarking upon? So for a basic science academician, one of the most significant aha moment is when you find some very new, no matter how small, aspect of laws of nature, which was unknown to the community till then. So this is not like, of course, the apple, it's a very, very watered down version of the apple falling down and Newton finding out the law of gravitation. But mind you, to have the excitement, you don't need to be Newton, and you don't need an apple to fall on your head to find out something as significant as the law of gravitation, which of course is great, but there are much smaller versions of that, which us mere mortals, as scientists, in our life in science, do enjoy. And that is perhaps the best aha moment in a life of science. So as a theoretical physicist, what has been my particularly aha moment? I do some theoretical prediction. I do some calculations using when I began my life using pen and paper, but as my life continued using more complicated computers, using GPU, using your parallel processors and what have you, do very complex calculations. But at the end of it, seeing that one calculation you did, the one curve that your model predicted, the data confirm the predictions. Or sometimes the experimentalists provide some piece of data and say, we don't understand it. In general, very simply, which you have studied in your, regular courses, so I can say this, is that, you look at, does a simple thing like this, does the resistance go linearly with temperature of a material? Somewhere there is a funny behavior of this resistance versus temperature. And then you ask a question, how did that happen? And very often answering such questions led to very fundamental breakthroughs in our understanding of fundamental science. So very often, you may not be as lucky as all that, but sometimes some small aspect of theory you can tease out from the observed data, and you say, this is what the data are trying to tell us. So that is a particularly aha moment. Then as a particle physicist, having spent my lifetime in the worldwide community of people who are hunting for the Higgs boson, I was present at CERN, the place where the Higgs was discovered, on the day the discovery was announced. And I was supposed to lecture 2 hours after that discovery to a whole lot of summer students coming from all over the world at CERN for a summer school. And I can't tell you the kind of high one gets in a life of science after such an event. And last but not the least, meeting students of different nationalities, many different places, at different places in the world, meeting a student in China who comes to pick you up at the airport and says, oh, I listened to your lecture at CERN in 2012. Or some student meet a student at Netherlands and says, oh, I listened to your lectures in Oman. Or somebody says, I listened to your lectures in Algeria. Now, this is partially because my subject is extremely global, and we have these global world level schools where students from all over the world come. But believe me, meeting your students somewhere and saying, I still remember this. I learned this in that course. Actually, that feels, something very special. So some student in Kashmir University, I meet him after 15 years, and he says, oh, I listened to a talk by you on the discovery of the Higgs in the library of Kashmir University. And since then, I have been interested in nuclear physics, and I'm studying nuclear physics. So these are the aha moments of an academic's life. And these are the aha moments that all of you can look forward in the life of science. We may not get too much money, we may not get too much name and fame, but these academic joys are actually the joys of a life in science that I hope you all can look forward to. Next slide, please. And actually, last but not the least, one of my special moment has been when, already the professor who introduced me told you about a book that I co-edited with my friend, chemist, Professor Ram Ramaswamy, which is called Leelavati's Daughters. And we had featured, this book believe it or not, featured in the penultimate round of Kaun Parega Crorepati. And, this kind of, for me, was a proof that the importance of women scientists now has become the part of the Indian social psyche. I mean, if Mr. Amitabh Bachchan could ask a question about Leelavati's daughters, and the participant actually went on to answer that question correctly and won the 1 crore award. So when this happened, that was really an aha moment for me. For somebody who studied in an all-girls school, where till the 7th grade, I had not even studied science. I had only studied home science. So for somebody like me, seeing the journey from 1960s, where we didn't even learn science in a girls' school, to a level where my book, Leelavati's Daughters, actually featured in the penultimate round question of Kaun Banega Crorepati, that was indeed a case of, you have come a long way, baby. There used to be a very famous Virginia Slims ad, which you people will not even know. This was in the US in 1974 when I went there as a student. And this was a woman smoking and saying, you have come a long way, baby, because women publicly didn't used to smoke before that. It was not considered the done thing. So essentially, this journey of women in science, for me personally, was actually also another aha moment. Next slide, please. So what will I do? I will tell you my world line. I will tell you about my world line as a student of science and a young researcher. I will tell you about my world line as a senior scientist. I will tell you about my world line as a scientist who happens to be a woman. And in all this, what I want to show you or talk to you is what helps. What do we need to do so that there are more young women who will become active scientists? This is where I would like to end. What will you people, what do I hope you people can do in your lives so that the atmosphere, the STEM atmosphere in which you work becomes more gender inclusive? And I'm sure the world line is known to all of you. You are all science and engineering students, but I will still put it here. World line simply means the space and timeline. Please, next slide, please. Okay. So what am I going to sort of want to convey to you through all this story is what is meant by the life of a scientist of any gender. It doesn't matter. What is the aim, the challenges, and the excitements of a life in science? I've already shared with you the excitements of the life in science. Then what does one require? What is required to do that? And what are the steps that you need to take so that you will reach to that goal, if that is what you look forward to in life? Then what are the milestones by which you will measure your success or failure in the journey? And as I said, the underlying all this, the thread would be, what are the special aspects because one is a woman? Next slide, please. And actually, I'll tell you the origin of this talk is actually in a talk that I was asked to give at the first international conference on women in physics. This was held in Paris by the International Union of Pure and Applied Physics. This is actually the union of all the countries in the world who and look at the development of physics and applied physics all over the world. And this was the first international conference on women in physics in 2001. And there were about 10 speakers who were asked to talk about experiences of doing science, doing physics as a woman in their respective countries. We were 10 of us, I think. And for me, this talk was very, very important because it marked the beginning of my own involvement in the cause of women's participation in science. So next slide, please. I will just show you on the next slide that this was the talk I gave there, being a woman physicist, an Indian perspective. So next slide, please. And I just want to read out the first few lines for you, because this gives essentially the background, my own background before coming to science. So I said that since I was talking to an international audience, I told them that in India, student typically goes through 11 and 12 years of schooling. At our time, it was not 10 years. It was actually either 11 or 12. And that is primary, secondary, and higher secondary education. And this was followed by either 3 years of college or 4 years of college, depending on whether you did 11 years of schooling or 12 years of schooling. And then 2 more years for doing masters. And then most of the time we would do BSc and MSc in state-funded universities. And the PhD would be in some cases in the institute in India. Most of the time, at that time at least, it was abroad in the US, either IITs or TIFR, and so on and so forth. So either, but most of us actually did our undergraduate mostly in smaller universities, state universities. And as I said, most of the students who applied for professional courses, such as engineering and medical, did not join these undergraduate colleges. And the bulk of funding in India, the research activity, actually happened in research institutes, and that is still true. And universities have active research groups, but that they're limited. So this was giving them a picture of the India in which I grew. Next slide, please. And this is my world line. So my essay, my world line has more or less followed this general pattern. So now here, I studied in an all-girls high school for 11 years. I studied in my mother tongue. Then I studied for my bachelor's in a local college in Pune. And this was followed by 2 years of a master's degree in IIT. And then I worked for my PhD in the US. And after my PhD, I spent time in equal proportions at TIFR, at State University, and finally at the Indian Institute of Science. So this is where I have been, and now we want to understand, next slide please, how did different aspects of this journey get impacted by the different specific features that I have added, and what do we want to learn from this? And in case any of you are interested, you may actually look at the URL of the book Leelavati's Daughters, which has stories, not just mine, but 100 such stories, and you might be able to learn a little bit indirect answers about what does it mean to be a woman doing science at the cutting edge in India. Next slide, please. Next slide. Yeah. So my word, no, go back, sorry. Yeah. So I have said most of these things, but there are a few points that now I want to make. So I am now today almost 72 years old. I was born in 1952. And the important point was that I was very lucky to be born in a family which valued education. And actually it was a family only with girls. And I think there is a point here. And my mother herself was actually somebody who finished her bachelor's degree after 3 of her daughters were born, and the master's degree after the 4th daughter was born. And then she went on to do a degree in education and started a job as a teacher in a school at her age of 43. So she was doing a degree, B.Ed, in the year I was doing my BSc. Why am I saying this? I'm saying this so the atmosphere in the house was absolutely conducive for a girl to be involved in higher education. And my father was extremely supportive of her education all through this. So the atmosphere at home is extremely important, was important, and I think even today it is extremely important for a young girl to be enthused about doing education at all per se, whether it is science or otherwise. Then in 1964, in fact, I got a scholarship in the top 10. This was a state scholarship examination, and I was at time in the 7th grade. So this scholarship was actually used to be 1 rupee less than our school fee. And just for some of you to create a laughter, the school fee was 5 rupees a month. So, I mean, and the scholarship was 4 rupees a month. Now, I was actually the first girl in my school to get this scholarship. This was called a state scholarship, because my all-girls school used to teach only home science till the 7th grade. We learned science only after that. So nobody in my school got it because there was a paper in science in this examination. So somehow in my year, when I was in 7th, I went and said, this doesn't make sense. I need to learn science. I need to be able to appear for this exam. I want to get this scholarship. And then my school teachers took extra time out after the school to help me prepare for the examination. They actually took a group of us and they trained us. And then one teacher told me, please come home, because her husband used to be a mathematics and science teacher. And by the way, in my school, we had only one male teacher, and that male teacher was a science teacher. And as I said, we didn't learn science till the 7th grade. So I started going home to visit them, and I started studying science, and I got the scholarship. Next slide, please. So when I passed out of the school, that year, there was actually an essay competition. And the subject that my school teacher, our school headmistress had given was that reforms that may be introduced in my school. So recently I found actually this old article in my school magazine that I had written and which got published because this was a prize-winning essay. And then somewhere I said this, that please see this thing that I have circled. My practical experience is that this was a great, I have said this, it is correct that girls should know domestic science to make themselves good housewives. God knows why I accepted it, but I did. But however, my practical experience is that this was a great handicap in my high school scholarship examination. Our knowledge in general science was so poor in the 7th standard that I could not even describe. So then I went on to say that I don't suggest that domestic science should not be taught, but I said that I need to learn general science so that we can compete better in the high school scholarship and the SSC examination. So please go to the next slide. So, I said this, and what is the moral of this story? I think the moral of this story is that you have to figure out what you need to move on and try to create the resource. People help you if you help yourself. So, this is my message also to my young women participants in this audience. Don't sit back and bemoan, this doesn't work, that doesn't work. You have to think creatively. And that's true for all of you. That's true for whatever you see as an impediment or whatever you need, an impediment in achieving where you want to reach. And you have to figure out what is it that you need. And the second lesson actually is that you can do science quite successfully, even if your childhood was not steeped in science exhibition, in reading and knowing lives of scientists. It helps, but it's not essential. In fact, my childhood till I think 12 or 13, till I was 13, 14 years old, was spent in participating in debating competitions, in elocutions, acting in dramas, reading drama, recitation, poetry recitations, poetry writing competitions. So what is important is to develop a logical approach to look at and discuss things around us. It doesn't have to be science. I debated a lot. I wrote essays on all kinds of subjects. For example, there was a devaluation. Then I had written an essay from the student's point of view. What is the impact of the currency devaluation? But I think all that too prepared me for a life in science. So what you need in life in science is an attitude, a questioning attitude, a logical thinking process. And you must develop that. No matter, all the other things are necessary, but this is essential. Please go to the next slide. So 2 things I would like to once again emphasize. We have to analyze a situation and see what is it that we need. And as I said, for women in particular, you have to figure out where do you need, what is missing, what is lacking in your toolkit, and how do you achieve that. So in 1968, actually, I was in the merit list of the school leaving certificate examination. I was in the top 30, but I could not get the scholarship because my father's income was above a basic minimum level. So again, remember, this was because this was a newly independent, somewhat poor India. So money would go only to those who needed it absolutely. It was very little amount of money that was being given out for education by the country at this level. In 69, I appeared for the National Science Talent Search Examination, which had started about 1964. And in 1969, if I am right, about 300 NSTA scholarships all across the country were given. So this were more like, early avatar of what you call KVPY today, or what we had till very recently, KVPY. And I think your PMRF is just about the modern avatar of these kinds of schemes. And the whole point was that parents' income was no bar, but you had to study pure science. This was an effort started by the newly independent India to increase the number of young students who would be interested and ready to participate in pursuing a path in pure sciences. And for me, this actually widened my horizons beyond my little hometown, which was an education center, but still it was a limited horizon. And let me tell you, my friends, all the friends you are making here as your co-PMRF fellows, some of these will become lifelong friends. Some of the friends that I made in my NSTS summer schools are my lifelong friends, sometimes in science, sometimes just in life, but some whose advice, interactions with whom has been extremely important in my journey in the life of science. So these government programs, which are established to attract young to pure science and research, help me, and actually they help really. And as I said, you are the part of the community that's benefiting from it. So they are good things, but also remember that the bridges you build with your young co-students, your co-travelers, are perhaps the bridges which are most useful. These are the most important learning centers. And I heard already Dr. Desai, the way he was saying that you don't learn so much in the lectures, but you learn from your peers. And these are the peers that you learn. And I actually have treasured them in my life. And I hope you will also make bonds which you will treasure through your life. So from 1972, I actually received my BSc in Pune University. And then I went to IIT Mumbai for a MSc in physics. And I had these big insecurities. Here, I have studied in my mother tongue, in Marathi, all my life. Will I be able to speak English? And apart from that, at that time, in a IIT, in a total student population of about 1,000, I guess, or maybe 1,200, we were not even 50 women. And these 50 were not even all in engineering. They were not even in masters. We were all sort of, 10 in engineering, 20 in masters, 10 PhD students, and that's what it was. But the point is, that made a difference in my own life. That widened my horizons, going to IIT, again, to a very different level. And I could go there only because I had NSTS. Otherwise, in that sort of middle class in India, I would not have been able to go and stay in Mumbai to a different institute, and I would not be perhaps talking to you today like this as a successful scientist. So some very, luck or life and chance works in many different ways, and each one of them has their own role to play in pushing you on the right path. You have to grab the chances you get as best as you can. Next slide, please. So in 74, I did my master's. And as I said, women students, we had not even 50 students. And my insecurities were not about being a woman. My insecurities were about studying in an elite institute and, trying to deal with take-home exams, trying to deal with assignments. But I think, it worked very well. And in fact, I got the Institute Silver Medal And I was actually the first woman student of IIT Bombay to get it for physics. And if I go back and I remember, what was helpful? What was helpful was an extremely supportive and friendly group of classmates. We were 3 girls in a class of 17, and actually 3 of us were in the top 5. And I could not sense, and I tried to remember as much as I can, there was neither gender bias in teaching, nor was there gender bias in the appreciation of the success by a girl, nor was there any bias in treatment by class friends. So this actually speaks very well, but I cannot but also remember very protective attitude of some of my teachers for whom I have enormous respect and who I know liked me a lot. But then they said, when I was going to go to PhD to the US, they said, why do you want to go abroad? We'll find you a good PhD supervisor here. You know, you're a little girl. Why should you go abroad and staying in the US? That's really not so, easy. Whereas the same teacher with my younger colleague, one student, my 1-year junior, and we had the same set of achievements that I have. And to him, he said, why are you studying in India for PhD? Go abroad. As it happened, I went abroad. He did not go abroad. He did his PhD in IIT IFR. Both of us were equally successful. But I see today this protectiveness in my teacher as something that can hold back a girl, that can hold back a woman. So it's only now that I realize. That time, of course, I realized that it was being said out of concern. But when you come in your life, when you become mentors, please remember that you should not, let these kinds of thinking impact your advice or mentoring that you give in future, either mentoring to your younger student colleagues or advice to your co-students. Make sure that it is not impacted by your perceptions about gender stereotypes. Anyway, in 1979, I came back from the US, and I had actually at that time 2 other offers for postdoctoral positions. One was from Europe and one was from US, and I came back. I came back because I had had it enough. I had stayed abroad for 5 years. I wanted to be back home. I also had this great love to be part of the social system. I used to take part in teaching young women who were analphabets, and we used to go to, slum areas to guide those women. So I wanted to do part of that. I wanted to be part of the society. So I came back. But as a scientist, coming back right after my PhD was actually not a very good decision, because it is in your period after your PhD that you bloom as a scientist. That is the period when you grow, you identify your own niche, you see your own area. And if you say at the end of 4 or 5 years, people say, hey, this is your expertise. So it is very important after PhD to do a very good postdoctoral research position. But I was not advised like that. And again, I feel part of that advice not being given also was impacted by my own gender, that people didn't, I had done PhD, I was a smart student, I did good work for my PhD, I did decent work. I should not say that my PhD thesis was superlative. It was good functional PhD thesis. But I am not sure that was I a man, my supervisor would not have advised me to take one of the 2 postdoctoral positions and go ahead, get some experience, and then come back to India. But in my case, he must have felt. Unfortunately, I never checked it with him. This thought came to me only recently, and he's no longer in the world. So I didn't really check with him. But I have a feeling that somehow for him, it was enough that I got my PhD. Now, good idea. I go back and settle in life. Again, here I want to tell you a small joke. This is Sania Mirza. She was being interviewed by Rajdeep Sardesai. I still remember that interview. And at that time, she had become #1 in tennis women's doubles. and won just the Wimbledon Grand Slam. And at that time, he asked her, so when do you plan to settle down? And then she got somewhat mad, and she said, no matter how many Grand Slam championship you win, how many number ones in the world you get, a woman does not settle down till she marries and till she has a child. And this is a perception which Mr. Rajdeep Sardesai, for all his various attitudes, reflected in his question. And I think it is the same attitude that gets reflected in the mentoring that we give to young women. And this is an aspect that all of us in our life in science need to be very, very aware of. And in all this time after I came back, I think the family support and support of my friends whom I made, friends in science, with whom I was not doing any collaborative work, but friends in science who were my co-students in the science talent search examinations, my co-travelers on the path in IIT during my PhD. These are the ones who supported me in this period after my PhD. So build your support structure like that, okay? Can you go to the next slide, please? Yeah. No, next slide, yeah. So this is the 79 to 83 is the period that I already talked about. That is the period right after the PhD. I came back to India, I came back to TIFR. As luck would have it, I came back to the best possible place in India at that time. This was for particle physics, the only place in India that one had access to the most recent journals, because there was no internet. Physical review letters used to come by AML, and therefore we would get it within 2 weeks. And particle physics had a particular tradition of sending things called preprints, and TIFR was one of the few institutes in India which would have access to the preprint list. So I was in a place, though far removed from the center of high energy physics in the West, I still had access to the information. And actually I functioned quite well. I published 3 papers in physical review letters. And for those of you who may not know, for particle physicists and physicists in general of those days, a paper in physical review letters was like you would think about a paper in Nature, okay? It was as important as that. And many people don't even write more than 2 or 3 physical review letters papers in their lives. And I was able to write 3 papers in two years. And I think looking back now, I feel I could have done with more support and more positive mentoring. So I've learned from this time, and I want to say this message to, again, not just to you PMRFs, but also to the senior faculty in the audience, that we have to appreciate the gender mentoring needs to be gender neutral. And that is very important. So this is just personally what happened was in 1983 to 1993, I actually spent time at University of Mumbai, and I actually developed myself as a young scientist. So let's go to the next slide, and I will make comments on this when I come back later. So go to the next slide. Yeah. So it is this period. No, go back. Sorry. Yeah. It is this period where I developed as my own person. I created my own niche. As I said, in 1994, I went for an international conference. It was a big international conference. There was a talk on an area in which I worked. Right after I got out in this audience, in the coffee, one of the colleagues came, one of the participants, it's a conference 1,500 strong, comes and says to me, you are the expert in this area. What did you think of this talk? So this is what happens when you say, I have arrived as a scientist in my small community. I was very lucky at that time to hit upon some very interesting and very productive areas of research. And I started getting invited at all kinds of national level schools, conferences. I was giving talks. So this is part of a scientist's life, that not only you have to do research, but you have to contribute to the society by giving lectures, by imparting your knowledge to the younger students, going to the conferences, finding out what's happening in the world of science, telling to the world of your narrow, small area of science, telling to people what you have done. And this kind of exchange is extremely important in a life of science. Okay. And at that time, actually, this going to conferences and so on also helps you. I'll tell you in a very interesting manner. That it was this period, 1979 to 1993. 1993, I moved to Indian Institute of Science. In this 15 years period, I was still developing. I still was not completely happy with the successes, with the achievements that I had, perhaps. Academically, yes, I was, scientifically, yes, but still, I always felt, I needed more support. I needed more time to do my research. And I was getting bogged down by things that were not useful for my scientific research. And I was a bit, perhaps not receiving the accolades or receiving your Young Scientist Award or whatever. And I was questioning myself, am I just not good enough? And at that time, after a conference, I met a Japanese physicist and we were both traveling back together. At Frankfurt Airport, he went to catch his flight to Tokyo. I was running left to catch my flight to India. And then he said, by the way, are you the same Godbole who wrote such and such paper? I said, yes, I am the author of that paper. And then in the middle of the airport, this guy bows down to me and says, I respect that paper. At that one point, all my displeasure about not having got XYZ award or not having got a WYT honor, all fell apart. Because what is most important to a scientist is this kind of appreciation by a fellow traveler on the path of science, where he or she says, I like what you do. This is wonderful. So this is the thing that we all live for as a scientist. So please don't be affected by on your journey if you don't receive the accolades which your colleagues receive, which you think you will deserve, but you don't get them. Because those accolades, then it's nice to receive them, but they don't measure you. They don't define you. What defines you is your research. What defines you is your academic scientific achievements in terms of as measured by your co-travelers. In this period of 20 years, 15 years, I became an expert of sorts in colloidal physics. I was guiding PhD students. I worked on international collaborations, and I actually got a lot of international recognition. But mind you, this was super hard work. The day had to have 48 hours, so to speak. Next slide, please. So there is no free lunch in science. That's really what I want to tell you. And 1992 to 1984, this was the period when I started getting some of the rewards and awards. And actually, I think the first one came from my revered IIT Bombay, which selected me to be a IIT Bombay distinguished alumnus. And I believe I was one of the first few, perhaps I may not be the first, but among the very first few women who got a distinguished alumnus award. And I was certainly one of the first few in basic sciences. Then I also got elected, in Fellow of Indian Academy of Sciences, also Indian National Science Academy. And there, actually, I was either the first or the second woman in physical sciences. That is when I realized, I think it was this time, that I'm beginning to realize that why do I not have more women anywhere at this level? As far as personally I'm concerned, all this provided the Nucleation Center for the awards and rewards, and they kept on coming. As I said, it was good to get them, but I don't think, and I rightfully think, I did not let them define myself. And I would request you also not to let awards and rewards define you. Next slide, please. And then finally in 1994, I moved to Indian Institute of Science. Again, this decision to move to Indian Institute of Science was actually driven by personal reasons. And this is an important part of a woman in life of women in science. This was one opportunity by which me and my ex-husband could spend time together, because we conducted a marriage across 2 continents for something like 10 to 12 years. And along with me, in my age group, there were many friends, women friends, and of course the male, their partners, who conducted lives in 2 different institutes, 2 different towns in the country. In our case, it was 2 different institutes in 2 different continents. And that, I think, is perhaps one of the biggest challenge that many of the young women scientists also face, having jobs together. The two-job problem. Okay. But I moved to Indian Institute of Science because of that. Okay, as things happened, the marriage didn't stick around, but professionally, it turned out to be a good move. And then, I got more and more interested in science administration also. And it is not the administration of your institute, that can also be. It can be a director, associate director, dean, but there is also part of scientific administration when you start becoming members or chairs of advisory committees, of editorial boards, of selection committees. So these are also parts and parcels of a scientist's life that you have to contribute to all these parts of the life of science in the country. And you cannot just say, oh, I have time only to do my research and be in my lab, so please don't ask me to review papers. Please don't ask me to review grant applications. Beyond a certain time, you cannot do that. Because if you do it, you lose the, how should I say, you lose the chance of contributing positively to the growth of the science and the scientific community in India. And that too is an important part of the science of doing science. And when I was doing all this, when I was taking part in all these activities, I actually realized that women do have a special edge when it comes to setting up collaborative efforts. And science these days is becoming very global, is becoming more collaborative, and therefore there is a distinct advantage if we will have more women participating in the process. So again, this is one lesson or one moral that I want to give you. Next slide, please. So, at all this time, I was still continuing on my life in path in science. So I was guiding students, I was writing papers, I was writing my 5 papers a year, some of them in physical review letters, some were in physical review D. I was, part of international advisory groups. I really have had an international profile. I also wrote the book on supersymmetry that my friend talked about, mentioned before. And, as a scientific life, I think I was performing at many different levels. But I had not thought very clearly about gender and science till about 2000. I had never thought of myself as a woman scientist. I had wanted to be considered as a professional, and I wanted to be valued for my science, not get some special dispensation due to my birth. That is from my side. But from the other side, it would have helped if people had realized and considered the spatial needs of the gender-dependent needs of a young woman researcher, like having accommodation on campus. Okay. Now, there is nothing special, a woman in Indian context. For example, if I'm in IIT Kanpur, I would need accommodation on campus, or in IISER Mohali. I don't think I can feel myself very comfortable finding an off-campus accommodation as a single woman. In fact, the reason I didn't accept an offer of job in IIT Kanpur was that I didn't feel safe enough. So institute authorities have to realize that there can be sometimes gender-dependent requirements of things, mundane things, such as housing. And that is an aspect that I realized only now, after the end, almost, at the end of my life, professional life, and I'm looking at these things through a telescope, as it were. Then in 2019-21, actually, I was lucky enough to get the 4th highest Indian civilian honor and one of the highest French civilian honors also. Say that felt good. Next slide, please. And as I said, around 2000, 2002, I started looking at things through a lens of equity. And I realized that women do suffer due to the bias. I cannot say personally for me that the bias stopped me from achieving things. But if I were of a different gender, I might have got here sooner and perhaps with less effort. So from then I have been working on women in science, and I have brought out, as you have heard, brought out 2 books. I have directed the surveys. I have participated in writing many reports. I have put in place many programs for women in science. And part of the reason I'm talking about these things to you is also a part of my advocacy for women in science. Next slide, please. Next slide. Yeah. So I want to tell you that there can be something which I call invisible bias. And this invisible bias is perhaps unconscious, it's unintentional, but it exists. It was there in the comment that my professor made for me when he said protectively, why do you want to go abroad? So we need to be open about this elephant in the room. Sometimes it may come from good, sort of from a well-wisher, but sometimes this invisible bias may be coming from a different origin. And we have to see how the challenges that women face due to this bias can be eased. And this is the thing in which you, my friends, my student friends, you can be proactive in your labs. When you are working with your women's co-students, just be proactive. Just think of this in a proactive manner. This is also for us, for senior people, when we mentor, we have to realize that we are not mentoring, letting our mentoring affected by our invisible, unconscious biases. Next slide, please. So it's very close to my end. So I want to tell you a very simple and nice quote from Jennifer Doudna. And she is the Chemistry Nobel Prize winner in 2020. And she said, we need to ensure that women feel welcome and enabled to contribute fully to the society in whatever way they feel is important to them, whether it is through being moms or being involved professionally or some combination. So you don't decide what is good for a woman, what she can do or what she cannot do. Let the woman decide it. If she is your partner, you will decide together with her in partnership how to handle the difficulties, how to handle the responsibilities. Because it is clear that only a woman can bear the child, but then everybody can rear a child. So when you go on in your life, get your partners. If the partner happens to be in science, please remember this, that you don't make choices for your partner out of your ideas of what a woman should or should not do. But do it together, do it through consultation, and then you can never go wrong. Next slide, please. Next slide, yeah. So what helps? What helps is an extended family support, either family support or extended family support. And here I'm telling this to my women young friends who are in the audience and who will go on to become scientists in their lives. Please don't feel guilty about asking for help. I think my generation was a funny generation. We thought we had to do everything. We had to be super moms, we had to be super wives, and we had to be super scientists. It cannot work that way. You have to have support structures and you have to learn to build your support structures. That was one message I gave you in the beginning, that you have to identify what will help you and then try to create that support structure. Some of it can be because of your gender, because of the extra responsibilities that you have. And to these women, my message is, don't feel guilty about asking for support. And to my male friends, that don't realize that there can be a gender dependent need of a support structure. For women, I would like to give another message. Do a reality check. Be confident when you choose what you want to do. Don't let others decide for you. Don't try to be a superwoman. And it is very important for you to develop your own support structures, your own aims, your own targets. Life in science is not necessarily easy. It's a bit of a hard life, but all good things cost it. And all I can tell you, it is all worth it. Especially for me, it has been worth it when I've been working in an exciting subject like particle physics. And all I can do at this point is wish you all the very, very best in all your future explorations. And I hope that some experiences that I have described to you of some help to make you think about how you should treat the atmosphere around you so that it is gender neutral and it is, gender friendly. Thank you very much. I think this would be enough.
Thank you, madam. It was great listening to you. And, we admire the passion with which you have spoken and the passion with which you have prepared all the life experiences in the form of a presentation. It was very fascinating to listen to you. Thank you very much.
Thank you.
Professor Khakkar is also here. Professor
Hello.
Muralidhar from IIT Kanpur is also here.
Hello.
And Professor Desai is also here. I am
Yeah.
also graduate, the alumnus of IIT Bombay. We have met you several times in IIT Bombay.
Yes.
You
Yes.
may not, we may not remember, but
No,
thank
no,
you
of
very
course.
much for giving this wonderful talk. We probably will not be able to give you physically a memento, but we will send the memento as a token of our appreciation to you by
Thank you.
post.
Thank you.
And we have probably an memento for you. They were little hesitant to give you. So what will you do? How will you give? You'll show only. Okay, come.
Yeah, I think showing is good.
I can. Okay, this is a.
Yeah.
This is a.
It looks very good. I can tell
Yeah,
you
this
that.
is a shawl which is of Maheshwari silk,
That's
which is
great.
famous in Indore.
Yeah.
And
Thank you.
there is a small memento which says that with best compliments from IIT Indore.
I shall
Thank you.
treasure it. When I receive it, I shall certainly treasure it.
Sure. Next
Thank
time we would invite you to visit IIT Indore. So let's plan like that so that you can come sometime.
Actually, just as a matter of interest, how many women are there in this PMRF symposium?
There are many, I feel.
Close to 900, I believe.
Women. I see. Great.
Scientist.
Probably think you,
Of course, you know her probably.
you have to do the camera.
Camera that side. You know her?
She may not remember.
So right now, I'm not able to see very clearly.
Deepa, huh?
Mr. Deepa Venkatesh from IIT Madras.
Oh, hello. Yes. We have met in IIT Madras recently.
Yes, we have met. Yes.
Yeah, yeah. Hello.
Participation women, how many are there?
We have a total number of about 3,700 fellows. About 40% of them are women.
No, I'm so happy. Then I'm happy that I talked about this because it's to them. Actually, maybe I can give one small information that there are last 3 slides that I have not talked about, which are actually what I think are more for directed at women. So since the presentation is with IIT Indore, those of you who are interested can just take a look at those last 3 slides because those are kind of do's and don'ts as far as I am concerned, particularly for women.
Thank you, ma'am.
Okay. So it was great to be a part of this, though virtually, and my apologies that I couldn't make it, but I think Dr. Khakkar had seen me with a stick last week. So right now my knee is making it impossible for me to travel, otherwise I would have made it there. So wish you all the luck for the symposium and bye-bye.
Thank you, madam. Thank you.
Bye. Bye.
So we'll take 30 minutes lunch, quick lunch, and assemble here at 2:15. Yeah, those who are wanted to stick the posters, we still have the poster session in the night. So you don't have to worry about it.
वो भी mic है. Do the mic.
Welcome back, everyone. Let's get started with the second session. Our next speaker is Dr. K. Muralidhar, who will be talking about an envious journey with experiments. He is a professor of mechanical engineering at Indian Institute of Technology, Kanpur, where he has worked since 1987. He earned his PhD from University of Delaware in 1985. He is a very accomplished and thorough researcher, and along with this, he is a very excellent teacher. So with this, I would like to welcome him on the stage.
Thanks. So, good afternoon. This is the title of my talk. Somehow it seems to be tilted towards experiments. I'll try to explain what I mean by it. So some generalia, not too much, then some case studies, closing remarks. So I should congratulate you first on starting your research career. So like it was pointed out, expectations are very high, though each person is working on his or her own topic. The work will be expected to be original, have high utility, should have tremendous impact. There should be an element of rigor and scholarship. So all angles would be used for evaluating the work that you carry out. So when you begin, the question that appears in front of you is what should be the direction to be, or what are the tools to be adopted? So here I may say that modern thought or modern scientific thought used to rest on theory and experiments. They would say theory is theory, experiments are experiments. But now we say theory, simulations, experiments. This word theory is now connected to a lot of abstraction, abstract thought. PhD being a sort of a short duration program, you may not end up doing too much of abstraction. So we are left with simulations and experiments. So, of course, there is understanding that both are important. Simulations can be strengthened with experiments. Experiments, of course, are significant, but can be understood better, interpreted along with simulations. Combination is ideal, but like all ideals, it is hard to achieve. So the thrust of my talk rests on this observation that recent trends show a shift in research that relies excessively. Of course, you should rely on simulations, but there is an excessive dependence on simulations. Reasons being, computers have become very powerful, algorithms, all kinds of new algorithms have come up. Software packages are available. AI tools are coming in to interpret your data and actually develop theories. So simulations are able to feed your imagination much faster when compared to experiments. So in contrast, experiments have some glaring weaknesses. First of all, it requires infrastructure. It requires cost, money, time. It's a slow process. So if you look at modern technology, if you look at leading companies around the world, whether it is government or private sector, the cost of simulation in research, simulation is to experiments could be as high as 1:7 or 1:10, experiments being that much more expensive. So and these research labs and companies are willing to go for this higher investment. So there must be a reason for it. Part of the reason is experiments have natural advantages. They are grounded, they are connected to the natural world. There are fewer approximations. They, in a way, indicate the technology that needs to be developed. And experiments, for some reason, tend to be more believable when compared to simulations. So in addition, there are technologies like your mobile and app and all that, but there are critical technologies where you simply cannot ignore experiments, even the usual passenger aircraft, unless it has been tested thoroughly in experiments, nobody is going to travel in it. Because of recent development would be UAVs, autonomous systems. Autonomy is a simulation aspect which you have to test out in the field. This healthcare devices, I'm involved in one such development. The device that is developed has to go through years of animal trials. It has to ensure the animal survives. After that, it goes for human trials for years together. So just imagine the time it takes. And also, you can imagine that it's experimental in nature, even though the initial part of the device development could involve simulations. Having said that, I should be slightly careful. Simulations do help you they give you detailed bits of information. Quick assessment of alternatives. So I was talking about that biomedical device that is really a blood pump that we are working on. And the question is, if I change the blade angle a little bit, how will the design change? Making the impeller all over again requires a high temperature additive manufacturing machine, which very few places have. So, but in simulations, you can change the blade angle and see how the performance of the pump changes. Most modern devices operate close to their optimization or optimal point. So if you have to search for the optimum, then you have to carry out a large number of simulations, which are much cheaper than experimental tests. So new development that I have been advocating is online decision making using digital twins. This digital twin is a virtual but realistic simulator. It's a simulation device running in parallel with the physical device. So physical device is running, simulation device is also running. And when the environment changes, the simulator will tell you how the real device should respond. And you can check if your real device has responded in that manner. And so that way the digital twin acts like a supervisor of the physical device. So you as a student, when you join an institute, you will be provided with a set of resources, maybe a wind tunnel or a high performance computing system, microscopy, SEM, TEM, and so on. And then you will be working in a person's lab. The lab will have its own strengths, its own group, its own resources, its own ongoing projects. So that will narrow down your space quite a bit. And then you end up working in that particular field. So you may not have too much of a liberty to say, I will do experiments or I will do simulations. So the other factors may, in a way, determine how much of experiments and how much of simulations you will actually carry out. But my recommendation is that you maintain a blend of experiments and simulations in your work. And I do feel that in the present era, we need to strengthen the culture of experiments while doing research. So that was the generalia, why I think experiments should be given particular attention without in any way diminishing the importance of simulations. I will give you some examples. So this is not a technical seminar, so I'll try to keep the examples as superficial as possible. These are drawn from, the pictures are all drawn from the past work of my students, but I have not given their names, just to help you focus on the slide itself. There are some videos. So before I go into test cases, maybe I can quickly repeat this previous slide, overall recommendation that I just made. That, of course, you will be limited by the institute and the group you're working with, but I recommend that you maintain a blend of experiments and simulations in your research. And I do feel that there is a need to strengthen the culture of experiments overall for various reasons. So now I'm going to show some test cases from my own lab without naming the students. All the work I'm going to show will be the work of my past students. Try to bring in some videos here and there, so it becomes, that will animate the discussion. So the moment, so I think, okay, my background is mechanical engineering, more specifically fluid mechanics, heat transfer. The moment you say fluid mechanics, this vortex shedding, quite unusually, your slide also, Dr. Kakkar, had some vortex shedding in it, but that was from a simulation. Anytime you disturb the flow, the other side, those disturbances have pronounced oscillations. They're called vortices. It's a subject that is extensively studied. I just showed, I'm not going to explain the setup, but the point I made earlier was setting up the experimental infrastructure is very slow, expensive, takes a lot of time. And then you have to integrate your measurement system with the experimental apparatus. So I just wanted to make that point. So here, this video, can you see the hand? So that video is a flow past cylinder whose cross-section is a square, and you will see alternate shading of vortices. On the right-hand side, it is the same cylinder which is given oscillations in the same direction as the flow. Now, if you ask a simulation person to go from one configuration to another, you will see that there are plenty of complications reproducing this data in simulations. But these come out, so this is the, you can see alternate shading of vortices. And the next one is, this is, see the shedding patterns can be controlled. That's the whole idea. So here small amplitude fluctuations are given. And the flow patterns. So experimentally you can investigate very complex flow fields in the experimental framework, which is not as simple in the simulation. Just a slide to show that the wake patterns, the disturbances can be suppressed even by mild heating of the object. So you can see that as you go from the top, where it is practically no heating, as you go down, last row has mild heating, maybe 30 degrees Celsius above the ambient, and the plume is completely suppressed. All disturbances are suppressed. So these experimental images. So let me show you some data. On the right-hand side, you will see all curves. They are like that, and then there is a sudden drop. That is when the wake is suppressed. So any such transition, people studying not just fluid mechanics, any kind of mechanics, they realize that all such transitions are very hard to predict. And particularly your simulations have to be very high order accuracy. They have to be invariably three-dimensional before you can get that jump. The jump I'm talking about, this kind of jump, which in experiments you can see quickly. Simulations would take a lot of time. And so these experiments were done, let's say, around 2005, and simulations have come out maybe 10 to 12 years later. Okay, this is another example of jets. I think most of us know is water coming out of a tap becomes disturbed very easily. But Reynolds in his experiments, this is not Reynolds number, another Reynolds, showed that with certain types of disturbances, the jet would bifurcate. So one jet coming out bifurcates into two. So the left-hand side, those are experimental smoke visualization images. So we did simulations. So large eddy simulations. This initial part, those are called ring vortices. Those come out well, but this bifurcation is quite hard to simulate. So, but there is a gap. You can see a gap of more than 10 years between the experiments of Reynolds and the simulation data. So of course, I'm not showing you quantitative comparison. So the size and strength of the vortices and the angle of bifurcation. So those are there in the papers that we have published. So Reynolds also showed that with some specific kind of disturbances on the inflow plane, the jet would bloom. So on the left-hand side are experimental images. Then I have just shown a video. You can see the jet coming out and blooming into multiple branches. By varying the disturbance parameter, you can control the number of branches that come out. So in our simulations, we managed to match the strengths of the vortices and the number of branches that are formed. But the point is, it's a gap of more than 10 years between experiments and simulations. Just want to point out that there has been rapid growth in experimental techniques also. We're able to do a lot more now than we could even maybe 2 decades ago. One classic example is measurement of wall heat flux. So many of you, with this temperature measurement is absolutely common. You can measure temperatures from very low values to very high values, and there are dedicated sensors available. But if you say heat flux, then practically nothing is available. So, but from application viewpoint, it is heat flux that you want. So I'm just showing you, but still this picture below shows the kind of very elaborate experimental setup you have to build and all the instrumentation that goes with it. Here I'm showing you heat flux measurement using liquid crystal thermography. So the experiment is that's a flat plate and flow going from left-hand side to right-hand side, and there is a disturbance that we introduce. We want to show that heat fluxes are very high, close to the point of disturbance. And because of high heat fluxes, that region will cool down faster. And if the red is, this blue is high temperature, and as it becomes cooler, it becomes reddish. So that you will see in the video. So you can see blue becoming green, becoming reddish. Flow is from left to right. And with this data, you can determine the heat fluxes distributed over the plate. So right-hand side is again an experiment in which it's chaotic convection resulting from combined rotation and buoyancy. Doing this experiment, measuring velocities, measuring temperatures inside that fluid zone is a challenge. So I'll just show you these color pictures. These are not just visualization, they also help you do the measurement of both velocity and temperature. This is a chaotic convection. I'm not giving you the graph that actually compares temperatures and measured versus experiments. Just want to show you the power of experiments in covering a lot of ground. One of the criticisms was that simulations give you so many details and experiments don't. I just want to show that with experiments, but with a lot of investment of time, effort, energy, it's possible. So this is going to be the tone of my talk. I'll be giving you some examples. They are in a way arranged in chronological order. So what I'll show next will be more recent. This is blood flow. It's something I started working on a few years ago. If you look at videos of blood flowing in arteries, ordinary videos on YouTube or anywhere else, they show all the RBCs punching up towards the core of the artery, core of the tube, away from the walls. So if you think of particle concentration, it is low near the wall and high near the axis. And a theoretical explanation, of course, by theory and in a simulation framework, was not clearly stated till recently. So I'm not saying that we developed this model all by ourselves using inspiration from past work. We developed a diffusive flux model in the blood context, and we were able to show that RBCs will indeed migrate towards the axis. So this is a topic I'm working on. It deals with dropwise condensation of vapor on a vertical surface. The application is water purification. So this is in the evaporation condensation framework. If you want to maximize the amount of water that you produce, then you have to maximize the condensation rate. But surprisingly, if you increase the temperature difference, then you form a film and condensation rate actually becomes small. So you have to extract water when it is in the form of droplets. So that's why this dropwise condensation. This picture above is a model that we developed starting from nucleation to growth to coalescence to instability, forming a condensation cycle. And below is an experimental setup where we created a vacuum environment in which vapor would condense and we would produce water. So here the simulations are ours, experiments are also ours. Just a picture, this will run jointly, but it has to be evaluated a little more closely to see how similar they are. So this is left-hand side is animation of simulation data. Right-hand side is the real video of water being produced on that surface. Now, to do analysis, you have to evaluate on a frame-by-frame basis. So this green is all experiments, and the red is simulation. So of course, in simulation, we represent the drop as a circle. So in experiment, you get the real drop shape. So this open patch, that is when water has fallen off, and that happens at this instant. So you have to match. You may not be able to do a point-wise comparison, but you can do the drop size distribution, experiment versus simulation at various instants of time, various orientations of the surface. This, I would say, is a hard problem to solve because you have interfacial phenomena, phase change, heat transfer, fluid flow, all of them together. So while dealing with this condensation problem, we found that two large drops joining together, it's called coalescence, is a very important step. It's very important because it's very useful because the drop becomes very large and it gets drained away. But it also generates very large shear stresses on the substrate. These substrates are all specially treated. They're all hydrophobic, preferably super hydrophobic. So the coatings get damaged by the shear stresses. So we started a separate line of investigation looking at coalescence of liquid drops sitting on a, not in free space, but sitting on a substrate. So here you can see this, the right-hand side, those time instants, timestamps 0, 1, 2, and you can see 7, 9, 11, they're all milliseconds. So you need, and the drop size is like a couple of mm. So you need high speed, high resolution imaging to just see the whole process. So again, there is, if you read the literature, you will know that there is a race going on. We have come up to some 9,000 frames per second, and the world is talking about 20,000 frames per second. But then we had a collaboration with somebody who had a 30,000 frames per second camera. So study is it's an ongoing study. And then we also carried out simulations that is shown in on the left-hand side. So we are able to reproduce that bridge formation at the interface, bulge formation. Most importantly, the two drops, after they coalesce, will recoil. See, this is recoil. The drop has lifted off the surface, and that also we see in the experiment. So the instant of recoil, duration of recoil, height of recoil, all these have to be carefully reproduced if your simulation. Now these simulations turn out to be, these are again interfacial phenomena, moving interfaces. And I'll mention briefly that the most important aspect is how the liquid gas boundary moves on the solid surface. Just take a look here. So left-hand side is simulation, right-hand side is experiment. So unless you evaluate frame by frame, you're not going to see that the two of them show a good degree of match, because the scales are also slightly different here. But you can do this kind of a comparison with elaborate measurements on one hand and elaborate simulations on the other. And when you do them together, I think there is definitely a gain in terms of insight. So this is the very last part of the test case, where I want to highlight the fact that what happens at the liquid gas boundary over the substrate. It's called the three-phase contact line. Three phases: gas, liquid, and the solid surface. On that, the liquid boundary moves. Those who are in the field must have heard of the no-slip condition. The no-slip condition is violated. It's often called a singularity. So anytime you have to model a singularity, heavy amount of theoretical understanding is required. So here, this is water drop, which is placed over super hydrophobic surface. It's Glaco is like a water repellent. Just show you this is an experiment. So you can see the total time is like 10 to 15 milliseconds. So, it's a slowed down video. If you do it with your naked eye, you will see nothing. This is Glaco. Then if you do it on PDMS, which is like a sticky surface, so it spreads and gets stuck. Water gets stuck on that surface. So we are studying all this from the water production perspective. That is the big application we have in our mind. So because it is stuck, the interface shows large oscillations rather than the drop itself bouncing off. Now, what do we do? This is, so if you want to understand this phenomenon, you may seek to develop a model. So that, so when we approached this subject, fluid flow is determined by Navier-Stokes. Interface deformation is given by surface tension. And what is, and if you just use those two, you will never see a match between experiments and simulation. You need to address the contact line singularity properly. So I'm just showing you that model that was developed by our previous student. Is that formula given at the base. And then we carried out this first line. This is experiment. And second line is simulation for the Glaco type. It's just a frame-wise placement of the video you saw. So you can see this recoil and drop deformation. There is It's not exactly a donut, but it's a flattened surface that you can see at certain time instance. And this is a 40 milliseconds, but the transients last for about 200 milliseconds. So then it's a smoothly dissipated subsequently. If you look at PDMS, you can see in experiments also that the drop is pinned at the base and there are large oscillations of the interface. So particularly 11.86, you can see large interface deformation. And then, so this just compared the shapes. I have to emphasize that this level of match can be obtained. I think you have to call what? Yeah. Mm-hmm. Huh? Oh, no, it's all right. Yeah. Some loose connection here. But of course, if you have any questions, you can ask in the meantime. So how many in this? There it is. Yeah, okay. So I was on this topic of droplet dynamics because it is so important for the subject of dropwise condensation, which is important for water production. So we are getting into some surface engineering domain. See, when you make a superhydrophobic surface using Glaco and you use it for dropwise condensation, it does not survive for more than a minute or 2 minutes. It gets leached out. The stresses are so high at the drop level. Velocities are finite, surface areas are small. So we are now aiming to make our surface pillared. Ideally, the pillars have to be deep relative to their cross-sectional area and the pitch. But getting pillars of that type, so we in metals was turning out to be a huge challenge. I don't know if it was institute specific challenge. So I have not, I went to all the labs, I couldn't get it made. So we finally had it made in the silicon wafer. And then we have managed to make some pillared surfaces with copper. So the initial studies, we are really going to study dropwise condensation on such surfaces. And we want to see if the age and longevity and water productivity, they're all maintained at as high a level as possible. Before that, we are doing all these drop dynamics, drop spreading and drop coalescence experiments jointly with modeling. So a lot of it, see, when you do chemical coating, uniformity is practically assured. But when you make pillars, that homogeneity has to be very carefully enforced. So you have to make a sample and then see it under a microscope. And if you have made your pillars right, then like in the blue picture, your drops will sit on the pillars and surface is effectively hydrophobic or super hydrophobic. And because they are made of rigid, in fact, metallic metals, the life is quite good, could run into several months to a year in the water production perspective. So let me show you this drop spreading on a pillared surface, the video, which looks very much like drop spreading on a coated surface. So because the gap is very small, the interpillar gap is very small, liquid does not penetrate. It's resisted by surface tension, and effectively you have this hydrophobic kind of behavior. So you have to tune your pillar dimensions to serve your purpose. Of course, this journey, there's a separate journey on how pillared surfaces can be made. It's a very long story. So that anyways, that is the real world gain that you get when you indulge in experiments. But in simulations, you just create rectangular pillars in your mesh generator. So we have compared simulations with experiments for the pillared surface. Overall, let's if you put a coating over the pillars, you get some patterns. These are shown here, and they match the second row is simulation, first row is experiment. Okay, so if you put a partially wetting surface coating, then that liquid drop can pierce the pillars. So that trend we get both in experiments and in simulations. So overall, in terms of time scales, interface deformation, and of course the fluid speeds. See, if you analyze the frame rates, you can also get typical velocities attained in these liquid drops. So I think that was my last example. So except for the fact that making experimental setups, having suitable instrumentation requires time, effort, money, and can be a source of delay for students. It's of course a real factor, but experiments can be a source of new observations. In fact, in our field, mechanics in general, most important observations came from experiments first, followed by simulations. And simulations, via modeling, they have kept pace. So model development emerges from experiments. Of course, simulations provide enormous amount of additional information apart from just supporting your experiments, no doubt. So ideally, in an ideal world, experiments jointly with simulations will lead to better understanding and impact research quality. But what is happening is, because of the first factor, experiments, I feel, are being sidelined. Something you have to keep in mind. Try to bring in a balance between the two. Thank you. So mic here, yeah, this mic.
If anybody have questions to sir, please ask. You can ask for now.
course, I can ask a question and I can answer it. So, yeah, please. Ah.
Qualitative comparison or is it quantitative?
Right. So I would call it a statistical comparison. Okay, that means you look at, see, there are multiple time scales of, any phenomenon. So here also there are multiple time scales. There is something happening on the scale of microseconds, something on milliseconds, something on hundreds of milliseconds. So you see if these trends are reproduced in experiments versus simulations. In that intermediate millisecond, first 1 to 20 milliseconds, that is when you have large interface deformations. Interface deformations are very small when you go from 20 milliseconds to 200 milliseconds. So you see if those time scales are reproduced in your simulations as in the experiment, number one. Number two, there are some peculiarities like recoil. So the instant of recoil, duration of recoil, height of recoil in experiment should match simulations. Normally, see this, even though it is a drop with a volume of 10 microliters, the grid you have to use may be 20 million in 3D or maybe 30 million. And when you do, this is the minimum you are doing is Navier-Stokes. On top of that, interfaces. Then there is contact line movement. So the CPU time you need could easily run into a few weeks for one run. Okay, so you have to factor that in. So if you do point-wise comparison of interface shape here and experiment, the match may be good only when you go up to 100 million. That simulation you may never be able to do. But there is, so our match at this point has been statistical in nature. That means the overall features are reproduced here.
So information this can provide which experiments can be done.
Okay, see, I'll tell you that, okay. Very quickly, I can tell you, experimentally, you do not know the velocity field, pressure field inside the drop. Immediately, you get all that information in the simulation. Suppose I heat the surface, all the problems are heat transfer related. If I heat the surface, what will be the temperature distribution? If I'm able to do such a large flow problem, very quickly I can do the heat transfer. But doing a heat transfer experiment jointly is not that simple. And now if I bring in, I replace water by, let's say, salt water, okay, or some mixture, okay. So that in the simulation, if I have set up the simulation, I can do those simulations quickly. And yeah, rather than do that, because salt water will then damage all those pillars I have created at great cost. So I don't want to do that. So, but we are going to do salt condensation and evaporation together with heat transfer. So that experiment is being planned, but those can be done. See, anytime you have phase change, simulation also becomes tricky, but those we will attempt via simulations. But then, like I told you, simulations quickly give you flow field, and not just inside, but also outside. Inside the drop, outside the drop is also, the vapor is moving. So you get that flow field also. You get a whole lot of extra information from simulations. But the experiment is what told you that there is a three-phase contact line which is moving. Unless you resolve it properly, no amount of simulation will help you.
How do you, well, what are the ways by which you can measure the correctness of experimental results? That experimental results, normally people think that, okay, I have done experiments, my results are correct. But
okay, that is why we started with a flat plate. So flat coated superhydrophobic surface. So those experiments have been done in the literature. And you also do your experiments. You do your simulations. You compare your data with published data. Then you do slightly inclined. Then you do vertical. So once you have covered some ground, your confidence is higher, then you jump into pillared surfaces. But pillared, nobody has done it. which is good news and bad news. So
Questions?
yeah. Yeah, please. So I think in 2024, there is a paper in one of those chemistry journals where they are trying to reproduce the equilibrium contact angle of a liquid drop, water drop, sitting on a specially coated surface. So this is a surface chemistry problem. I don't know much about it, but as I understand, so in their simulations, the total volume they consider is also not microliter, it's all picoliter or maybe much smaller, small amount of volume at the three-phase contact line, and they do ab initio calculations. And they try to see if the molecules will cluster, and they look at the preferential clustering of particles, and they try to get the continuum property like contact angle. So doing a molecular dynamic calculation on the scale of a drop is not possible as of today. Yeah. Even though the drop itself is small. Yeah.
Thank you for the wonderful talk, sir. Now I request Professor Joshi to honor Professor K. Muralidhar. Moving forward to the next invited talk of the session, I call upon the stage Professor Satya S. Bulsu, Department of Chemistry, to introduce the next speaker of the session, Professor Ganti S. Murthy, National Coordinator IKS, who will be delivering a talk on Indian knowledge systems and its current day irrelevance. Over to you, sir.
So good afternoon. Let's invite our next speaker. He's from IIT Indore, our own faculty. So Professor Ganti Murthy, his education PhD, he has done his PhD from UIUC, University of Illinois Urbana-Champaign. He joined as a professor here in 2019 in the discipline of biosciences and biomedical engineering. So before IIT Indore, he was a tenured professor in US, in Oregon State. And he was also a co-founder of GRW Engineering. It's a company. And here, apart from being a professor, he's a national coordinator for IKS. So he will tell us about IKS and its relevancy today. So let's welcome Professor Murthy. Thank you.
Hello. Yeah. Matrubhyo namah, Pitrubhyo namah, Gurubhyo namah, Sabhai namah, Sabhavatakrishya namo namah. Very good afternoon to all of you. And very good afternoon to all of you. This is a slightly different topic than most of you may have heard. This is about Indian knowledge systems, which IKS, which you may have heard, some of you may have heard, is the current buzzword that is going around in the country, especially after the introduction of the National Education Policy 2020. What is this IKS? And then how do we do research in this area? What is the relevance of this? There are a few questions that come to our mind. And especially given this audience where we are primarily from the STEM disciplines, and I'm going to focus primarily on those aspects. So if we talk about a few things that are there, for example, what is IKS is not currently well known amongst most of our STEM academia. And there are many myths about what is this IKS about. And then we also talk about, when we talk about IKS, the first question that comes to our mind is what is different from research? Why should we do research in this area? What is its relevance today? How can you do it? These are a few questions that arise in mind. And I'm hoping to answer those questions through my talk today. And we are living in the land of Kalidasa. So I'll start off with what he has said in Madhavikagnyamitram. Purana mityeva sadhu sarvam nachapi kavyam nvamityavadhyam santah pariksham tyatarat bhajante mudah para pratyayineye buddhihi. This was said by Kalidasa around 1800, 2000 years ago. What does he say there? He says, just because something is old, Purana mityeva, just because something is old, Nasadu sarvam, it's not good. Old is not always gold. Nachapi kavyam navamityavadhyam, just because a poetry is new, it's not something to be discarded. He was poet, so he was talking about poetry. He says very important things. Santah pariksham tyatarat bhajante. The wise do the pariksha or examine things based on their merit. And then they praise or don't praise. Mudah parapratyayineye buddhi. Whereas the fools will be led by the opinions of the others. This is the kind of approach that we should take or we take in IKS. So when we talk about it's okay. Yeah, so what is IKS? So when we talk about IKS, it is essentially the Jnana, Vijnana, and Darshana of the people of Bharat continuously, which has arisen in this land from deep experience, observation, experimentation, and rigorous analysis, with a tradition of actually validating it and putting it into practice across various domains, whether it be health sciences, technology, arts, literature, so on and so forth. And which occurs primarily in Bharatiya Bhashas, because Bharatiya Jnana Parampara will occur in Bharatiya Bhashas. It makes sense. And it is not always textual tradition, it is textual, oral, artistic traditions which are expressed through the culture of Bharat. This essentially is what we mean when we say Indian knowledge systems. Now, what makes this unique? If you look at any knowledge system, the first thing that comes to our mind is, why should we use this word Indian there? Knowledge is knowledge, right? Chemistry is chemistry, mathematics is mathematics. Why should we say Indian mathematics, Indian chemistry, or Indian medicine, system of medicine? Then, there are three things that we need to be thinking about. The first thing is the real canvas on which this thing is built on. That is the drishti, or the perspective. The perspective that makes this knowledge Indian is what makes this knowledge system Indian. Is India unique in having such kind of a knowledge system? Not really. We have Indian knowledge systems, just like West has their knowledge systems, Chinese have their knowledge systems, so on and so forth. And then that drishti is also something that actually has been continuously transmitted through parampara, or the tradition of unbroken knowledge transmission. So parampara, by definition, involves three components. One, there is knowledge curation or preservation. Second, the knowledge transmission. And the third one is knowledge creation. Without that third part, we cannot have a parampara. So essentially, paramparas are the ones that will relate the past to the future through the present. And this is a continuously evolving system. And this is something that we need to keep very much in the center of our focus. That no knowledge system is static. It keeps evolving. So even Indian knowledge systems keeps evolving. For various reasons, it has been dormant, but it is something that has been evolving. And then finally, all of these knowledge systems have evolved because there is, at a very basic level, fundamental level, there is a laukika prayojana, or the prayojana. There is some utility of these knowledge systems for this world. For the other world is a different thing, but essentially is this, in this world, they are useful also. Now, what are some of the myths? You must have heard about a lot of these. IKS is about spiritual pursuits. वो तो retirement के बाद भगवद गीता पढ़ना है, वेदा है, उपनिषद से. This is what IKS is, and it's all about Sanskrit. It's all about reading something about how great India was. It's about essentially history, and there is no science or technical knowledge in IKS. It has no rigor. Even if there is science, there is no rigor in it. There is no methodology, proper methodology. And even if it has proper methodology, it's not relevant today. What I'm planning to demonstrate through few examples is that IKS provides a unique perspective, is holistic, rigorous, innovative, and inclusive in its approaches, and which are relevant for solving current and emerging problems. Because I think Professor Kakkar was mentioning it today morning, right? That the kind of problems, no, it was Professor Desai who was mentioning it in his talk, saying that the kind of future, the knowledge, he was talking about the knowledge system, he was saying the education system about children, right? He was saying don't confine the education system of your children to what you think, because they live in a different world. Similarly, the kind of problems that you are going to solve will be very different from the kind of problems that the world has seen in the last 20 years or 50 years. So it will be different. So what is very important there is, if you can be equipped with the tools to look at that in a different way, that will be something very relevant. So one of the first principles of Bharatiya knowledge systems is that first, do no harm. Like those lion makers, that is of Panchatantra, it says, make sure that you don't do any harm in the knowledge systems. In fact, many of the things that we talk about, which are posing ethical concerns today, would not have arisen in a Bharatiya knowledge systems because of the way that it is constructed. What makes this knowledge unique is Bharatiya Drishti, perspective, multidisciplinarity, holistic approaches, and rigorous tradition of inquiry and innovative approaches. So when we talk about science, one of the things that we think about is science is as if it is a monolithic thing. Science actually has two parts. It has scientific principles, which are foundational concepts of science, and methods which keep evolving. The foundational methods are unique to a knowledge system. Principles are unique to a knowledge system, whereas the methods will keep evolving. For example, whether I do the experiments here in chemistry, whether I do the titration here in Africa or America, it doesn't matter. It's a method that evolves. Let's say some of you may be from civil engineering background, where we used to do chain surveys earlier. And then that has given way to the laser-based surveys that we do. So the theodolites and all, now they are all laser-based. So methods keep evolving. Similarly, methods have been evolving in all knowledge systems. That is not what is important. What is important is the scientific principles. Just to give you one example of the practical consequence of these things. If you look at Greek mathematics, what is it based on? Axioms. We all have heard about axioms. Studied axioms, right? And essentially you have a bunch of axioms and you prove theorems based on that. Whereas Indian mathematics was much more algorithmic in its approach. So it was all about algorithms to solve a problem. And therefore these two things resulted in, these are the two differences in the principles on which the knowledge systems have been built. And the consequences are very profound when you look at it later. Just to give you one simple example, Greek mathematicians of yore were very conflicted about the circumference of a circle. Why? Because they were all using line segments as their basically the base model. Now, triangle is like a first closed figure, right? Then you can make it into a square, pentagon, hexagon, which resembles essentially the circle better and better. So what is it that you do when you do it, take it to the ad infinitum? The size of the sides is reducing. Number of sides are increasing. Now, if I take this to the circle, it will be infinitesimally small sides summed over infinite times. No, anything summed over infinite times is infinite, right? Right? However small it may be. And they were like, how to calculate the circumference then? What did Indians do? They just took a rope and then measured the circumference. Algorithmic approach. So there is no pure mathematics in India. It's all applied. Why? Because of the kind of a thinking that was there. So these principles can actually result in very different things. So here, one thing I want to emphasize is I'm not talking about pseudoscience here. Pseudoscience is essentially as per the Karl Popper's definition, right? If you cannot falsify something through observations or even conceivable observations, then it is pseudoscience. I'm not talking about that. Different from that. I'm talking about things that can be falsified, but have different bases. So when we think about model of science, the PEL model of science, essentially there's presupposition that's based on the principles, then you have evidence from the experiments or methods, and then you have logic that connects it all. And that's essentially the science. Where does this unique adjective that we are adding to knowledge system as Indian come from? It comes from this part and it comes from this part, not the methods. Methods are evolving. So let me give you some concrete examples. Let me start off with this kind of a drushti that makes Bharatiya knowledge systems uniquely Bharatiya. So we look at reality at three levels, not just at a physical level. And one of the biggest things that Indian knowledge systems does is it does what is known as a, okay, let me ask you this question. Whenever you do science, right, how do we do experiments? We are doing an experiment and we are observing them. And we do not consider to be part of the experimental setup, do we? We are separate from it. We are observing. So it is something called as a third person inquiry. What Indian knowledge systems also accept is a first person inquiry, which in current science is many times dismissed as subjective experiences. But now we are finding that they also have value. Why is that important? It may not be that profound, you may not see the differences in a physical experiment, but when you are talking about consciousness studies at that level of reality, then these things become very, very important. In fact, the boundary of the quantum physics today is colliding with some of these quantum delay experiments that were there. Actually can be beautifully explained by some of the Vedanta concepts. I will not talk about it today, but essentially this is the kind of frameworks that we talk about in the Bharatiya Drishti. But then this kind of a concept leads to very different, profoundly different, practically relevant applications. For example, if you look at allopathy, what was the definition of health as per WHO until 2005 or so? Absence of disease. So what was at the center? Disease was at the center. And what does Ayurveda talk about? Swastha. Swastha. That means being in your own self. Health was the center. Therefore, the pursuit of swasthya was the Ayurvedic concept of health, whereas treatment of disease is the allopathy concept of basically health. What does this lead to? Treatment of disease? You're focused only on the disease, and because disease can be only in a physical body, it is the responsibility of the individual. So then you have all kinds of these manifestations of that. Whereas if you look at pursuit of swasthya, I cannot be happy, I cannot be healthy and happy because mind is also involved. If my surroundings are not happy, so essentially that naturally leads to some kind of a societal responsibility and personalized medicine. Just to give you again one very interesting anecdote. In Kerala, there are villages there where there is a village Vaidya or a doctor who practices, basically dispenses healthcare to everybody in the village. If a family is, some member of a family is ill in a particular year and the Vaidya is not able to treat it, yearly there is a sum that the Vaidya gets from every family every year for his or her own maintenance. That person, the Vaidya, will not get that in that particular year if he was not able to treat the person, because it was a job of the Vaidya to make sure that the family member everybody in the village is happy and healthy. If somebody is unhealthy, he doesn't get paid. Compare it to what we have right now. Doctors get paid more if people are more deceased, right? This is the kind of differences that it will lead to, the drishti there. Now, also in the actual manifestation of the discipline itself. So what does allopathy talk about? We all know about the reductionist approach of allopathy, right? We talk about human body, organ systems, nervous system, digestive system, then we talk about different organs, then we talk about cells, molecules, and go on and go forth. It's essentially reducing everything, and that's kind of a reductionist approach. It is something that is very valuable. Whereas what does Ayurveda talk about? It talks about the Pancha Mahabhutas. From there arose three doshas, Vata, Pitta, and Kapha, from which health is defined as the balance of these doshas, one aspect of health. And therefore, it will take a systemic approach. By the way, this was validated in a 2015 paper that was published in Science, where they actually looked at basically the epigenetic markers in many human beings. About, I think they had a sample size of, I think, something around 1,500 samples, and they could classify it into three broad categories. Now there is an entire discipline of Ayurgenomics that is coming up, where they're actually looking at the connections of these kind of three doshas to actual implications at the genome level and even at a system level. So this is kind of a systems approach, whereas allopathy is more of a reductionist approach. Both have their value. It is a different perspective of looking at systems. Sometimes some of these things will be more valuable, and sometimes the other ones will be very valuable. They are both part of the kind of the knowledge traditions that we practice currently in science, for example. So, but then they're different. That's what I'm trying to emphasize. In the enumerative classification, which is essentially the reductionist approach, you have a long list of diseases that are to be treated and the causes, everything. Whereas if you take a systemic approach, it is also called analytico-synthetic classification, which is very common. These two classifications are right now even used in the library sciences to classify information. Ultimately, at the level of that, if you look at science, what it is about, a lot of it is about classification of different categories of information. And this kind of a systemic classification, analytico-synthetic classification, is something that is exhaustive. I think it will be very good if I give you one very small example, you will be able to understand it very well. One, let's say I ask you to list all the countries that attacked India. Right? We can start off with Greeks, Mongols, Chinese, Pakistanis, Britishers, Portuguese, so on and so forth. Dutch, French, all of those. Now, if I pose the question in a very different way, this is one way of looking at things. I will ask you the question in a different way. I say, put the number of countries, all the countries that have attacked in India, into three buckets: through land, through sea, and through air. That's it. Now, all of these countries that attacked India will fall into one of these three buckets. Agree? Space, by sea, by land, or by air. There is nothing else, at least in 3 dimensions now, right? So even if you consider anything that will, somebody, let's say Maldives guys got angry and then they attacked India. So that was not there in this list. In this list, we will have to add another entry. Whereas in this list, it would fall into one of those three buckets, right? This is the kind of the systemic approach that I was talking about. And this is the enumerative approach. In the enumerative approach, you can never have a finality. Whereas this one, in the systemic approach, you can have a finality of the categories. So it's a very different way of looking at things. Neither of them is superior. Where do we use the systemic classification? Is it something that is exclusive to Indian knowledge systems? Not really. Just to give you one example of that, if I ask you to list all the possible molecules of carbon or possible molecules in the universe, that list will never be complete, right? Because we know it's not possible to enumerate. But then what do we do in science, in chemistry? We put them into things and in the element, basically table of elements, periodic table, right? And then we say all of the matter, all of the molecules will be made of these elements, right? That's essentially the kind of classification that we are talking about. Anyway, so even if you think about food, so you look at a plate of food, based on biochemistry, you will say fats, proteins, lipids, right? That's the classification that we use. What if I want to use an Ayurvedic classification? It will be based on the Shadrasas, Then it will also talk about virya, vipaka, the influence on three doshas, influence of the mind. For example, no amount of biochemistry knowledge, whether you're talking about how much protein you have, how much carbohydrates you have, will tell you why I like to eat chocolate. Right? Because I like to eat chocolate. But Ayurveda perspective can tell you that. This is the difference in the drishti. And this is at the core of what makes these knowledge systems unique. And why is this important? This is important because this is what will make us better scientists. Looking at the problems from multiple perspectives will make us better scientists. I'm not arguing again, one is superior to the other. All I'm arguing is there are multiple perspectives, and looking at a problem from a fresh perspective often can provide you a better way to solve it. So let's talk about the rigor part. I guess mein koi rigor nahi hai. If you look at this, in Charaka Samhita, which was written 2,500 years ago or more, what does it say? Purvam aptopadesha jnanam. Apta is an unbiased person who teaches without any agenda. Okay? What should we start? Purvam, start with aptopadesha. Go to a learned person who has no agendas and learn from him or her. That will give you jnanam. That's not enough. Tataha pratyaksha anumanabhyam parikshobha padyate. Pratyaksha anumana. You do direct observations and inference based on that, because you have the background knowledge now. It was given by an unbiased person. Then you experimentally validate or verify, and then you come to a conclusion. Parikshophapadyate. That is what will give you jnana. It's what Charaka Samhita is telling. This is the kind of traditions we had, and we still have, not just had, not a past thing. And then it also talks about pratyaksha purvam trividham trikalam chanumiyate. That's essentially the cause and effect correlations. It talks about retrospective correlation. So something happened in the past and you are seeing the correlation, and then it will follow right now, right? So if I plant a seed, plant will come. See, that's retrospective. So if I see a plant, there I should be a seed somewhere that should have planted. Prospective, what will happen in the future? I drop this, it will fall down after some time. And concurrent, right? I'm breaking it or something, it will concurrently happen. These are the kind of things that are three kind of correlations. They talk about that. And then they also talk about this. Vinatarkena yasiddhir yadruchaya siddhirevasa. Any result not backed by logic or evidence is equal to a random effect. And they're talking about this in the clinical studies. And then they also talk about correlation is not causation. There are positive controls, negative controls. All of these things are there. And this is not unique to Ayurveda. Point I want to emphasize is, these are part of a larger text of research methodology in India that was used. It is published in a very organized way in a text from 16th century called Tantra Yukti. There are 32 methods of hypothesis formation. There are ways in which you write your dissertation and ways in which you should not write your dissertation or a compilation. And this Charaka Samhita I was referring to, do you know what it was? It was the notes by a student in a conference proceedings that happened 2,500 years ago. That was what it was. Imagine the kind of rigor that was there. And then context. One of the things that we always think is, just because I know a language, I should be able to use it anywhere. False. If you look at that, bhakto guna shuddhyati yena tena labdhya cha gunyo gunita phalamva. So I ask somebody with a basic knowledge of Sanskrit to translate it, but not a mathematician. They will translate it as bhaktaha, devotee, gunaha, devotee's qualities, shuddhyati,
No, it
it's
is easy.
purified.
I was able to do both for Santa Cruz as well as this flat. पण झालं काय, एंड ऑफ द इयर आल्यामुळे आणि सगळ्यांचं आल्यामुळे मला वाटतं द वेबसाईट इज गेटिंग ओव्हर.
Gets purified by the devotee's qualities and things like that, right? So all of these things makes no sense at all, because what the devotee gets after purified by the qualities makes no sense, because This is actually from Lilavati. It is talking about some associative properties of large number, which you can use that for multiplication of large numbers. And yeah, and also the technical knowledge is very important. So there is something called Kunapajala, which is made from discarded meat, bones, jaggery, honey, ghee, all of these things. Is that something that is mumbo jumbo? I wondered. Actually, I wondered about it because I come from an agriculture engineering background. We are trying to improve the soil health. And then when we actually did some experiments in the lab and we found out why it works, then we were astonished because this recipe for Kunapajala was given in a book that was that's called Vrikshayurveda, published by Surapala 1000 years ago. And methods do evolve. Having said all of that, methods do evolve. I'll finish it up in another next 5 minutes. So methods do evolve. These are the scientific methods that are there in basically Ayurveda, Varitara. So they will float something on. They'll take bhasma, which is essentially a micro aggregate of nanocrystalline particles. That's what they are. So you can test it through all of these, but you can also test it through SEM, basically your TEM and all of that stuff too. But keep that perspective in mind when you actually analyze these. Many a times you may feel just, so those of you who are in chemistry, many a times these texts will describe, especially in the Siddha medicine, they will describe that you'll have to take iron particles, then you'll have to take iron in an iron bowl, take some silica in it, and then put some juice of this flower, this fruit, lime juice, grind it, then you heat it up. And people were like wondering why all of this juice, gomutra and all of these things in there, what does it really do? People were never understanding what it was doing. There was some very recent experiments done in IIT BHU by Professor Ramanathan's group, where what they have actually found was because iron doesn't melt and then they were heating it up to 700, 800 degrees Celsius. Nothing happens, right? At those temperatures, neither to silica, neither to iron. What is it that they're trying to get out of this? At the end of it, they get some ash. What they were finding out was some of these juices actually have some elements which actually are acting as catalysts, and they bring down the melting point of these two to about 700 or 800 degrees Celsius, which was the firing temperature. And at that time, it forms an iron core and a nanosilica particle, which was having some impacts on the treatments and things like that. So there are these kind of things that need to be investigated. A Sanskrit professor cannot do it. Please see, this is not something, the job of a Sanskrit professor. The text may be written in a Sanskrit document, but this is the job of a chemist. Similarly, there are many high entropy alloys. You know, how many of you heard about Aranmula mirrors? Aranmula. So India had, yeah, right? India has, that was a metallic mirror. So what was it made of? Two metals. It's a high tin bronze, about 30% tin, right? And it's a very hard thing. What makes it a mirror? You can see, you can take any surface and polish it. You get a mirror finish, but you'll not get a mirror because that is very soft. What these alloys are very hard alloys. So this alloy made of tin, which is a soft metal, and copper, which is also a soft metal, you get a very hard surface, right? Similarly, there are things called Vajralepa that are there. Some of our faculty members here are investigating that. There are the rustless iron, of course, that is something that you all know. How did we produce it? Wood steel, we still don't know how to produce it. There is something called, of course, that's called Damascus steel, but then there is something called Damas steel, where you just put high carbon alloy, which is very tough and very hard, soft, basically mild steel, and then you layer them up and then you beat it. You can get layers of that. But what the wood steel was it was essentially one metal, one material, not a layered thing. Japanese produce it this way. We used to produce it in one metal. How did we get it? It's a play of metallurgists' dream if they do it. Even in economics, for example, it's not just confined to sciences. Even in other sciences like other things like economics, capitalism talks about Shuddha Labh, only maximization of a profit. The socialism or the communism will talk about Shunya Labh, discard all profit. Let's privatize profits, socialize losses. Not really, the other way around. So, but what does India talk about? India talks about Shubha Labh. I should get profit, but also there should be welfare for the society. This could be an alternative model for the world that we can give from our country. Similarly, at the core of this, we have the ananda, pursuit of ananda, or happiness at the center. That leads to how do we thrive with nature, growth that meets the needs of all, and social harmony. Whereas if you simply look at the consumption as a center or indirect measure of happiness, it will lead to all of these other things. Consumption based, because now, and then the circularity of time versus linearity of time, very, very important concepts there. Even in terms of those intellectual property rights, we have many, many things that are valuable insights that can be provided by the Indian knowledge systems. Just to give you one example of knowledge system, because I'm from agriculture, I would like to give you that. Agriculture, you see, one of the first textbooks was written in India about 2,500 years ago. And we have over centuries, we have this kind of lineage of texts, not all of them in Sanskrit. For example, if you look at Nuska Darfani Falahat, it was in Farsi. If you look at Krishi Gita, it was in Malayalam. Someshwara Deva's Manasollasa, I think, is in Kannada. All parts of the country, all languages. Something that we need to think about. And these are other texts published by ICAR, where they actually have validated these texts and found more than 85% of the practices that are referred to in these texts and in oral traditions are still valid today. They actually did field studies and documented them. So why is IKS relevant today? Few things that come to my mind. That swasthya versus disease focus, that differences in the drishti itself, consumption versus ananda, intellectual property rights, kind of drishti perspective. Also, it is something that represents accumulated wisdom in many disciplines like agriculture. Psychology is one very important thing, because right now, many of us are suffering from anxiety, depression, a lot of these things. The approaches of India are very, very holistic in nature. There are some things that we can learn from there, even the weather sciences. And also, it provides a framework for inter and transdisciplinary research, whether we are talking about smart materials, ecologically sensitive development, or this concept of holistic healthcare, which actually, by the way, has resulted in similar frameworks for Vriksha Ayurveda for plants, and then Pashu Ayurveda for animals as well. So it is not just about humans, it's also about plants and animals. And so using some of these approaches of Pashu Ayurveda, National Dairy Development Board has been experimenting in Gujarat, and for last 10 years, they have come up with treatments for mastitis, which is a disease that cows have, right? And the highest use of antibiotics is in the industrial animal agriculture. More than 70% of the world's antibiotics are used there. And there are many formulations which are being used now, especially in by NDDB in Gujarat and all those places, where they are treating these diseases without the use of antibiotics. Now, look at the consequences of all of that. Antimicrobial resistance, all of those things are consequences of overuse of microbial antibiotics. And then consciousness studies. There are all the things that are always there. But make sure that whenever you talk about a text, please do identify it as an authentic source. Need to look at a primary source, secondary source with all that commentary and things like that, right? And then make sure that it is coming from multiple independent sources. And what do I mean by examples? So for example, if you look at it, novel deep learning approach for classification of EEG signals of driver distraction while conversation with passengers is not an IKS project. On the other hand, science, religion, convergence, interconnectedness is also not an IKS project. Eternal Visions, exploring the Upanishads' influence on Western literary discourses of consciousness, can be a IKS project. Robotic wheeled vehicle for trending societal needs is not an IKS project. Whereas looking at the combinatorial approaches for management of soil fertility, microbiome, plant health, based on the Kashyapi Krishi Paddhati and Jiva Mritika Mishran is an IKS project. You see, it requires blend of modern knowledge plus the traditional knowledge. And this is where you all can, as young researchers, we all look for a break, right? What is the break? It is always the areas that well-tread paths are not likely to give you breaks. These are places where you can get a break because these are unexplored relatively. And more than 95% of Sanskrit literature is not about Upanishads, is not about Vedas, is not about Mahabharata and Ramayana. It is about these kind of texts where we are talking about metallurgy, chemistry, agriculture, and things like that. So I hope we'll all work on this area. And what can you do? please do think about doing research in your particular domain. There are tons of resources. If anybody is interested, I'll be more than happy to share that. And collaborate with scholars who know Sanskrit. Sanskrit is not mandatory. You can learn it, but you can also collaborate with somebody who knows it and then try to bring your technical knowledge, because that is a fundamental thing. These are not texts of literature. These are texts of technical knowledge. And then do other things and disseminate as much as possible. Because as Baba Dayam said, in the end, we'll conserve only what we love, and we'll love only what we understand, and we'll understand only what we are taught, right? So please learn and teach others. And with that, I hope this was useful to you. Thank you. Namaste.
So we'll take a couple of questions if anybody has.
Yeah. Yes, please.
Modern allopathy has a reductionist approach, while the Indian Ayurveda has a holistic approach.
Yes.
For example, this placebo effect. So scientifically, it is proven that 6% effectiveness in treatment.
Yeah.
But if you go with this approach, you can't explain why this placebo occurs.
Yes.
Indian Ayurveda.
Again, because see, what do we consider as this thing in our modern allopathy? For the longest time, the mental health was considered to be separate from the physical body, right? So you only look at it from a body perspective. Then you cannot explain the placebo effect, because there is also, we talk again of the Panchakosha model, right? We have the Annamaya Kosha, which is a physical body. Then you have a Pranamaya Kosha, which is of the different flows that are taking place in the body. Then you have a Manomaya Kosha, which is the mind. And then you have a Vijnanamaya and Anandamaya Kosha. So when you look at it from that perspective, there is an interaction between the Manomaya Kosha, or the mind, and the body. It's a very natural thing that comes into the framework of Ayurveda. Therefore, you can explain placebo effect there, because you say mind has an influence on the body as well. But if you look at it only as a collection of atoms and molecules and organs, you will not be able to explain it. See, that's where again you can use the approach. The drishti can help you.
Is relying on
Oh, yes. So this is. No, in fact, all of Western psychology is about third-person observation. You see, somebody else will give you a questionnaire to say whether I'm psychotic or not, right? But Indian methodology doesn't talk about it. In fact, it talks about how do I observe myself? And then, why is this very important? You know, right now, why did I say, I very fleetingly made a statement that quantum delay experiments, and today also we are coming to that and bumping into that boundary where Vedanta can explain a lot of these things, right? I just made that statement. But there is, in fact, if you go on to YouTube and then basically Google quantum delay experiments, just Google that, study what they're talking about. I mean, listen to that. It's a 10-15-minute video. There are many of them. Just pick up any one. And then look at work of Professor E.S.G. Sudarshanji, who was a famous theoretical physicist. Look at what he talks about. And look at the kind of convergence that is taking place when you're talking about the consciousness and even the reality. When the concept of reality is now changed. Because, see, the whole thing was essentially we considered time to be linear. What this quantum delay experiments are showing is it is not linear. So it is breaking the physics at a very fundamental level. There are no answers to that. Some of you may find some answers. I don't know.
That's the time we'll break for the session.
Thank you.
Professor Murthy. Thanks very much.
I request Professor Devendra Deshmukh, Dean of Education and Outreach, to present a memento to honor Professor Murthy.
Yeah, so we'll take 5 minutes break and then come back, 10 minutes break. Probably 4 o'clock exactly. Professor Sukhatme is waiting there. So we will start exactly at 4, the next session, which is a wonderful session because Professor Sukhatme is professor. So you'll have wonderful session there actually. Yeah. Sir, good evening. Devendra here. Sir, you are mute, sir.
Hello.
Sir, good evening, sir.
Good evening. Good evening.
Yeah, sir, we'll start exactly in 10 minutes, although we are late from this session, but we'll be in time.
Yeah, sure.
Yeah. Do you want anything to taste or something?
No. I'll be just speaking, nothing else.
Okay.
This
No.
will be a very simple lecture, common
Fantastic.
sense.
Right,
I
sir.
just want people to hear. I'll be speaking slowly and softly. I just want them to hear a little about experiences and talking about the transition which they will make when they finish their PhDs and go on to the world of teaching and research.
Yes, sir. Yes, sir. Thank you, sir. Thank you.
Okay.
Thank you.
आपला देशमुख. Hmm? I don't think. I know him, but this one. हा कोण आहे? कोण आहे? जयंत सबनीस आहे मला वाटतं. The Jayant? हे लावल्यामुळे कळत नाही. The Jayant?
Okay, now.
Okay, Jayant.
Namaskar.
Okay. Let's talk in advance before I begin the lecture.
Well, when I found out, I was sort of hoping that you might be able to actually make it here, which would have been great.
This morning I saw your name and I said, I have to see your name. It's Indore. You have to be there, right?
It is. Actually,
Yes.
it is a lot of it is also happenstance. I did not know about scheduling of the symposium when I was planning my trip.
Yeah. Okay, but good. We are at least meeting this way.
That's true.
And if you are, while going back, if you are coming through Mumbai, remember to drop in at us, at our house.
माझं जर तसं जमलं तर मी नक्की आधी कळवीन.
Sure.
And I will do that. Karan, unlike my normal trips, this time I am actually coming from Pune.
Okay.
So
let us know.
Nakki.
I'm not traveling much nowadays, not really moving around much at all, really. Otherwise, I would have come to Indore myself for the lecture today. but traveling is becoming difficult actually, whether it be by air or train or anything. In fact, I don't travel by train at all, really.
No, you are 100% right. Just up until a few years ago, I used to do significant amount of traveling.
Yeah.
These days, even the thought that I would have to travel, particularly internationally, just makes me very nervous.
Yeah. So whatever it is, remember, we are mostly, not mostly, I would say 99% in Mumbai. And you know the house also.
I know the house very well.
Yeah. Okay.
Yeah. I'll definitely show up.
बाकी काय म्हणताय अमेरिकेला? How's things going on?
Going on well.
Okay.
मी MIT मध्ये जेव्हा गेलो होतो तेव्हा माझी अशी समजूत होती की हे 1-2-3 वर्ष चालेल. आणि त्याच्यानंतर I will be fully retired.
Yeah.
आणि एक दिवस मी तो प्लॅन एक्झामिन करायसाठी बघितलं. I realized it was already 7 years.
Okay.
So it was obviously quite enjoyable. माझ्या हाताखाली दोघं जे ग्रॅज्युएट स्टुडंट्स होते पहिली बॅचचे, त्यांची PhD वगैरे संपली आहे. So I feel I have gone from start to finish in that journey.
Okay, good.
In the time that was available.
Yeah, good. That's good.
Also, something for your benefit, that I know you will appreciate. I landed up getting nominated and selected as an outstanding educator in the School of Engineering at MIT for 2023.
Okay, great. Good, wonderful.
It came as a total surprise. I had absolutely no idea this was going on in the background.
Okay, good. Excellent.
I thought you would enjoy it.
Yeah, absolutely. Good to know. A systematic approach always helps.
Yes.
No question about it. No
Right.
question. I think that was the last time we met was at MIT, was it? When I came for the
Yes.
Rosenau
Right.
lecture? That was 5 years ago, probably, or more. I don't know.
No, I think about 5 years ago is probably
Yeah,
right.
about 5 years ago. Yeah.
I know there I had asked you a question about your estimated kilowatt hours per use per person.
Yeah.
And all I remember is that my number was twice your number.
Okay.
And then in 3 days, I finally figured out you were looking at it on a per household basis.
Okay.
And I was looking at it on a per capita basis. So I forgot the fact that between those two, I need to account for the fact that a household has 2 people
4.
on the average.
2 or 4. I don't know what they
2
take.
or 4. Right.
Yeah.
2 or 4. It's not 1.
Yeah, it's not 1. Yeah. Okay.
And
Maybe. Yeah. ठीक है. Good. Wonderful. Good to see you. बाकी काय म्हणताय सगळं? At home?
बाकी होम मुलगा आता हे आहे he's a assistant professor at University of California, San Francisco Medical School.
Okay, great. Wonderful.
आणि मुलगी माझी she teaches biology in high school. म्हणजे ज्या शाळेत ती शिकली होती
Yes.
त्याच शाळेत after several years now she is a teacher teaching biology.
Okay, good.
तिला 2 मुली आहेत, so they keep me quite busy. They are twins.
So she is in Connecticut still, huh?
She is 3 miles from my home.
Okay. Good. So one is 3,000 miles away and the other is 3 miles away, right?
3 miles.
Okay.
But
Good.
at least the good part is the one who is 3 miles away has the grandchildren.
Okay, good. Wonderful. छान. ठीक आहे. सगळं ठीक आहे. Good. छान.
आणि तिकडे काय तो उदय बसलाय, लपून बसलाय, काय करतोय? उदय तिथे बसलेला आहे?
Uday is next to me, yeah.
Yeah, I thought I saw his profile.
Yeah, he's
but
very
then
much
he's
there. I'm using his laptop today, actually.
Oh. Can't do anything without them.
Yeah. त्यांचा ब्रेक किती मोठा आहे?
आता I think they are just starting.
मी घड्याळ आणतो माझ्या समोर इथे नाही आता.
Welcome back, everyone. We now begin the next session of the day. I would now like to invite Professor Devendra Deshmukh, Dean of Education and Outreach, to introduce the next invited speaker for this session, Professor S.P. Sukhatme from IIT Bombay, who's there with us online. Over to you, sir.
Good evening, everybody. It's an honor to give a brief introduction to Professor Sukhatme. Professor Sukhatme is a distinguished figure in engineering and academia. After graduating from IIT BHU, Varanasi in 1958, he pursued his studies at MIT, acquiring a master's and doctoral degree from there. From there, he... Hello? Sir, is it audible?
Yes.
Yeah. From there, he started his research journey as a research assistant at MIT, then at Dynatech Corporation, before returning to IIT Bombay in 1965 as assistant professor. That's from where he ascended through various positions, academic and administrative position. He culminated his tenure as a director between 1995 and 2000. Beyond academia, Professor Sukhatme has been chairman of Atomic Energy Regulatory Board, Government of India between 2000 to 2005, and he played a very pivotal role in shaping interdisciplinary program, which we know in the different forms at different places, including IIT Bombay. And that has a long-lasting impact on the academic landscape. As an author, he has numerous contributions through research paper, books, covering majorly topics in the heat transfer and solar energy. Professor Sukhatme's achievement, he has received widespread recognition, including prestigious awards such as Prince of Wales Gold Medal, Shanti Swarup Bhatnagar, and Padma Shri. He is esteemed as a fellow of several prominent academies and societies. So we welcome Professor Sukhatme for your lecture today and to get some word of wisdom from your side. Over to you, sir. Yeah, some of his former students have also joined, it seems, and it's really a privilege to hear from you. Thank you, sir. Please go ahead. Over to you.
Good afternoon, everybody. I hope you can all hear me. I'm speaking from the comfort of my home in Mumbai. Nowadays, I don't travel too much, so I apologize for not coming to Indore. Though Indore is a city I like. I've been there many times in the past. But age has its limitations, as you know. And one of them is it's not that easy to travel as you grow older, even by air, forget traveling by rail or by other means. So today, I'm not going to speak on anything complicated. I'm going to speak on a subject which will be of interest to many of you in the audience. And the title which the people who are in charge have given me is What It Takes to Be a Good Teacher. And I think that's an interesting topic. It's not something which is readily answered by many people. And there are you'll get different answers if you ask different people what it takes to be a good teacher. I'm sure you will. But if you come down to it, you can put things in a certain, shall I say, mode if you want to discuss it. And that's what I wish to propose to do in the short time. The way I'll go about it is as follows. I'll spend about half an hour speaking, or so, about half an hour. I haven't timed myself. But then I leave about some time at the end, maybe 30 minutes or 25 minutes for questions. And whatever questions you have on the topic that I'm speaking, that is what I mentioned. The topic is, as I said, I repeat, the topic is, as I said, what it takes to be a good teacher. And I mean really teaching at the college level, at the institute level, at the university level. I mean that, not at the school level or the high school level. That's a different situation altogether. I assure you there are differences. Now, to begin with, let me start with a quotation or two from Swami Dayanand Saraswati, whom many of us admire. from it's a book which he wrote, not he wrote, but a lectures based on lectures which he gave on teaching long ago. And I've taken some quotations from that book, not book, pamphlet, really. One of the quotations he says is, in that, which I've taken is, teaching is a creative adventure. Very short description what he thinks of teaching. Another one is, you are not creating knowledge when you are teaching. You are trying to remove ignorance while you are teaching. And again, a very clear-cut sentence of what you are trying to do. So, then in another place he says, a teacher is a person who has a certain capacity or training to teach. Okay, and then he, in his write-up, he describes that that is not taught to you. It is something you have to pick up as you go along. Training itself that you have received, now many of you are doing your PhDs or have done your PhDs or will do PhDs in the future in sciences, engineering, whatever it is. And he says, training by itself does not assure you the skills to teach and cannot definitely bring about a heart that loves to teach. It's again an important sentence. It doesn't teach you how to teach. It teaches you the subject that you are likely to teach. Okay, and you'll agree if you're doing your PhDs, whether it be in chemistry or in physics or in mathematics or in biology or in whatever engineering, you are learning something in that subject and doing research in it, getting a PhD, but it's not teaching. While doing it, you are not learning how to teach that subject. Though you have done the subjects, whatever are required as a basis for doing your research. You've seen the teachers who are teaching you, but you have not been taught how to teach as they teach. You may have noted some features which some of them have while teaching for the future if you're thinking of teaching, but you have not been taught those per se. So keep that in mind. Right? Then he goes on to say further, the training itself does not assure you the skills to teach and cannot definitely bring about a heart that loves to teach. So you see, these are aspects you need to have. You need to learn how to teach, and you need to also love teaching or love to want to teach at some stage in your career if you want to do it as your career, as part of your career later. Two very important aspects for a good teacher, a good professor. And I think in one sentence, the Swamiji says it well. He says, the training that you have received does not assure you the skills to teach and cannot definitely bring about a heart that loves to teach. These you have to develop yourself with your skills, with your background, and with your reading and with your whatever efforts that you make. That's where you come in as an individual as you go along and grow up. Then he says further, there are many trained people who do not have that heart or the skills or the flair for teaching. Though they have the qualifications, mind you, they do not have that. And they do not have the commitment also to the student to teach. There are many people, he himself says that. And then they are disgruntled with what they are doing. The student is also disgruntled with what they are doing. That's obvious. If you are not happy with what you are doing, you are not doing it well, obviously the other party is not going to be happy. Both sides have to feel that they're doing something worthwhile for us to have a magical, shall I say, exchange of ideas. So I think in this paragraph which I read out to you, Swami Dayanand Saraswati really points out that there is something to be done by the individual who wants to be a good teacher and a professor as he goes along in life, to fill that gap, though he knows the subject, to be able to convey the essence of that subject is what he has to develop. And he has to develop that art as he goes along. Nobody teaches you that art. Now, so the first thing is in life, which we all face at some stage in our careers, as we are getting our final degrees, is do we really want to teach? If you are getting a PhD, for instance, and you have done research, you have a choice. Can you switch? I can see myself. Just 1 second, please.
This way you can see it here. I can't make it full
Yeah,
screen.
that's fine. Now, so at some stage in our career, we have to decide what we want to do. We've done a PhD or we are on the way to finishing a PhD. We have a choice of what we do, what kind of career we want to do. Would it be a research career? Would it be in industry or in teaching or in something else? Maybe just administration, where there's no research or no teaching. And that is an important decision which many of us have to take. If you take a decision that you want to continue in research, that's also quite acceptable. If you take a decision that you want to take up teaching, you have to take it with care and prepare yourself for it and learn something in advance as you go along in the first year or two. So keep that in mind when you make that decision that you are going to teach. Now, where do you get the positive, shall I say, feeling that you want to teach? Sometime while you are doing your PhD, I'm assuming that all of you are going to get PhDs. Many of you who are listening to. Sometime while you're doing your PhD, you have to make presentations, of your work, or take part in conferences where you have to make presentations of your papers, and so on. And at those presentations, other people are present. Questions are asked. And you have to see what reactions you get from the people who are attending that presentation. And that gives you some indication of how you might be as a teacher. Though there are few in between, because you're just giving a few as you go along, still that's the first indication of how good you are at presenting things. And I urge you, if you are still in that stage of getting a degree, to make presentations if you are avoiding them to the extent possible. Make them, face questions, see how well you answer them. You yourself will start finding out whether you like answering questions, whether you like facing crowds, whether you like, people reacting to what you are saying, whether you like the occasional joke that you crack while you are giving your lecture. You understand? Do that. Nothing wrong. You are still experimenting with what you want to do. So please do that if you still have a chance of making up your mind of what you want to do. Because the advertisement which comes out says an institute is looking for assistant professors or lecturers, says you must have a PhD with good background, you must have so many years of research experience, so many research papers, this. Nowhere does it say you have to be a good teacher. You understand? You have to know that decision in your mind. That can come partly from the presentations that you have made. So never forget that you must start getting that input for yourself. So make presentations deliberately if you can, because you'll automatically get that input from your friends at least who attend your presentations. Now, just to give you a personal example. When I was in BHU in my final year, okay, I'm not trying to show off, but just to give you an example. I remember just before the final year, we had to do practical training, 4 months of practical training. It was quite important, the practical training in those days, in the 50s. So I was in the Tata Iron and Steel Works at Jamshedpur, 4.5 months. It was a very planned training. You couldn't touch anything in it, steelworks. They sent you from workshop to workshop. You were sent to a workshop, different workshops, blast furnaces, rolling mills, etc., etc. In each of these, there's a superintendent. You report to him. He tells you, he gives you some books to read or pamphlets to read about the workshop. He's available for any questions that you have while you are spending time there, and reading material he supplies to you. You can meet him if you want. That was the training. It was up to you to learn. They didn't make you do anything in the hands, because that was a workshop. I mean, that was a iron and steel works. They didn't want apprentices to be touching anything while it's all iron and steel moving around. That too red hot iron and steel. But you could learn a lot. There's a library from which you could take books also. Now it so happened that while I was in the rolling mills, where they rolled rails, they rolled plates, they rolled sheets, they rolled when they made wheels, etc. So many things made. While I was there in the rolling mills, I got interested in the rolling of steel. It's an art and a science by itself. There were many books in the library of the training school there. So I picked up one or two to read on my own on the side. Learned quite a bit. And then when I came back to BHU for the final year, we had an engineering society. And the engineering society had a program that final year students could make seminars, could present seminars, technical seminars in the evenings in the college hostel to their fellow students. They had to prepare a seminar. They could have rolling boards on which they could write something if they wanted, or make some sketches and present it in the hostel college common room. So I said this was a good venture. I thought of it and I said, let me try presenting what I've learned. So I again went to the BHU library, got the same books which I'd read earlier, read them, and prepared a small lecture of about 40 minutes. And it was a very good tradition at BHU. This was not compulsory. A professor of the department used to preside over the seminar presentation, and it was held in the common room. And it was voluntary. Anyone could attend. Usually final year students, and usually if you were not sure if any audience would come, you made sure your friends would at least come. You have to have some audience after all. So, I've forgotten, but there are at least 30, 40 for my seminar, and I presented it. And I had prepared it very carefully. I had some rolling boards which I had prepared, which I could roll down, on which I had written with chalk something. There were no slides in those days, things like that. That was 1957. And I presented it for about 35, 40 minutes. There were questions at the end, which were quite good. And of course, the professor who was chairing it, Professor Jain, I remember, gave some closing remarks. At the end, he congratulated me, said, very good presentation, and so on. And it went well. I was happy with it. But more importantly, some of my close friends who were attending it met me after the seminar. And one or two of them said, that was very good, they said. That was an excellent presentation. It was clear to us because you spoke at our level, and what you said we could understand fully. And one of them said, you should be a professor. And that was a great compliment to me. I hadn't even thought then that I was going to go into the teaching profession. But it was the first spark in my mind that something was there worth doing further. And it could be in the direction of teaching and research as a profession. Research as a profession I had already thought of, by the way. See, my father was already in research. He was a well-known statistician research, known for his research. And so research was in my blood. I was sure I was going to do a PhD in engineering. But that I would be teaching I started thinking about it on that day. So if you're thinking about it even, I suggest to you who are listening to me, think of it, push yourself a little, give a seminar more here, right now, wherever you are. Give more seminars, present, see what are reactions. Some may say, look, that was terrible. You know where you stand. Or maybe they're joking, in which case also you know where you stand, whatever it is. So just to give you an example, I say these are impressions which you need to form of yourself also, to judge yourself as you go along, because you have to build your own career. If you are a good student, you have to decide your career as you go along. And of course, later on, I was at MIT, and you're doing your doctoral work. You have to make presentations from time to time, every 6 months in your group, to your thesis committee. You have to make presentations, which tell you also that you have confidence in your presentation, and so on. That all comes with you, time. And invariably, I found that, my professor also used to tell me that was, at the end always, that was a good Felicitation, you've done well, and so on. He was himself a well-known professor, and anything that he said like that, I took seriously when he said it. So by the time I was through with my PhD, I knew that I wanted to do both teaching and research. I had more or less decided on that as a career. Okay, so I suggest some of you start thinking in that direction or planning in that direction as you go along, if you have the time to do it. Now, I thought I would spend some time saying, if you are in that stage, that this is the time to plan. Now, after you join, however, as I said, advertisements only say you need this, you know. So, I mean, I was in the US, the IITs were new then, and IIT Bombay had started in 1958. In fact, by coincidence, I passed through Bombay before I went to the US. And somebody who had just joined IIT Bombay then, just a few months ago, whom I knew. And he said, why don't you visit our campus? And IIT Bombay was then in its temporary campus in Worli. So I went to Worli by bus and met him there. So he told me a little about IIT Bombay. So that was really my first contact with IIT Bombay in 1958. I did not know then that in 1965, I would come back to join it and be there for my whole life, really. Anyway, that's life. And in a way, as I said, you start planning what you're going to do while you're doing your PhD. Now that you've decided on teaching. And of course, I had long ago planned that I would return to India. Though I could have stayed on in the US and all that, many people said I was silly to come back to India. I never thought so. I was quite clear in my mind that my future lay in India. And if it was in India, it was in IITs. IITs were new, Bombay was new, Kanpur was new, Delhi was new. I said one of those IITs is where I'm going to go. They are new, they want good people. I'll go there and I'll see what I can do. If I'll do well. There's no question of if in my mind. So I wrote to them, and some paperwork was involved. But in those days, IITs were very forward-looking. You know, both IIT Bombay and IIT Delhi offered me the positions without interviews. I wouldn't say without interviews. They had their own ways of finding out about me. You know, from the Education Ministry, the secretary was visiting Boston, and he wrote to me because IIT Delhi informed him that when he was visiting that he should meet me. So he wrote to me, said, I'm in Boston on this day. Would you please meet me? He was visiting MIT. So I went over, met him, and spent half an hour with me. He didn't say anything he didn't say that he knew that I'd applied to IIT Delhi, but obviously he knew that. And he sent back his impressions, which was basically like a informal interview. IIT Bombay also received some input from him, I think. Whatever it was, based on whatever inputs they had, and of course, referees, letters, etc. Both of them made me offers based on that, which were good offers, some increments. Nothing compared to the salary I was getting as a research engineer after my PhD in the USA. So many people said I was a fool to return to India. I never thought I was a fool, and I still think I made a very good decision. So that's that. Now you come back to India. You come back to a new place. Interestingly enough, I chose Bombay. Somehow I thought that was the right place for me. Not because I'm a Maharashtrian, because I grew up in Delhi. I went to school in Delhi. I was very familiar with the city. I could just as well have joined at Delhi. That was not the issue. I just felt from the way the correspondence went with Bombay that would be the place for me. So I chose Bombay. So here I am, never having stayed in Bombay before in my life, just visited Bombay as a young person, off and on, and a Maharashtrian, landing up in Bombay, going and staying in the staff hostel where they reserved a room for me because they knew when I was joining, and joining. October 12th, 1965. Okay? And it all began on that day. It's been a wonderful journey, right through. But it's been a journey in which you've been learning right from day one. And that learning process was particularly heavy in the early months. That's again what I want to emphasize. If you want to be a good teacher and you haven't done teaching before, you need to look around you when you join to know how to get into the process. You can't just say, I mean, my subject was heat transfer and thermal measurements and so on. So I could have taught a subject like that. Not that I didn't know those subjects, but how to teach them at an undergraduate level, systematically, or something that would have been new to me. I would have to plan it out. I could have taken a textbook from the library. I was familiar with the textbooks and started teaching. But fortunately, IIT Bombay also turned out to be a nice place for me, because immediately, as soon as I joined, I didn't have to teach. They gave me some time. I joined in the middle of the semester. So for a month or two, there was no teaching. You could get familiar with your surroundings. And then they assigned me in the first semester a course of teaching postgraduate students in measurements, thermal measurements, temperature measurement, flow measurement, pressure measurement, all measurements which I was very familiar with, having done a lot of experimental work in thermal, on the thermal side for my PhD. I'd use all kinds of devices while doing. So, once you have a textbook on it, you use many devices. Right, lecturing on that subject was nothing for me. And this was a postgraduate class of about 20 students. Teaching them was simple and straightforward, relatively straightforward. So the semester went off very easily, and fortunately the institute did not overload me immediately. And however, I knew that in the semester to follow, I was to teach the undergraduate course in heat transfer. Okay, now here's where the adventure began. Okay, so I'll describe it to you, the fun of it. Now it's fun, of course. At that time, I was a little nervous, if I may say so. The IIT Bombay had Russian experts till that time. And the year prior to mine, a Russian expert had taught heat transfer to the fourth year class. He was still there when I went. He was to leave shortly afterwards when I joined. They came for 2-year periods and so on. He's a good person. And but he was not a thermal engineer. He was really a power plant engineer. Heat transfer was side business for him. So I asked him what book he followed. He had followed a Russian book. So he gave me that book. And I looked at it and I was aghast. It was just a book of formulas. And he said, yes, I teach them this formula. Formula for heat conduction, one-dimensional heat conduction, two-dimensional heat conduction, cylindrical coordinates heat conduction, the formula for everything. Heat exchangers, okay, counter flow, parallel flow, everything, there's a formula. That to him was teaching heat transfer. And he said, I taught them all this, they knew how to use this formula, and that is it. So I didn't say anything to him, because to me that was not teaching heat transfer. Heat transfer is both a science and an art, as far as I was concerned. I'd done a PhD in heat transfer, not for nothing. To me, it was not just an art with formula in it. So I didn't say anything to him. I said, okay, and kept quiet. And of course, I went to the library. I had my own books in heat transfer, which I had brought back with me. The library also had enough books. So I sat down with them and started preparing my lectures in heat transfer. Teach conduction, you have to start with Fourier's law of heat conduction. Take up one-dimensional conduction, cylindrical coordinates, Cartesian coordinates, whatever it is, constant property of K, if it's varying with temperature. You take up examples one by one, make problems complicated as you go along. Go to 2 dimensions, in which case you get a differential equation, and so on. You get a partial differential equation, and so on. So once you do that, and these are IIT students, they had all done courses in calculus already, differential calculus. Once they saw that, they could see the connection with the differential calculus they'd done earlier. So when I got the 2-dimensional differential equation, I didn't solve it further. I said, this is a 2-dimensional differential equation. I'm going to give you very simple boundary conditions. Solve it. This is the answer. Come back with the answer. I'll give you the solution right now, get it yourself. They were happy to do it on their own. So you see, immediately now you're linking up with the class with what they have done earlier, and they see the advantage of the mathematics they have learned. Otherwise, they say, what's all the mathematics for? That's the purpose of teaching calculus. So like this, as we went along, whether it was radiation later and or fluid mechanics, that is the convection later, it requires some calculus. And if you use a little bit of that calculus, not too much, obviously, in a first course on heat transfer, you can't go too much into partial differential equations, then the students appreciate it. At the same time, and I stress this, remember you are teaching an engineering course. You are not teaching calculus. You are not saying solve that differential equation with these boundary conditions and give me the solution. You have to analyze that solution. You have to see what that solution is saying. That is where the engineering part of it comes. And then students start appreciating the engineering. You got it? So there is an engineering part to teaching, the art of the subject. There's a mathematics part to the teaching, the science of the subject. When you put that across, students start appreciating the subject. Then they say, there's something in all this. And that's what you need to convey to students as you go along. It calls for a lot of effort. And for the first semester, when I taught it the first time, I used to work 3 hours at home to prepare one lecture in the class next day. But it was worth it, because as I went along, I cleared up my doubts also as I went along. And mind you, some doubts that remained, good students in the class cleared up for me. Because there are always some good students who will catch you when you try to skid over something. Say, sir, but I think you meant that. And you know that you've sort of not quite understood it. They're clearing up a doubt. There are always some students. Or if they're polite enough, they don't say it in front of everybody. After the class, they'll meet you and say, I think you meant that and that. So, students are very helpful also to you. You have to appreciate all that. Build up an atmosphere of education. Students appreciate it. You appreciate it. You learn. They learn. It's mutual satisfaction. At the end of the semester, you're happy. But it doesn't end there. The exams come. Exams, are a duel. The students were used to old-fashioned examination, describe this, derive this, the old-fashioned examination we used to have in the 50s. Write short essays on, heat transfer, what do you write essays on? They're all problems you give. So I told them in advance, you will get nothing like describe and discuss. You'll get only problems to do. You're going to be engineers with slide rules. Those days we had no calculator, slide rules. Remember that, you'll have to do calculations. I said, okay, no problem, sir. Okay, I said. And I said to them, to make your job easy, I won't expect you to remember any of the formulae we have derived in the class. For instance, you have some problems in what you call radiation to do. Don't remember the Stefan Boltzmann constant. Write it down on a piece of paper. You can bring one piece of paper, I said, on which you can write anything you want. Okay, all the formulae you want that I've derived in the class, all the differential equations that I've written in the class, whatever you want. But don't lend that piece of paper to your neighbor while during the examination. That's the only thing. So they all came with the open book, just that one piece of paper allowed. And they're written very small handwriting. Both sides of the paper crammed with the small handwriting, all kinds of things. Said, write what you like. All is open. I said, if it's useful, whatever you think is useful, write it. But remember, you will not get any descriptive stuff to write on. This is not an essay. This is not an English subject that you have to write an essay on or something, or describe this. So they came to the open book exam. And I said, you won't get something that I've derived in the class also. So they came. And then sure enough, as soon as the exam started, they started asking questions. I was, there typically the instructor is also the invigilator. So you're walking around. Sir, you haven't given this data in this problem. You haven't given this data. I said, I know. Do what you like. I'm not going to tell you anything more. The clever ones immediately knew that they didn't need that data. The ones who were not so clever wrote there that this data is not given, so the problem cannot be done. The still cleverer one said, assuming the value to be something, let's do the problem. You know, all kinds of things like that. But what the clever ones realized is the value of that particular heat transfer coefficient was so high that it didn't matter what you took. It was not affecting the solution of the problem. It was not the dominant thermal resistance in that tube. There were other heat transfer coefficients which were really, whose values were known in the problem. So it was really a two-line problem. The good students did it in 2 lines. The other students scratched their heads and said, left H as an unknown and got the answer. And those who were this thing assumed some value. All those who got the right answer by saying H value doesn't matter, it's high, and got the answer in 2 lines, got full marks. The rest complained, sir, I wrote that H, you haven't given H. He said, you wrote correctly, but you didn't give me the answer. You didn't recognize that you didn't need the value of H. Okay, so be careful in future. As an engineer, you must be able to see what counts and what doesn't count. That's what engineering is all about. Not about saying I need every value for everything that's in front of me or every unknown that's in front of me. They appreciated that. From that point onwards, they were more careful in their tests. So they all remember me even 50 years later. Sir, you said that question. That's what they remember me for. Things like that. So teaching was an experience for me. It wasn't just for them. For me also, I was teaching the course for the first time. And obviously, if you teach that course in that manner, setting new problems every semester, it all ends up as a book, which I wrote after 4 years. The 1971, my book, heat transfer book for undergraduates came out. That was only the first edition. It was pretty poorly written, to be quite honest. I improved on it subsequently, 2nd edition, 3rd edition, 4th edition or something. And then, of course, I became too old to write more editions later on. But it did help me. Not only did I learn the subject better, I think my students also learned it better as we went along. Now, why did I go through all this? To tell you, the work as a teacher is a very golden road. It's for you to taste that golden road. You can say, I have to teach a course, I prepare it, go and lecture. Some students go to sleep, some learn, some yell, okay, and I come back. Next day, I again lecture. Another is to say, I set them exciting problems. Not all of them get excited, mind you. You can't get 60, 70 people excited, but at least half of them get excited with what you're doing. That's good enough in a class of 70. These are all, not all 70 are going to do heat transfer later on in their career. But the fact that you've got 30 or 40 people interested and attending to what you're doing is the greatest gift students can give you. That's what teaching is all about. To have students come to ask questions and to listen to you quietly or even ask difficult questions, either in the class or even after class, or meet you separately to ask questions. That's what teaching is all about. So that's one aspect of teaching. And that is a learning process. It takes years, few years. And then, of course, if you're getting tired of teaching heat transfer, switch to another subject. I switched to thermodynamics, which I enjoyed teaching as much, engineering thermodynamics. A very beautiful subject to teach. I switched started a new course on solar energy and thermal processes, solar energy, and so on. I taught a number of courses like that. But the basic courses like heat transfer and thermodynamics were my pet subjects. You really learn something from them. You learn from teaching them. The students also really love the subjects. You present them well and carefully. There's no question about it in my mind. So that was one aspect in that first 2 semesters, which I think I thought I'd bring to your attention, because it means a lot of effort, but it brings also with it a lot of satisfaction. But there are other aspects also to that first year or two, which makes you sort of determined to do well. And that is your colleagues in the department. IIT Bombay had very fine colleagues, older than me. I joined as 27, 28. colleagues were young, but they were in their 30s already. They'd been there 3 years, 4 years, 5 years, like that. And some were older, who were in their 50s, a few, who had come from other colleges and joined the IIT. And they were the ones who were very helpful to me, some of them, because of their experience. If you make friends with them, they don't know your subject, mind you. Just to recall their names, Professor Parulekar was teacher of refrigeration for us. Very friendly person. Right from the first day I joined, he made friends with me. He said, look, I don't know heat transfer. I know heat transfer, some formulae. I teach those formulae in the class for teaching refrigeration. That's my knowledge of heat transfer. So he, in fact, attended my course later, not that first year, but later when I was teaching postgraduate students, just to get a glimpse of how I taught. But I requested him. I said, sir, he was about 20 years older than me. I said, sir, I want to attend your class sitting at the back. He taught postgraduate course in refrigeration, air conditioning. I want to attend your classes. He said, why? I said, on the board, we had boards those days. No, what you call, slides and all that to present that time. They came a little later. If you wanted, you could put slides or transparencies later. That came later. So I said, I want to see your technique on the board, how you manage the board. I said, sure, come and sit in the class. I attended a few of his lectures, for 10 lectures. And he was also a very entertaining lecturer. He used to crack jokes with the class and, present refrigeration. But he was, I call it a very descriptive lecturer. Didn't believe in much calculus and things like that. He told me, I look on integrals as snakes, he said. That was his description of calculus. I don't have snakes in my teaching at all, things like that. But he taught with a feeling for the subject, that kind of thing. Do a lot of diagrams on the board to show the TS diagram on the board and so on, temperature, entropy, and so on, the board, so on. All kinds of refrigeration cycles, things like that. And he taught well. And so I used to attend his classes, quite a few classes at the beginning, just to get a feel, not in the beginning, in the second semester, to get a feel for how he taught, how he kept the class together, how we would occasionally crack a joke or two, how we used the board. That was important. We had 3 boards in front of us. He always used to start with the left-hand board. Never used to stand in front of the class. That is, the board was never blocked. It was always on the side. Okay? So that if you wanted, you could look at the board. He was never in the middle. And I noticed that. He would write the first 1/3, then to the next 1/3. Not erase the first 1/3. Go to the next 1/3, then the last 1/3. Then go and erase the first 1/3 when the board was fully full. So you could see the whole board in that thing. 1, 2, 3, then erase the first one if you wanted to write more. That's a systematic way of using the board. Many lecturers, I assure you, do not know how to use a blackboard or an equivalent if they are using a transparency, how to write on a transparent. They scribble all over the place. That is not the way to handle a class. You must write systematically because to some extent, somebody is taking some notes and that helps. If you write systematically, they also note down systematically because they are going to refer to those notes later. That's a helpful thing. So keep in mind that you learn these things from older people by attending the classes. So I benefited a little. Not that I attended his course fully. I attended about 10 lectures and thanked him for it. And he was very happy. And he in turn attended my class in the following year, saying, I want to see how you conduct the class with so much mathematics and calculus, and appreciated the way I was handling it also. So learn from your seniors if you go. If you think they will not mind, and also if you think that you will benefit from it, not that you will benefit from any senior person. So there are senior people who want to help, you should take their help. And I think that was, to me, that was a very good experience at IIT Bombay at the beginning. Now, I did mention all this because these are the things that count at the beginning. The way everything was said by us. The papers were said by us. semester end exams were set by us. We were the paper setters, we were the examiners. So you have to know how to do this thing. Open book exam I could set because we were allowed to do that IIT Bombay. And that helps to give you that freedom to do things in your own way and to win over also the students to what the way you're doing things. They appreciate it if you're open with them and so on. So these were some of the things that I did. And that opening, once you've started it, spreads. I mean, to all courses, then as you gradually, slowly learn that method of presenting and keep it up through the years. But as I said, teaching is not something to be taken lightly. A lot of people think teaching, what is there? You know, I meet many people or met many people in the past who would be doing something else before a lecture. To me, if I had a lecture at 10:30, 15 minutes before the lecture, I would close the door of my office, whatever I was, whether I was a director or a professor, and not see anybody. Even if I had given that lecture 10 times earlier, or it was a new lecture, I needed those 15 minutes alone to go over in my mind what I was going to cover, how I was going to cover it, and how I was going to begin, and at what stage I proposed to end at the end of that lecture. I used to plan that in every lecture that I gave at the institute, so long as I was giving lectures. That is part of the job of a lecturer, to plan out every lecture, what you're going to do. Not say, I'll go there, if I don't cover it, it doesn't matter. Sometimes you don't quite achieve what you want to do. You make it up in a subsequent lecture, but you must have a plan. And to have that plan, you need 10 or 15 minutes alone before you walk into the classroom. That's one important good habit you should all have if you're entering the teaching profession. You should be outside the classroom. You have to teach 5 minutes before the lecture is due. Don't come rushing into the class saying, oh, I was late, and then go. Okay? If you have a board which you have used while leaving, you should wipe that board while leaving. Don't leave it that your newcomer who walks in has to first wipe the board with the previous person. These are good habits to have in teaching. They are habits which go with you and automatically go with you and leave behind a good impression with students as well. Okay? And it's part of the job. Attendance, of course, we have to take sometimes. You don't have to take sometimes. One has one's own technique. Today, of course, it's all automatic. You have to press some buttons somewhere and to sign in and things like that. Of course, my method was simple. We had a roll call to make. I used to find out soon enough who were the people who didn't come too often, read out those 10 names and stop there, assume all others were present. Yes. And those 10 started coming if they knew that that number was being called, name was being called. Finished. It's as simple as that to get good attendance. And believe me, if they came to class, I used to always tell them, come to my class, you will have no difficulty in passing my course. If you don't come to class, how can I assure you even of that much? You can't assure yourself, I can't assure you also. So please come. That's all. As simple as that. And some of them took it seriously and then had nothing to worry about. It's as simple as that also. So teaching is a very gratifying profession. You meet students years later who remember you for that. Remember you. You go to the airport and you're sitting, somebody comes and says, sir, you remember me? And you say, no, I don't, I can't. I'd say, so-and-so, you taught me in that year. And you taught us that subject. It's so nice to have somebody stopping by somewhere, just saying hello to you. Somebody dropping in an evening suddenly, saying, I was passing this way, I came to know you stay here, just to say hello. These are, shall I say, good moments in one's life. So let me stop here at this stage. I think it's now, it's 10 minutes to 5. So now I promised you more time, but I'm giving you less time too. I get carried away. Sorry. But I'll stop right here now and say thank you for listening to me and questions. Somebody take over now.
Yeah, thank you very much, sir. Thank you for your enlightening
I've
lecture.
taken more time than I promised. Sorry.
No, but we also forgot the time, like how we are going ahead. And you rightly said, like it's training does not, the teaching does not require only a training, but it requires heart and it also requires love for the teaching. So thank you very much for the lecture. And now we have it's time for a few questions, and
Sure.
there are already some hands up. But
Sure.
I have doubt, like should I go from your old student? Jayant Sabnis is here. Jayant, do you have any questions? Okay, right. We'll start from here. Yeah, please go ahead.
Hello, sir.
Yeah.
Thank you so much, sir. And it's a privilege to hear you, listen you here. So my question is that as a PMRF, we also have to teach in nearby colleges, and we have to go on, regular means weekly. So in the classroom, we have different kind of student. Let's suppose we have 20, the strength of the student of the class is 20, out of which only 5 and 6 are, they are listening to you, and other totally disturbing the class. So in that case, how will you keep motivating yourself to teach? And then whom will you focus? Or you will focus on those 5 students or whole class? And so this is the big challenge, I think, while we teach in the class.
Well,
And similarly,
I'll tell you, I've been spoilt in IIT. Okay. Spoilt in the sense, attendance nowadays, compared to when I taught earlier, attendance nowadays isn't as good as it used to be earlier. But students don't make noise in the class. Those who don't want to attend, don't attend. Okay. But they don't make noise unnecessarily in the class. That doesn't happen in IIT. That I can tell you still. I mean, a good teacher can tell a student, look, if you don't want to listen to me, you can go out. I'll give you, say you're present and you can go. You can give him that option also. You can be polite with him, saying, you don't have to listen to me. I'll say you're present and you can go. But please don't disturb those who have come to listen to me. That much you owe to all of us, don't you? So be reasonable with them. They will be reasonable. If they won't be reasonable in spite of it, then you have to think of disciplinary action. That's the way I look upon it.
Yes, sir.
All students are reasonable, in my view, if you are reasonable with them.
Right.
Okay. And if you are reasonable, saying, you don't want to listen to me, I'll give you attendance, you can go. But don't disturb others who have come to listen. And don't disturb me, I've come to teach. Very simple.
Okay, thank you, sir.
That's the way I would approach it. Be honest with them. They should be honest with you.
Hello, sir. It was
Yeah.
good to hear from you. I just have one question regarding online teaching, because after COVID, everything has shifted to online. So
Yeah.
it's really difficult for us to keep the students engaging in the online thing. So how to improve on that thing?
You're asking a person who hasn't done online teaching. So I really don't have an answer to that. I've seen some online teaching being done. You know, when I go to my grandson's house in Bangalore, sometimes while he's doing online teaching, he has to do at home. I watch him as he's doing, in school. Some days they don't go and the online goes on. Just hear it. And I find it interesting. So, because they have a good school and the classes are small and the school handles it very well in the sense that the teacher knows all the students of that class. You understand? So even if they're handling it at home, it gets done well. That's what I noticed. But I'm not sure how well it is handled otherwise, because I've talked to other people who say online. And initially, when it was online, when online teaching started with the COVID, people used to say, oh, it's online, it's online. After a while, the same people say it's online, but it means nothing. Nothing is achieved. Many people told me that. So I have no solution, to be quite honest. Having not myself not having been associated, I really can't offer you a solution what to do.
Okay, sir.
Hello, sir.
Yeah.
Sir, you told that teaching a subject is not just conveying the mathematical formula, but you have to convey the physical meaning behind it.
That's
Sir,
right.
how do you deal how do you deal teaching thermodynamics, sir? For example, this law of entropy and all, they're highly philosophical. And uh, I am unable to teach. Like while I'm teaching, I break down into bits and pieces and it becomes story. And students say that, sir, first time you are using the same notation, but we are able to get the story. But I am not feeling satisfied. I want to teach thermodynamics in a systematic way.
You are asking a very difficult question. Teaching entropy is the most difficult thing because there's a certain element of philosophy in teaching entropy. You see, it is something which is imagination also partly. You understand what I mean? It's all the time increasing. So it's entropy is increasing, and therefore that kind of thing. So I agree with you. It's difficult. So you have to also recognize that while saying, you say it is a concept. It works. It works for describing even engineering situations. But to say that it is the last word for everything is also, we don't know if it is right. It works. So don't say that this is it. Okay. You say it's a concept introduced to the second law. It helps us in understanding what can be done or cannot be done. And it gives limitations to what we can do. But to say that it is the last word and forever it will exist, we don't know. We leave it at that. That's the way I put it. You understand? It is vague in a sense.
Sir, I read it myself 8 to 9 times, but still
No,
I am
no,
not convinced.
I agree. Sitting next to me just now, listening to me is Professor Gaitonde, who knows more about entropy than I do. And he may have a different view on it because he teaches thermodynamics much better than I teach. Okay. And it is a difficult, that part of thermodynamics is the difficult part. The easy part of thermodynamics is to teach cycles, you see, various Rankine cycle, starting with Carnot cycle, etc., solving problems, etc., stream cycles, etc. The easy things to do. It's relatively straightforward, I would say. When it comes to this thing, entropy, it is tough, but it helps to explain certain ways things are happening. And a certain mystic is there about it, which we have to stay with to explain things. That's all I can say. Beyond that, I myself cannot say that I understand everything about entropy. I myself.
Thank you, sir. We take last question, sir.
Hello, sir.
Yeah.
Thank you very much for your enlightening lecture. I have one question. Generally, a class consists of few smart students and few who would learn things slowly. So how do we maintain the pace of the class? Because it shouldn't be boring for the group and still a very fast for the group. So how do you keep them engaged both?
You look for the class average. You are really trying to teach the class average too. The bright student will probably be guessing what you're going to do next as the next step. But that can't be helped. Okay. But you can't go that fast as to say we'll skip this step in a derivation or things like that. You have to go a little slowly. So you go for the average student while teaching. And at IIT, actually, even the average student is pretty bright. Huh? Let me tell you. At least I have felt that way. But it is true, in spite of that there are quite a few students who do get left behind. And we urge them to, in the tutorial, to meet us. When the tutorial is held, particularly we identify them when we have tutorials, identify them, try to spend time with them. If they come to tutorials, spend time with them so that, they catch up a little. That's what we try to do in tutorials. But my thinking has always been teach so that teaching goes to the average. That pace should be for the average student of the class.
Yeah, thank you, sir. I think there is one last question by Professor Anki.
Yes.
Yeah, please go ahead, ma'am.
So thank you, sir, for your nice talk. So I
Yeah.
have one question, like when we select our faculties, so
Yeah.
generally we focus on that research, whether he's
Yeah.
very good or not. But a good researcher may not be a good teacher.
Quite
so,
right.
But in IIT, it requires that teaching has to be taken care seriously. So what are the way we can enhance the love for the teaching in
Well,
faculties?
one, of course, if you are identifying some IITs, for instance, ask the candidate also to give a lecture on a subject of their choice. Okay? That is a teaching type of lecture.
We have also that.
You have that. So then you
Teaching,
can
yes.
tell whether he explains well. Then you're getting an idea how well he or she explains the topic in addition to the interview that is being held. I mean,
Explanation, sir, explanation is one thing.
you
Another
must be
thing,
having him also giving a talk about his research or her research, isn't it? No, I understand, but what I'm saying is that is one way in which some IITs get over the problem. They ask candidates also to give a lecture on teaching. I mean, lecture on a topic actually of their choice. They do that also, in addition to giving a lecture on their research. In addition to the interview, of course, which follows on a next day, for instance.
okay. Thank you, sir.
Thank you very much, sir.
This is done by some places. So
Yes.
these are ways of finding out, you see, because I do say this, or while they are giving that lecture on their research, see the way they present that research. You see, you can tell a lot about a person. How they present that lecture, if there are slides in it, how they present those slides. You can tell a lot about a person, how systematic that person is during that presentation also.
Thank
Okay?
you so much, sir.
Okay.
So now I request Professor Joshi to felicitate this thing.
Am I visible, sir?
No, I am visible to myself only right now.
Yeah.
Okay. No.
Yeah.
Uday is changing
Okay.
over to you.
My apology, I had to miss because there was some other lecture going on with
Yeah. Now
young
I can see.
faculty.
Now I
Yeah.
can see you. I can see you.
Yeah.
But
So.
by the way, I should tell the audience there are two Suhases now in action. He is also Suhas Joshi. I am Suhas Sukhatme. Okay, go ahead.
Yeah, so thank you for joining. I could come only for the last discussion probably. There was Professor Kakkar was addressing young faculty, so I was in the other room and I could not join here. But thank you very much for enlightening. I can see the bright and glowing faces of the audience, and I can make out that they are really enthused by your talk and the discussions which has happened after that. So thank you again. We look forward to your physical presence sometime on the campus so that you can talk to our faculty and students again.
I'll try
and
to
we
come.
have a memento. We will only display the memento online for you.
Okay.
So this is the shawl made of Maheshwari silk.
Okay.
Which we will either I will bring it or we'll give you sometime by post. We'll send you. And this is a small memento which says best compliments from IIT Indore.
Thank you. Thank you. Thanks a lot. Thanks. Thanks to us. People may not know that you are also from IIT Bombay.
Yeah, they are aware probably. Yeah. But there's a group of bright PhD students. They are about to finish their PhD, and that is where we wanted you to address them that what it takes to be a good teacher. Okay.
So
Thank you, sir. Thank you
I
again.
tried to emphasize that in my lecture.
Yeah, sure, sir. Yeah. Thank you, sir. Thank you very much. Yeah.
Thanks a lot for calling.
Thank you, sir. Thank you, sir. Moving on, we have the next talk by Lieutenant General Professor Dr. Madhuri Kanitkar, who will be presenting her talk on research across borders, provenance and productivity in an online mode. I request Professor Ananya Ghoshal to introduce the speaker.
Good afternoon, everyone. It is my absolute honor and privilege to introduce Lieutenant General Professor Dr. Madhuri Kanitkar, one of the most inspirational women leaders in today's India. She is a retired general officer in the Indian Army, the first pediatrician to hold the highest doctor's rank in the Indian Army, and only the third woman in the Indian Armed Forces with a 3-star rank. She served as the Deputy Chief of Integrated Defense Staff Medical under the Chief of Defense Staff and serves as the Prime Minister's Science, Technology and Innovation Advisory Council. She has been conferred with the Param Vishish Seva, Ati Vishish Seva and Vishish Seva medals, which are awarded for distinguished service or of exceptional order in the Indian Army. She currently serves as the Honorable Vice Chancellor of the Maharashtra University of Health Sciences. It is an honor to have her with us today. Please give her a huge round of applause. Over to you, ma'am.
Thank you so much, Ananya. Am I audible?
Yes, ma'am, you're audible.
Thank you so much. Can I start sharing my slides as well?
Yes, ma'am, of course.
Is it seen? I'm not too sure whether it's seen.
Ma'am, it's visible. You just open the slides. Yes.
Yeah. So is it visible now?
Yes, ma'am, it's visible.
Yeah, perfect, perfect.
Thank
So
you.
now I'm all set to go. I'll just get my laser pointer. Yes, thank you so much. At the outset, thank you so much, Dr. Suhas Joshi and Dr. Devendra Deshmukh for inviting me to give this talk. The fact that you've called a doctor and a military person for this is obviously we are going across borders. So I think that's the way to begin. And all the faculty members attending today, as well as the scholars of the PMRF. It's a pleasure to be addressing you all today. And I thought my first slide, I must start off with a bang by showing you a little installation that we've put up in the university research department when I took over. And I realized that the only way forward is integration. So this is the little installation, and it is called Drishti because that's our Department of Research in Interdisciplinary Systems of Health and Translational Implementation Methods. So, and if you see, it starts with the basic roots of our good ancient Indian systems of ancient wisdom, going on to Ayurveda, and all the other knowledge that we have. And I've gone through your program. You've had a session on Indian systems of knowledge, which goes on to allopathy, but still the Rudrakshas are there. And we've integrated all this for good health for the earth. And that is our vision or drishti. So this is the first thing that I thought my tirist with integrated and crossing borders is. At the outset, I want to give a clear this thing that there is a conflict of interest, and I must declare this, that I have been a doctor, a soldier, and a teacher, and therefore, in my presentation, I would probably be a little overbearing on nation first and always, because the soldier came through very, but so also as a doctor. But today I'm expected to talk to you as a teacher, and therefore I do not think for PhD scholars you can teach. So I don't wish to inform you, but I hope to ignite you and inspire you to think beyond what this your own little sphere. And while I was preparing for this talk, actually yesterday morning I was going on this walk in the university, and this was what I saw in front of me. Look at that, the gray clouds which were all there. And we keep lamenting about the grayness and the gray clouds which are all around. But I think you scholars are this silver lining. And look at this ray which goes through. When a ray goes through, it's the ray of hope, which is also illuminating this. And look at this, which is totally submerged in that no more the gray. And there's another little cloud here, which is totally silver. So I think that is what, when you go through beyond borders and break open, the sky is the limit. And I did the same in my own journey, which was of 40 years of a very structured, organized system. And at the end of it, after 40 years in military uniform and serving as a doctor, I thought it was time to retire and enjoy my pension. But at the same time, I did think that why not jump borders and take on new challenges to solve newer problems. And therefore, this is sitting in a chair in a totally different, learning new tricks, because it's from center to state, from English, Hindi to Marathi. It's been a huge learning curve for me. And therefore, what I want to is leave you with this thought, that as we go from our graduation to our masters, and we just go through this cycle of information and knowledge, collecting degrees, where is the time to really assimilate it and use it to gain wisdom? Do we have to wait till all this hair is gray? And can I leave you with the thought, do not learn only to earn. I mean, there has to be more. And being a pediatrician, I couldn't help but say that there are always milestones. And I would like to, you keep referring to some of my milestones, which probably be balanced for prominence and productivity. And the journey on this path that I held from when I graduated with my doctor's degree and then went on to specialize and super specialize as a pediatric nephrologist, the whole thrust was patient care, with possibly the way in India, this thing, research is a very small. We rarely get opportunities to really get out into translational or some other. It's generally just clinical research, and it's a very small component as a thesis or something. But from there, I have moved into this zone where I opened up those little circle barriers, and that education, research, and productivity have to drive each other. So this is the path that I'm going to share with you. What started off as very small baby steps in the clinical ward in pediatrics, and I felt that I must find solutions. So a simple procedure for treating a large outbreak of diarrhea, and I felt that I'm a small fish with not much to do in a small military hospital. But one of my teachers said, doesn't matter, be a big fish in a small pond. So I think we need to start steps like that. But more important was, as I moved along, and I thought this is something that I'd like to share with you when we're trying to bring in productivity, is, am I sensitive about a problem? Yes, I am doing PhD, I'm doing research, but can I work towards, how is my research leading to what is the bigger picture? Do I think to stop, or do I just keep getting into specialization, super specialization? At some point, can I have little lateral thinking and kickoffs which come out of my research? And more important, as I drive solutions, can they be AFAS? And AFAS stands for affordable, feasible, acceptable, sustainable. I think this is what the nation needs. And the other is, can I solve it alone? You're all scholars, and you would realize that lots of times you cannot do it alone, and you would need a lot of resources. So if you can just go into your mind of doing all this, you could probably find solutions. And sometimes solutions come out of the box. For example, when I was trying to find cheaper ways of dialyzing children, I found a solution from my kitchen of you letting moms at home, instead of using disposables, taught them how to utilize the same pressure cooker to sterilize things. And the same way, when we did not have in those days very advanced equipment, how can we use the normal this for bladder dysfunctions, which has been my area of research and contributions. It was trying to find a gap, what is little known, difficult to diagnose, with a huge cost of investigations. So therefore, we developed algorithms which were relevant for India, which are now in the textbooks. And this is where one learned that where there is a will, there is a way, that you can always find solutions through but that was giving me productivity, but I was not being able to start off with small and get any publications as a clinician. And therefore, that's the next lesson one learned, was that you have to develop teams. It's rare you can, yes, through your research, you'll be able to have your publications. But to get into the bigger picture, you have to have part of teams, and your research has to fit into the big picture of the cogwheel. And I think that is important. And therefore, as one learned to do that, we did larger projects using across, like this one was through 20 hospitals, taking all the newborns and developed nomograms for Indian babies. And this, as one grew along, we developed the multidisciplinary research unit at AFMC, which was important because we were clinicians but had a very poor going back to basic sciences. And therefore, this was important. And through that came an integrated approach. My first IRIS, where we tried to look at Yoga Nidra, Indian systems of medicine. And just last month, we've had a PLOS publication through this research. And this went on to further multidisciplinary, where we went on to microRNAs and the basics of this thing in a simple situation of nephrotic syndrome to find what really ails our children. And this was a large DBT project. But once the bug bites you, you tend to keep finding solutions. And like I said, since this may not be relevant to you, but it does, I hope, to inspire you. So from there, I was pushed into a Northern Command total sector of Jammu, Kashmir and Ladakh, heading the medical operations there. But the bug in me of wanting to find solutions remained. And therefore, while working there, one went on to do practical things of why the men were, Jawans were getting more of frostbite, looking at data. So we did analysis on that, and also looking at incidence of high altitude pulmonary edema and high altitude cerebral edema, and went back to the basics of designing studies for global methylation and gene specific promoter methylation in reinductees of high altitude, as well as a clinical research as to what was the difference between the bullet injuries and injuries that happened in our soldiers from the fatal versus non-fatal. And we found it was thoracic injuries, and teaching our MOs a simple introduction of a thoracic drain changed the outcome. But of course, when you keep growing into trying to do, I've given a gist of some of the clinical work just to kind of stimulate a discussion, because after my talk, I do hope to take a lot of questions from you. As one grew along, one decided that the serenity prayer is the most important, which said, God, grant me the serenity to accept the things I cannot change, the courage to change the things I can, and wisdom to know the difference. So this was always about having a best productivity and best outcomes. And during COVID times, it was sometimes it is how common sense works, and the research comes in later. When the world was into having the N95 masks, which India just did not have, we came up from the Principal Scientific Advisor's office for the first time suggesting we use cloth masks, and that went on to be accepted later by the world, because something was better than nothing. And where ICMR and WHO said this was not acceptable, we felt we could do it, and then research proved that even a cloth mask did help. And the same thing went on to innovations during COVID, where within 3 weeks we set up 1,000-bedded, I was given the responsibility as the deputy chief, and we set up these jumbo hospitals with DRDO and developed protocols so these could be replicated across the country. And then look where I jumped. A person of total pediatric nephrologist who had nothing to do with infectious diseases, who had absolutely given up maths long ago, but joined hands with Manindra Agarwal from IIT Kanpur and Vidyasagar from IIT Hyderabad. And we started modeling out and working into mathematical solutions, me giving the clinical perspectives and the way the virus behaves, and they getting the mathematical. So I was soon changing my language to rho and epsilon and R naught and all the things of the mathematical equations. So I think what is important is knowing how to catch the fish being more important than just getting fish to eat, because then you can jump boundaries, you can cross borders, and you can keep finding solutions and make teams. And with the future, while you get out into the world, we're moving towards a gig economy. It's no more looking at a standard, steady 9 to 5 job. but you're going to need to keep coming together in different permutations, combinations, and different teams to keep finding solutions to remain relevant and meaningful and give back in a productive way. In the same way, we found mental wellness and mental ailments to be a huge problem, and COVID really threw it up. And therefore, under the Principal Scientific Advisor's Office umbrella, got in 3 institutions, the Armed Forces Medical College, which had a huge military psychology, the NIMHANS, Bangalore, and CDAC and NIC. With getting all of them together, we developed an app for mental wellness, which is now being tested out across people. So the message that I wanted to actually share was collaboration and getting together of diverse people is so important to find solutions. We have probably, the world looked at India with new respect when we were expected to be totally crumbled and submerged by COVID. We came out successful. And the reason? The scientific community came forward as a team for this work. The Principal Scientific Advisor's Office, DBT, DST, ICMR, DRDO, MIT, CSIR. And in no time, we developed rapid diagnostics, digital and molecular surveillance, repurposing of drugs. We were self-sufficient in PPEs, ventilators, supply chain logistics, and vaccines. I think we are the only country which developed, we had 3 vaccines, and not only for our country, but we ensured that it was even shared with other countries. So I think this is where success comes, when we cross borders, we get out of our absolutely tight shell and try to find solutions together. So with this background, I think I'd like to further share with you that at MUHS, we've just launched the first state-led network of centers of excellence, where we would like to have young, brilliant doctors and PhD and other scholars to come together, because we have a bold vision to solve critical challenges. We've already done an MOU with IIT Mumbai, KCDH, BETIC, and we hope to work and create an ecosystem which helps find solutions, because health is moving away in a big way. I think the future is not going to have doctors and engineers, but I think we are going to have doctoneers, or we are going to have engineers. I think that is what, with digital health, the whole paradigm is changing. And therefore, I think we need to all come together for this. And the same way, we're taking this project of reaching out to community, using students, faculty, all getting together with an outreach to the community, the same thing, to break the paradigm of education, research, and health, which is for us a productive angle. So we are combining all 3 together, whether it's a project where we adopted 18 villages, or towards the digital health, where on our LMS, we are launching the first foundation course in digital health for healthcare professionals, so that we learn to understand some of the language you would speak, and we can work together. And we also launching a Degree Plus program, because we feel most of us are, as doctors, having a very, very structured knowledge of only our domain, and we need to be skilled in other aspects beyond just our degrees. So with that backdrop, I thought I'll leave you with some ideas that what you can do. Because I think finally, if you're working on something exciting that you really care about, you don't have to be pushed. The vision pulls you. And the fact that you young scholars are all part of this Prime Minister's fellows for PhDs, I'm sure you're doing absolute brilliant work and are already passionate about it and need guidance to go forward and hit out and make a difference. I'm sure that you all know that there is a need to publish or perish. The reason being, for all grant applications, you need to have your citations, you need to have your publications. It's a must for faculty promotions. Citation score and H index is the new identity for any scientist, any scholar. But in the same thing, can we look at it a little differently swiftly when we were looking at Viksit Bharat at 2047, because India is poised for a science revolution. Our Prime Minister has already launched that it is not just this, but it is the scientific community which is going to make a difference. The National Research Foundation has been announced, and it really encourages huge partnerships between academia and industry. And I'm really happy that in this symposium and conference, this is the aim, how to get people together. And in India, we need to find our own solutions which are relevant for India, which are specific. Even in the field of medicine, we're talking of precision medicine, which cannot come without big data analysis, us understanding. So doctors and engineers, I think, need to learn to understand each other's domains and speak each other's language and share a problem, because solutions cannot come out of one domain. And therefore, that's the only way we can combine prominence and productivity. Look at this mismatch in insight generation. I mean, if you look, the large number of impact factor which comes, publications and research is coming from this part. Whereas if you look at population, this is where all the populations do. So there's a huge mismatch. But the good part is that today we are third for number of publications. We are sixth in this thing for patents, and we are ninth for the quality of research. So India is moving fast, and it is only because of young, bright minds like you all. So we have to bridge this gap, and we can do it only if we bring out productivity from our research, which for a passionate scientist, you're very passionate about your subject. So at times we lose sight of an ultimate bigger picture and how it is going to fit into the substance. And then when we look at revisiting biomedical research, there is evidence to say that most research is flawed, because we are it's rubbish in, rubbish out. We are not probably analyzing it correct. Most scientific studies are incremental to prior evidence and definitely not disruptively innovative and non-reproducible. So I think this is important, that we try, if we are looking at a disruptive economy and a disruptive scientific leap, I think we'll have to think differently. And there are definitely funding biases. So we need to look at research in a different way. And this is something that, are we working together? Look at the top 10 institutes in India versus the top 10, in global institutes. If you look at global, the top 10 collaborative indices show universities. There's Harvard, there's Stanford, there's MIT, there's Yale, there's University of California. And look at our Indian, it is CSIR, IISc, TIFR, Indian Institute of Science, ICER, National Center for Biological Sciences, India Ministry of Science Technology. So why is it that our institutions cannot come into the top? And this can happen not by them being alone, but by them collaborating, and academia industry partnership and coming together. And we'll have to look at the academic diaspora would have to look at out of the box solutions, and more. It's a large number of IITs already have a good collaboration, but I think the masses come from other universities and other colleges as well, and other institutions too will have to see and take this up disruptively, especially with the NRF, where there's going to be only a fifth of the funding which comes from public, whereas all the rest of it is supposed to come from industry and other partnerships. This is in keeping with what the world today in India, 65-70% of the funding is coming from public or government funding, as against in developed countries where just about 30% probably comes, but there's philanthropy, there's academia, there's industry partnership, and that's where the funding is coming for. So we also need to move towards that. And in that, since I'm a member in the STIAC, I think there is a huge opportunity from the national missions and how we can align. And most of them are related to young scholars, whether it's the e-mobility, climate change, and all these topics. So how can our research actually come into it? And to encourage this cross-border and trans-border participation. City clusters have been formed, like the Pune Knowledge Cluster, the Hyderabad Cluster, the Bangalore Cluster, the Delhi Cluster. So such clusters have been constituted, and these are picking up. It's just been about 2-3 years, but they're doing a good job of participating with state governments to find solutions together for local problems which can be scaled up. So we would work in India, think global, but act global. So that is the mission, and this would really be a big way. And I'm sure these are opportunities for scholars like you all to participate in. Look at India's presidency for G20, and the scientific theme was discover, disrupt, and develop. Disruptive science for innovative, sustainable development. Now, if you look at these broad themes, there is no one department which could solve it unless we came together. Whether it's clean energy, its effect on a universal holistic health, and connecting science to society and culture. And some of the national missions that are being launched is hoping to eradicate. We are still struggling with basic problems of tuberculosis, sickle cell anemia, linkages of ICMR laboratories to colleges, private partners. I mean, these are some of the national missions which have been launched, and I'm sticking to the medical, but you would have an access to a large number of such missions which are being done on a collaborative mode. So with that, I thought we ask, how can you cross the borders? So I think a border is something, as a soldier, I put it as a very ultimate. I think we should change the word to boundaries. We want to hit sixers. We want to hit a 4 in cricket because we want to cross the boundary. So it's first we have to cross the mental border of moving out of our comfort zone. We have to learn that education is for society, and for a scientist, the journey is long and arduous. I think mentors are very important. Degrees of graduation, post-graduation, PhDs, postdocs, I think these are guidelines, but we have how to make it useful needs cross-border thinking. Research is just not for publication, but we have to see how it can be changed to wisdom, and you have to think of your own passion instead of using a herd mentality to get into the same well-trodden path. And of course, like I warned you in the beginning, nation comes first always, and each of us needs to contribute and give back for the excellent education that we have been able to get out of this very country. But when you do this and you have to cross these borders, you need more than a Google map. And this map, I call it a map because it's a good mentor, a correct attitude of never say die, and a passion beyond doubt. With this map, I'm sure you can all cross all the borders. Keep an open mind. Don't close it up with this, keep these gaps which open up, which I say it's the Pareto principle of 80-20, that if you're spending 80% of your time in your own research, your own subjects, your own spheres, at least 20% find the time, the friends, and reading, which is totally outside. I mean, I have nothing to do, but one is reading on so many of these newer books which are coming, which are futuristic, because it gets me thinking on a lot of things. And mind you, like I said, the journey is going to be rough, but kinsur koroi is the art. The more we have failures and challenges, the more we stick together with a beautiful golden blue, because you toughen yourself. I think that is so important. But the only borders that we can never cross are those of ethics in research. Because ethics, especially when you're doing with people, I think this is the only border which I would warn should never be crossed. Because it is not just an institutional ethical. There has to be honesty in data collection, which is paramount, and integrity at all costs is crucial. Use statistics correctly to draw inferences. Plagiarism is an absolute no. Start with reading and talking to people outside of your domain. Use funds judiciously. It's a crime to use public funds for research and not have a good publication which can be shared by all. And IPR and authorships must be understood, and I'm glad that this symposium has those subjects also addressed to. And while again I talk of prominence and productivity, as a clinician, I would say you have a left brain and a right brain. Technically, the left brain is associated with what all of us are doing, the science, knowledge, time, decision-making, attitude, logic, reasoning, structure. It's all there. It's very important, but it's of no use unless you combine it with your right brain, which has language, religion, family, art and culture, food for thought, music, personal space. So therefore, ladies and gentlemen, prominence is the science of research, but productivity is the art of application. And therefore, if you've not read the book, please do read it, that while you're pursuing your mission, passion, profession, vocation, and what you love to do, I think the final thing is finding your ikigai, is what the world needs from you. It may sound a little philosophical, but if you start your path on that, I can assure you productivity and prominence will come together. Just the way in the university, we have created a garden of 5 senses. This is so that we do not forget to live close to nature. And this is in the last 2 years, where there was once a jungle, we've put in rainwater harvesting, and so that we listen to nature, we smell the flowers, we have developed a vision, and that's the way forward. Thank you very much for a very patient hearing, and now I look forward to taking questions from you.
Thank you, Dr. Kanitkar. I think it was a wonderful lecture which truly spoke about border crossing. We have heard it in metaphors, but today for the first time we heard that in terms of disciplinary merits, in terms of our abilities, how do you cross borders? So thank you so very much for your lecture. So the floor is now open for questions. I'm sure students will have lots of questions.
I'm looking forward to that.
Yes.
Hi, thank you, ma'am, for your very captivating lecture. So I wanted to ask you about, like you mentioned about collaborations. So in that way, so I am a researcher working on infectious diseases domain, and I often see, particularly for tuberculosis, I see that there is a gap between what the clinicians know and the ongoing of the disease and what the patients face versus what we are actually doing in the lab for the disease. So how do you think we should tackle this gap which is actually there in our society, and how we can come together to actually look at it?
Excellent question. What's your name?
So I'm Shiksha Sharma. I work at IIT Bombay.
Yeah, Shiksha, that's a brilliant question, and I don't know what your specific research subject is, but when I worked at AFMC, the National Center for Cell Sciences, all these places have a lot of excellent, brilliant scientists, but if the scientists, I had asked them to come and join my tuberculosis, HIV clinics to try and understand what goes at the patient level. And in other words, on the same side, I sent clinicians to learn what is the scope of research. Today, when we pose our research questions, the researchers pose it on their own side. At the inception stage itself, if clinicians and scientists work together, I think it would be brilliant. And just to share with you, with that in mind, we've just set up a MUHS Center for Research in Infectious Diseases at Mumbai. And Dr. Jayanti Shastri, our microbiologist, is our chair professor. If any time you particularly would be, need some inputs on that, we'd be very happy to help you. Thank you so much.
Next question, please.
Hello, ma'am. Jai Hind.
Jai Hind.
Yeah, ma'am, my father has visited you sometimes at AFMC. I'm son of Indian Air Force soldier, D.K. Srivastav, Junior Warrant Officer. Ma'am, my question is, ma'am, for example, we all are PMRF scholars, and we are running behind some new novel ideas, etc. And there are Indian military services which are also looking forward for some new techniques which they can adopt in their services. Ma'am, what do you think, how we can actually employ PMRF scholars in Indian military services for internships or for jobs, etc., for research and development, etc.?
I think you have again a brilliant question. So far, DRDO was running the, sort of had isolated itself to run research for the armed forces. But now DRDO has collaborated, like, for example, IIT Chennai. They also have this thing under the vice chief where problems are thrown out and then given to institutions like IITs and other top institutions for finding solutions together. For example, when I remember when I was sitting this thing out there were problems like how do you, tanks working at Siachen, the mechanics of mobility for that, or as a clinician, I had an issue of when casualties were evacuated from certain very forward posts and there was no internet there. The en route 8-hour journey, we had no connectivity other than satellite, which didn't work. So we were looking at, can we bring in solutions for that? So, and I think these are way forward. The borders are opening up, and I'm sure they would have a structured thing. Since I'm not part of it, I can't directly tell you what it is, but the Defense Secretary, the JS, is looking into these aspects.
Hello, good evening, ma'am. Thank you
Good
for
evening.
your lecture. Ma'am, I'm a CSC scholar and I work on the intersection of healthcare and CSC, computer science. So whenever I'm going to apply certain applications of machine learning, I need some data from healthcare. So whenever I talk to a doctor or a medical student there, it's very hard for me to explain what's going on there. And it's even tough for me to understand what their actual problem is. So can you please provide some guidelines or tips on how to mitigate these issues?
Again, I'm loving your questions, because this is exactly that I'm trying to introduce through getting so far digital health was being done by, computer science, and without understanding the ground reality where health in our country is at the public hospitals, which are so understaffed, so heavily worked, whereas scientists would hope to have ready data given to them to work on. We have not bridged the gap of how to generate that data. And what I have challenged the scientists, find better ways to collect data instead of getting doctors to start feeding in all that data besides looking at patients. So now that with natural language processing and all these other voiceover and things, unless we create cheap programs which are running in our hospitals, the data will never come by. But I would love to tell you that this would be with a future that in mind. We are creating a data center to link up. That is what I showed you, where we'll link up 10 top government colleges, so that we have put in EMR and HMIS, and along with the KCDH and Koita Foundation, we have launched our first primer course for digital health for medical people, so that they understand the importance. Otherwise, it's like an added burden. I have a whole day and night of working with patients, and I'm expected to provide data to a scientist who's sitting in a office and wants that data to do research. So that doesn't happen. We'll have to learn to actually reach halfway, talk to each other, and find ways and means to collect that data in a better way.
Hello, ma'am.
Yeah.
My name is Abhishek. So I'm a researcher as well as I'm a father to a 2-year-old child. And often there are situations where I feel that I should give more time to my research, but sometimes I feel that I should give adequate time to my child as well, to my family. So many times there is this situation of duality. So please let me know, how do I come out this द्वंद्वता, जो एक situation होता है कि यहाँ पे ज़्यादा वहाँ पे ज़्यादा, या how to get that fine balance?
Yes, it's always there. You can imagine, I can imagine how you go through, and you can imagine how I didn't show one of the slides in some of my talks I show, where I had to really be the Devi with 20 hands, because besides being, having 2 children, I also spent 24 years posted away from my husband, running a home, running a thing till I was ready to pull out all the hair that I had. But what is more important is time management. I mean, time management is that quality time. For example, I mean, if you can say that it's non-negotiable, that you know that you're going to spend that 1 hour before, early when she wakes up, or say when just before she's going to bed, and you explain to her rest of the time and make that a real focus time for her children to start understanding. But don't ever put that away, because that is a very important part of your life. So don't prioritize only work and research and forget your family, because this balance is again important. You become a good researcher if you are sensitive to being a good husband and a good father as well. And your good research gets you your position, which your family respects you for that. So the good of one comes to the other, and let it flow. So definitely time management, picking up 1 or 2 things which are non-negotiable and keeping time aside for that is as important as your research.
Thank you, ma'am. Thank you so much.
Yes, please. Next question.
Yeah, that was a brilliant talk. I'm Professor Deepa Venkatesh. I'm coordinating the PMRF activity and from IIT Madras. We have close to about 3,000 PMRFs who are literally handpicked, and they are the brilliant minds of the country, some of them whom you are addressing today. One of the responsibilities, or the deliverables that we expect from the PMRFs is that they spend an hour of work outside their institutes in promoting teaching, in promoting STEM to outside the institutes, essentially bring others along. So do you think there's an opportunity for them, because there's a large workforce that is available, brilliant workforce, innovative workforce that's available right now, and we're trying to coordinate activities towards what would impact the country in general. So is there any opportunity that we can streamline?
Huge, Dr. Deepa. I think this is so important, because you have really the cream, and taking science to society has been a theme that is out for the nation. In fact, now there are orders and diktats also for all top institutions of higher education to reach out to communities, to schools, because it is when we interact, everyone needs a role model. Every kid needs to see the good and something fantastic. You don't have to tell them about rocket science. I mean, if I came to this talk and talked only of how have innovative ways of doing my research, no. But if I can stimulate you to think beyond and think a little, you go back with 1 or 2 thoughts. If there are going to be so many, whether it's a school outreach program, whether it's college outreach program, whether it's especially the colleges in and around area which have your BSc and master's students, if they also need a little guidance, and nothing like having a peer who mentors you. So if you can sort of reach out and have regular interactive sessions where they go out, they utilize it, I think that would be a brilliant thing for having an interaction. And here, while they are pursuing their careers, they would show a map to large number of students in society. So I think this is an excellent thing that you're coordinating, and I would urge all students to say that, can I take out a little of my time to give back to society? And the second thing is, I mean, a little hutke from this is that what we are trying to, from the bigger picture, agreed, most people want, after their PhDs, they would like to go for a postdoc, go abroad, and a large number do because of the facilities which are there abroad, and they can do a lot of work. But probably utilizing and helping, being a creator of those facilities, staying back, at least some of them, if they start doing that, we would start solving real world problems that are for our nation. So I think that is also important. It's a difficult path, because you choose a easy path, it's the standard, and then you get picked up, you're excellent. But I think if you can bring a talent to create own paths, to have this entrepreneurships, to incubate, to get out and this, because the world is looking at India now. The fastest growing economy is going to be India. We have the youngest population. So you may be able to go out and develop, but if you want to do entrepreneurship, the growing economy is going to be our country. 60% of our population is below 35 years, which no other country in the world can boast of. Even China has petered off now. So how can we get this human resource and this opportunity for getting productivity and prominence both? And that is why I love this topic that was given. I think that's a very important point you brought out.
Perhaps this could be our last question, or 2 or 3 more. Okay, let's continue.
Hello, ma'am. Rishabh
Yeah.
this side. I am currently working on rare genetic disorders, especially ocular disorders. So, I have a question. Like in India, the genetic disorders are really underrepresented. So, how can we reach out to people explaining them about the disorder so that therapy can easily reach out to them?
Excellent. I think again, and why it is important. Which institution are you working with?
IIT Kanpur.
Okay, so rare genetic disorders, the DBT is running a huge program, the UMMEED program, for the last 3-4 years, which with its sort of the headquarters of that is in CDFT Hyderabad. Having said that, this is one field which is going to require cheaper and easier solutions. In fact, even our own university has set up a small center to get in, because there is rare genetic disorders are rare, but we have huge population. So the number of people who have that is there, but at the same time, we need to pick up and develop our own panels for quick diagnosis and antenatal diagnosis. So this requires the entire gene map as well as solutions which we can develop. So for that, unless there is a network which I am trying to create with CDFD and mine and DBT, where we link up the have-nots. At the moment, rare genetic disorders is coming out of samples from the haves, because the majority are the have-nots. For example, not so rare, but your thalassemia, sickle cell, this thing is more among our tribal populations who can't afford to get these tests done. So how do you do research? So unless we spend it into a translational and develop a network to get every patient has an access to them, then can we find cheaper solutions. First comes our ability to diagnose those disorders and put them together with simple screenings, syndromic wise, and develop our own panels, which would be, because we don't have our own libraries in most situations. So we are trying to do that, and I think we need to all collaborate together. So there is something happening in Ayur Genomics in IIT Hyderabad. You're looking at rare genetic IIT Kanpur, there's CDFD. So a large number of people. So consortia would have to be developed for taking this forward.
Thank you, ma'am.
Any more questions? Okay, can we have another round of applause for her? Thank you, ma'am. Thank you so very much.
Thank you, ma'am. I now request Professor Joshi to remotely felicitate Professor Kanitkar.
Thank you, Dr. Kanitkar. It was great listening to you. It was very enlightening. I think what she said was very important. If you replace word border by boundary, then everything changes. If you cross the border, you land into the enemy's territory. But if you cross the boundary, you will get 4 runs or 6 runs. So you have a lot of advantage by crossing the boundary, which is very important. Nevertheless, your other talks and wide exposure to many things, I think it's tremendous and mind-boggling. Thank you very much for enlightening us. Thank you.
Thank you so much.
So, as I said, this is the shawl, which is of Maheshwari silk, and this is a small memento of IIT Indore with best compliments. Thank you
Yes.
very much. We will try to send it to you. Thank you.
Thank you so much, Dr. Joshi, and all of you for giving me this opportunity to interact with you all. And if there's anything that any of you all feel that we can help out through MUHS, please feel free to approach
Sure.
us.
We have a very vibrant biomedical and biosciences department, and
Yes.
we will definitely reach out to you. Thank you very much. Thank you.
Thank you, sir. So this brings us to the end of the plenary talks for the day. I request everyone to proceed to the common area for tea and then to Nalanda Auditorium for a cultural program featuring a mesmerizing musical night by Mr. Prasanna Rao. So he will be singing the hit songs of Mohammad Rafiji. Also, we have arranged for a forest walk tomorrow morning. So this is an excellent opportunity for everyone to explore the unexplored parts of IIT Indore. I request everyone to please assemble in front of Carbon Building at 7 a.m. from where the volunteers and the security team will guide you. And also an announcement for the participants that we will continue the poster session in the dinner time. And yes, there'll be an evaluation. So the best poster from each broad area will be rewarded. Thank you.
So we'll have a group photo. Just you can assemble in front of that Maitreyi Hall where you have a stairs. I think we can get the group photo in there. Yeah, thanks.
नितेश को चलने देना अभी, वो लाइव चलने देना लाइव. हाँ, अभी उधर से ज्वाइन करेंगे ना ऑडिट से. वो कैसे लीव उधर से ज्वाइन करेगा क्या? उधर से ज्वाइन है क्या, देख तो यार है. लीव हो गया कि ज्वाइन है?
नंबर है क्या? हेलो, हाँ भैया, हेलो, ऑडियो टीम, हेलो। आपका आउटपुट का गेन जो है ना, हमें जो लाइव पे जो चाहिए वो गेन बढ़ाइए आप। जो हमें लाइव पे जो गेन चाहिए ना, वो वाला गेन बढ़ाइए आप। हाँ, अभी बढ़ गया।
हाँ, थोड़ा सा वॉल्यूम दे। हेलो, 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 हाँ, हेलो, थोड़ा सा हाई से। हेलो, 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 हाँ बस। हाँ, हाँ, हेलो, 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 हेलो। Some
तो कैसे हैं आप सब? और जैसा कि मुझे पता चला है, काफ़ी अलग अलग जगह से आज आप सब यहाँ इकट्ठा हुए हैं। और सर को और आईआईटी इंदौर को बहुत बहुत धन्यवाद कि हम लोगों को याद किया आज आप सबको एंटरटेन करने के लिए। तो इससे पहले कि हम आज के संगीत सफर में आगे बढ़े, आज के जो हम सिंगर्स की जो बैकबोन होती है वो है म्यूजिशियंस। तो एक बार जोरदार तालियां इनके लिए। और कीबोर्ड पर हमारे साथ है दीपेश जी, जो टीम को लीड भी कर रहे हैं। विकास जैन जी गिटार पे, सागर जी ऑक्टोपैड, नीलेश जी ढोलक और तुंबा पर हैं, और तबले पर हैं अजय राव जी। और हमारी आवाज पहुंच रही है आप तक? पीछे तक आ रही है आवाज? तो एक बार ओके, तो हमारी ये आवाज आप तक पहुंचा रहे हैं धन्नू भाई। एक बार खड़े हो जाएं, शुरू करें। ठीक है, तो जैसा कि आज हम ने रफी साहब को क्यों रखा है, थोड़ा सा वो भी बता दूं। एक तो क्योंकि मैं मैं उनके गाने गाता हूँ, सीधी सी बात है। दूसरा ये है कि ये साल रफी साहब का 100th बर्थ ईयर है। तो एक बार जोरदार तालियां उनके लिए। अब हम थोड़ी सी बात मैं इस पे करना चाहूंगा कि हम म्यूजिक सुनने आए हैं यहाँ पे। अब हम जब से पैदा होते हैं तब से मरने तक हमारे जीवन में संगीत बहुत इम्पोर्टेंट रोल अदा करता है। लेकिन शायद वो एक ऐसा साथी है जो हमेशा हमारे साथ होता जरूर है, लेकिन हम कभी रिकग्नाइज नहीं कर पाते। करेक्ट है कि नहीं है ये चीज? थोड़ा आप लोग मेरे से इंटरेक्ट करेंगे तो मजा आएगा। ये सही है कि नहीं है? चलिए, अब मैं एक क्वेश्चन पूछता हूँ। क्या ऐसा हुआ है कभी कि आप एक लॉन्ग बाय रोड जा रहे हैं और आपको लगे कि यार नहीं, कुछ तो म्यूजिक चलाना चाहिए? ऐसा हुआ है? और उससे क्या फर्क पड़ा आपकी जर्नी पे? हंसते हंसते कट जाए रास्ते। लेकिन हमने कभी रिकॉग्नाइज नहीं किया कि म्यूजिक ने एक्चुअली साइकोलॉजिकली हमारे साथ क्या किया है। उसने समय शून्य कर दिया हमारे लिए, वो हमको समय पता ही नहीं चला कब गुजरा। राइट? तो म्यूजिक का कितना बड़ा योगदान है। मैं आगे इस पे और बात करूंगा, लेकिन ये लेक्चर नहीं है, चिंता मत करिए। गाने भी होंगे, बातें भी होंगी। तो पहला गाना सरप्राइज है आप सब। चांद मेरा दिल चांदनी हो तुम, चांद से है दूर चांदनी कहाँ, लौट के आना है यही तुमको, जा रहे हो तुम, जाओ मेरी जान। वैसे तो हर कदम मिलेंगे लोग सनम, मिलेगा सच्चा प्यार मुश्किल से, ओ दिल की दोस्ती खेल नहीं कोई, दिल से दिल है मिलता यार मुश्किल से, यही तो है सनम प्यार का ठिकाना, मैं हूँ चांद मेरा दिल, चांदनी हो तुम, चांद से है चांदनी कहाँ, लौट के आना है यही तुमको, जा रहे हो तुम, जाओ मेरी जान, जाओ मेरी जान, जाओ मेरी जान। थैंक यू। व्हाट्सएप अब किस चीज से काम, यस घुमा दिल में ये तू आई, कहीं चटकी गली कोई, मैं ये समझा तू शर्माई, कोई खुशबू कहीं बिखरी, लगा ये जुल्फ लहराई, लिखे जो खत तुझे वो तेरी याद में हजारों रंग के नजारे बन गए, लिखे जो खत तुझे। अता रंगी फिजा रंगी, ये इठलाना ये शर्माना, लड़ाई हाँ चले जाना, बना देगा इसको जवा जा ये दीवाना, ले जो तुझे तेरी याद में हजारों रंग के नजारे बन गए, सवेरा जब हुआ तो फूल बन गए, जो रात आई तो सितारे बन गए, लिखे जो खत तुझे। थैंक यू। और सिर्फ मेरी आवाज से बोर ना हो जाए इसके लिए एक बहुत खूबसूरत आवाज और हमारे साथ है, जोरदार तालियां। के और वो क्या सुना रहे हैं?
जी भर के दिल जिन्हें हमको तेरे रास्ते नसीब में ये बात हो ना हो शायद मेरे से जन्म बात हो ना हो चांदनी की फिर हंसी रात हो ना हो शायद मेरे से जन्म मुलाकात हो ना हो चांदनी पासा कोई बार बार नहीं आई बार बार बाहें गले मिटा हम रोने जार प्यार बरसा हो मेरे सजनम मुलाकात हो ना हो जागने के फिर हंसी रात हो ना हो शायद मेरे सजनम मुलाकात हो ना हो जागने
अब एक छोटा बताइए, थोड़ा जोर से बोलिए, सुन नहीं दे रहा। सब नाश्ता कर रहे हैं।
जो दिल को वरना जानम जो दिल को नजर नहीं चुराना सनम बदलती मेरी जिंदगानी नहीं बदलना जाना सनम बाहर बनके हमारी दुनिया में आए तेरा में कभी तुम्हारी दुनिया में गुजर न जाए कभी से तुम मेरे आज तुम मिट जाओ बदलती मेरी जिंदगानी नहीं बदलना जा
नाले को लहू जिगर का दूंगा हंसों की नाले सर तो जिगर का दूंगा जिस दिन कौन सा वो आखिरी दिन हुआ तेरा वादा वो इरादा तेरा वादा
जिस दिन तुम्हें देखा तेरी हुआ
हाथ ऐसे भला छूटेंगे कभी तेरी बाहों बेवफा क्या हुआ तेरा वादा वो कसम वो इरादा बोले दिल जिस तुम्हें का आखिरी वो कसम और कहने वाले मुझको परे भी है लिखा प्यार का नशा का क्या होगा Please screen. Thank you. Thank you. एक स्टोरी बता देता हूँ। ये कौन सी स्टोरी पता कि मुझे पता है। जैसे जैसे एक सिंगर एक आपस में जैसे हमारी है और ज्यादा हो गई जो हम लोग नहीं करते हैं बिल्कुल भी। तो तबला अगर हम तो सोचते हैं अपन तो नहीं सकते लेकिन मरने तो सबको। तो अगर हम में से कोई मर गया तो क्या करेंगे। तो दोनों मिलते हैं कि जो भी पहले मरेगा वो अगले के सपने में रोज आएगा। तो अगले वाले टिकट जाती है और सिंगर के सपने में एक महीने तो ये आते हैं और एक महीने तब वाला सिंगर के सपने में आता है तो वो चिल्लाता है बोले तुम्हें तो बड़े वादे किए थे कि रोज सपने में आएंगे ऐसा वैसा। तो तब वाला भाई क्या करूं नीचे से शो देते हैं। बोले कभी रफी साहब बुलाते हैं कभी भूप सिंह जोशी बुला लेते हैं 3 बजे कि चलो रिलैक्स करो। कभी बिस्मिल्लाह खां बुला रहे हैं कभी मुकेश को बुला लेते हैं। तो संजय बोलते हैं कि चलो एक महीने में कैसे अभी बोले तो तेरे को बताने का कि अगले हफ्ते तेरा शो होगा। तो ऐसा हो कुछ तो मिला लिया। Okay. आपका मूवमेंट Just Yeah. Thank you. बताइए जोर से बोलिए दीवाना हुआ बात सावन की घटा छाए ये देख जो प्यार अंगेरा बने दीवाना ऐसी तो मेरी तकदीर न थी तुम साथ कोई दिल आज खुशी से पागल है दिल आज खुशी से पागल है ऐ जाने मिले ऐ जाने दिल क्यों ना बने पागल क्या ये तेरे
फेल हो जाता ना वो कनेक्टेड होता उसके बाद
अभी फिल्म का नाम लेता हूँ कर्ज ठीक है
आधा काम मैं घर में फिल्म का नाम देता हूँ, गाना बता दीजिए ऐसा कर। ये वायलिन तो बजा है, यहाँ पर एबीसी कीबोर्ड बजा रहे हैं, यहाँ मेरा पास।
सर तो मतलब
दर्द दिल, दर्द जिगर, दिल में जगाया तूने। दर्द दिल, दर्द जिगर, दिल में जगाया। पहले तो मैं शायर था, पहले तो मैं शायर था, आशिक बनाया। दर्द दिल, दर्द जिगर, दिल में जगाया। दर्द दिल, दर्द जिगर, दिल में जगाया।
मेरा होस्ट पे ज्वाइन करवा गेस्ट पे ज्वाइन कर ले वीडियो कहाँ से बजा रहे हैं
दिल पे जगाया दिल पे जगाया और थोड़ी देर में बस पहले तो मैंने सारे आशिक बनाया दिल पे लगाया मुझे एक आशा सी का
Hello. Hello.
आएगा 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 जरूर। लेकिन सच में किसी की गुलाबी आंखें हों और सामने आए तो क्या करोगे? किसी की चांदी जैसा रंग और सोने जैसे बाल हो तो, सच में हो तो बाल तोड़ तोड़ के बेचने लगेंगे और कुछ नहीं होगा।
From my to तीसरी मंजिल आगे बिल्कुल साफ का म्यूजिक और काफी सारे गाने उसके हिट थे तो उसी में से एक गाना
ओ हसीना जुल्फों वाली जाने जहां ढूंढती है काफिर आंखें किसका निशान। ओ हसीना जुल्फों वाली जाने जहां ढूंढती है काफिर आंखें किसका निशान। महफिल महफिल है शमा फिरती हो कहाँ, महफिल महफिल है शमा फिरती हो कहाँ।
अनजाना ढूंढती हूँ वो दीवाना ढूंढती हूँ जला कर जो छिपाया है वो परवाना ढूंढती हूँ। गर्म है तेज है ये निगाहें मेरी,
काम आ जाएंगी सरदार मेरी।
तुमकी राह में तुम मिलोगे नहीं,
अरे इश्क हूँ मैं कहीं ठहरता ही नहीं।
मैं भी गलियों की परछाई कभी यहाँ कभी वहाँ, शाम से कुछ हो जाता है मेरा भी जग जवां।
ओ हसीना जुल्फों वाली जाने जहां ढूंढती है काफिर आंखें किसका निशान। महफिल महफिल है शमा फिरती हो कहाँ, महफिल महफिल है शमा फिरती हो कहाँ।
जाना ढूंढती हूँ वो दीवाना ढूंढती हूँ जला कर जो छिपाया है वो परवाना ढूंढती हूँ। छिप रहे हैं ये क्या ढंग है ये आपका,
आज तो कुछ नया रंग है आपका।
आज की रात में याद क्या हो गई,
अरे आपकी सादगी तो बला हो गई।
मैं बिन गलियों की परछाई कभी यहाँ कभी वहाँ, चाँद से कुछ हो जाता है मेरा भी जादू जवां।
ओ हसीना जुल्फों वाली जाने जहां ढूंढती है काफिर आंखें किसका निशान। महफिल महफिल है शमा फिरती हो कहाँ, महफिल महफिल है शमा फिरती हो कहाँ।
वो अनजाना ढूंढती हूँ वो दीवाना ढूंढती हूँ जला कर जो छिपाया है वो परवाना ढूंढती हूँ। थैंक यू।
La 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 la. गुलाबी आंखें जो तेरी देखी शराबी ये दिल हो गया संभालो मुझको ओ मेरे यारों संभलना मुश्किल हो गया दिल में मेरे ख्वाब तेरे तस्वीरें जैसे हो दीवार पे तुझ पे फिदा मैं क्यों हुआ आता है गुस्सा मुझे प्यार पे मैं लुट गया मान के दिल का कहा मैं कहीं का ना रहा क्या करूं मैं दिल रुबा भुला जी जादू तेरी आंखों का ये मेरा कातिल हो गया गुलाबी आंखें जो तेरी देखी शराबी ये दिल हो गया मैंने सदा चाहा यही दामन बचा लो हसीनों से मैं तेरी कसम ख्वाबों में भी बचता फिरा नाज़नीनों से मैं तौबा मगर मिल गई तुझसे नजर मिल गया दर्द जिगर सुन जरा ओ बेखबर जरा सा हंस के जो देखा तूने मैं तेरा बिस्मिल हो गया गुलाबी आंखें जो तेरी देखी शराबी ये दिल हो गया संभालो मुझको ओ मेरे यारों संभलना मुश्किल हो गया
थैंक यू आएगी 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 आने तो दीजिए फिर
तू है वही दिल ने जिसे अपना कहा तू है जहाँ मैं हूँ वहाँ अब तो ये जीना तेरे बिन है सना ओ मिल जाए सना तू नजरे जितना ओ मिल जाए सना तू नजरे जितना फिर हो ना जुदा आए वादा रखा तू है वही दिल ने जिसे अपना कहा तू है जहाँ मैं हूँ वहाँ तो ये जीना तेरे बिन है सदा मैं आवाज़ हूँ तू है गीत मेरा, जहाँ तेरा मन मीत मेरा मिल जाए ओ लगे जितना ओ मिल जाए तो लहरे जितना फिर हो ना जुदा आए वादा तू है वही दिल ने जिसे अपना कहा तू है जहाँ मैं हूँ वहाँ अब तो ये जीना तेरे बिन है जुदा किसी हाथ छूटे मेरे हाथ से दामन न छूटे पीछा तू मुझसे रूठे खुशियाँ न लूटे तो लहरे ओ मिलनाए तू लहरे फिर हो ना जुदा आए वादा रहा तू है वही दिल जिसे अपना कहा तू है जहाँ मैं हूँ वहाँ तो ये जीना तेरे बिन है जुदा ओ मेरा एक सनम दो लहरें की तरह फिर हो ना जुदा ये वादा रहा ये वादा रहा ये वादा रहा
आपकी फरमाइश।
आने से उसके आए बाहर, जान से उसके जाए बाहर, बड़ी मस्तानी है मेरी महबूबा, मेरी जिंदगानी है मेरी महबूबा। आने से उसके आए बाहर जाने से उसके जाए बाहर, बड़ी मस्तानी है मेरी महबूबा, मेरी जिंदगानी है मेरी महबूबा। गुनगुनाए ऐसे जैसे बजते हो घुंघरू कहीं पे, आके पर्वतों से जैसे गिरता हो झरना जमीन पे। झरनों की मौज है वो, मौजों की रवानी है मेरी महबूबा, मेरी जिंदगानी है मेरी महबूबा। बन सवर के निकले आए सावन का जब जब महीना, हर कोई ये समझे होगी वो कोई चंचल हसीना। पूछो तो कौन है वो, रुत ये सुहानी है मेरी महबूबा, मेरी जिंदगानी है मेरी महबूबा। महबूबा बड़ी मस्तानी है मेरी महबूबा, मेरी जिंदगानी है मेरी महबूबा।
अब अंतिम कुछ 2-3 गाने बस बचे हैं, तो वो सुन के जाइए और हम भी आप सबके साथ निकलेंगे फिर। तो बैठ जाइए जो उठ रहे हैं थोड़ी देर, और भूख ज्यादा लग रही हो तो जा सकते।
एक ना एक दिन ये तो मेरे सपनों की रानी बनेगी। एक ना एक दिन ये कहानी बनेगी, तो मेरे सपनों की रानी बनेगी। मैं तेरा दीवाना बनूंगा, जानी तू मेरी दीवानी बनेगी। एक ना एक दिन ये कहानी बनेगी, तू मेरे सपनों की रानी बनेगी। एक ना एक दिन ये कहानी बनेगी, तू मेरे सपनों की रानी बनेगी। चैन लूटा है, नींद लूटी है, ऐसे मौसम में हमसे रूठी है। चैन लूटा है, नींद लूटी है, ऐसे मौसम में हमसे रूठी है। तेरा मेरा नया नया मिलन है, ये मुलाकात पुरानी बनेगी। एक ना एक दिन ये कहानी बनेगी, तो मेरे सपनों की रानी बनेगी। मैं तेरा दीवाना बनूंगा, रानी तू मेरी दीवानी बनेगी। एक ना एक दिन ये कहानी बनेगी, तू मेरे सपनों की रानी बनेगी। तू मेरे सपनों की रानी बनेगी। तू मेरे सपनों की रानी बनेगी।
और अब जैसा कि मुझे आदेश हुआ है, ये आखिरी के बस 2 गीत हैं और आप लोगों ने इतने अच्छे से सुना, थैंक यू सो मच। एक बार जोरदार, क्योंकि अगर ऑडियंस अच्छी नहीं है तो आर्टिस्ट कुछ भी नहीं कर सकता। तो जब तक कान सेन नहीं होगा तब तक तानसेन का कोई दम नहीं। थैंक यू। तो आप सबको आज मैं यहाँ से आपकी इंजीनियरिंग की डिग्री के पहले एक पीएचडी देता हूँ। आप सब कान सेन हैं, तो अपने डिग्री के आगे कान सेन भी लगाइएगा। हो
हाय इशारों इशारों में दिल दीवाने बनाए, फिर तू सीखा कहाँ से।
निगाहों निगाहों में जादू चला, मेरी जान सीखा है तुमने जहाँ से। ओ मेरे दिल को तुम भा गए, मेरी क्या थी इसमें खता। मुझे किसने तड़पा दिया, यही थी वो जालिम अदा। हाँ, यही थी वो जालिम अदा। ये रांझा की बातें, ये मजनू के किस्से अलग तो नहीं है मेरी दास्तां से।
इशारों इशारों में दिल दीवाने बनाए, फिर तूने सीखा कहाँ। जो करती है वो जताती नहीं, धड़कने अपनी कभी किसी को सुना, किसी को सुनाते नहीं। मजा क्या रहा तब भी खुद अपनी जुबान से।
निगाहों निगाहों में जादू चलाया, मेरी जान सीखा है तुम जहाँ।
बताइए तूने सीखा कहाँ से।
मेरी जान सीखा है तुमने जहाँ। फाइनली आज की शाम का ये आखिरी गीत। हमें तो क्योंकि आप इतना अच्छा सुन रहे हैं तो हमें जाने का मन तो नहीं हो रहा है, लेकिन क्योंकि कुछ समय की भी अपनी पाबंदियां हैं, आई होप शायद आप भी ऐसा ही फील कर रहे हो जो इस गाने में हम आपके लिए कह रहे हैं। तो हो सकता है ऐसा हो, और ऐसा हो तो आपकी तालियां चाहो। पहले सुन तो लीजिए क्या क्या है। अभी न जाओ छोड़ कर के दिल अभी भरा नहीं, अभी ना जाओ छोड़ कर के दिल अभी भरा नहीं। अभी अभी तो आई हो, अभी अभी तो, अभी अभी तो आई हो, बाहर बन के छाई हो। हवा जरा महक तो ले, नजर जरा बहक तो ले, ये शाम ढल तो ले जरा, ये शाम ढल तो ले जरा, ये दिल संभल तो ले जरा। मैं थोड़ी देर की तो नशे के घूंट पी तो लूं, नशे के घूंट पी तो लूं। अभी तो कुछ कहा नहीं, अभी तो कुछ सुना नहीं, अभी ना जाओ छोड़ के दिल अभी भरा नहीं।
सितारे झिलमिलाते, सितारे झिलमिला उठे, चराग जगमगा उठे, बस जगमगा बस अपना मुझको रोकना, ना बढ़ के राह रोकना। मैं रुक गई थी तो जाना पाऊंगी कभी, यही कहोगे तुम सदा के, अभी नहीं बना जो खत्म हो किसी जगह, ये ऐसा सिलसिला नहीं।
अभी नहीं, अभी
नहीं 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 नहीं,
अधूरिया अधूरी आस छोड़ के, अधूरी प्यास छोड़ के, जो रोज यूं ही जाओगी तो किस तरह निभाओगी। कि जिंदगी की राह में जवां दिलों की चाह में कई मकाम आएंगे जो हमको आजमाएंगे। बुरा ना मानो बात का, ये प्यार है गिला नहीं।
हाँ यही कहोगे तुम सदा कि दिल अभी भरा नहीं।
दिल अभी भरा नहीं।
नहीं नहीं नहीं,
थैंक यू, थैंक यू। एक बार हमारी पूरी टीम के लिए जोरदार तालियां, क्योंकि हम गा तो रहे हैं लेकिन हमारा सपोर्ट जो है वो पीछे ये बहुत
इम्पोर्टेंट होगा, और हमारा साउंड जो आप तक पहुंचा रहे हैं, और खास तौर पे आप कान से इन लोग, थैंक यू सो मच, थैंक यू। टू बी वेरी फ्रैंक, हम थोड़ा सा डाउटफुल थे कि यूथ क्राउड है और पुराने गाने हैं, ये बिल्कुल सच बोल रहा हूँ, तो हमको थोड़ा था कि पता नहीं कैसे होगा, लेकिन जिस तरीके से आप लोगों ने रिसीव किया है, तो इससे एक चीज तो आज प्रूव हो गई कि अच्छा म्यूजिक जो है वो हर दौर में अच्छा रहता है। थैंक यू। और ये बात थोड़ा सा आज की फिल्म इंडस्ट्री को, अभी वाले लोगों को समझने की जरूरत है कि आप लोगों को अच्छे गाने चाहिए, करेक्ट? तो थैंक यू। जब तक आप जैसे श्रोता हैं तब तक अच्छा म्यूजिक तो जिंदा रहेगा। थैंक यू।